Hello friends, this video is about Introduction to C++ and this is the content. This much is enough to know about C++ in theory and we will see the practical throughout the course. So, object-oriented programming language. This is an object-oriented programming language. What makes it object-oriented programming language? These four things makes it object-oriented programming language: abstraction, encapsulation, inheritance, and polymorphism. So if any programming language having these four concepts, that is called object-oriented programming language. But this is not a pure object-oriented programming language, and the reason is we can code in C++ as we used to code in C, and we really don't need to write our code in object-oriented way. We can write it in functional way also, like you can call lots of function and make your work done. There is no need or no requirement actually for you to write everything in object-oriented form. So that's why it is not a pure object-oriented programming. Okay, it is an extension to C. I think everyone knows about that. So when C++ was created, it was not created from the scratch. It was taken from C. So everything was taken from C and additional things were added into C. Okay, now it's totally changed, but it is still the extension of C. And the creator of C++ is Behaviour, if I pronounce correctly. So he created C++ in Bell Lab, started the development in 1979, and first release was in 1983. It is not like you need to remember this. No one really asks in interviews or in exam, I guess, if they are not really in mood to kill you. So previously it was known as C with classes. So C++ was not named as C++ initially. It was C with classes first. Later it was changed to C++. Okay, and C++ is a statically typed language. What is statically typed language? You have to bind the data types with the variables, not the values. Okay, so you will first create the variable of some type and then you will start using that. Okay, so that is statically typed language. Another is free form. This free form is nothing but you can write programming like this also. You need not to give semicolon just after this T here. You can give any number of spaces in between these two lines. Then also this program will compile correctly. So those things comes under free form. There is no actual form of writing your code. Okay. And another is compiled language. What do I mean by compiled language? There are some languages you don't need to compile. And what is that compile here? So first of all, let's suppose you have written this code. Okay. Now, if you want to check whether it is really working or not, you cannot just directly tell this program that, okay, now you start running. No, you have to give some command so that computer will understand, okay, this is main function. Okay, fine. It will come inside. Okay, this is integer variable. Okay, I'm going to initialize 1 plus 2 into that. Okay, this is cout. Okay, this is an object inside this standard. Okay, fine. This syntax is also fine. Everything is fine when it will reach to this bracket, which is this end bracket, and it seems to be correct. There is no error in this whole code. Then it will say, okay, fine, you are good to go, and it will generate one extra file out of this file, and you will run that file, not this file. Okay, so that process, what is starting from this place and going to this place, is called compilation. Okay. And there are some languages, they will just directly start running, like they will start running from here and they will go to here, and if there are other lines, they will just directly start working on those lines and will start executing those lines, and whatever is written on those lines will start happening. But let's suppose there are hundreds of lines from 1 to 100, but there was some problem in 15 number line. So until unless it reaches to that error, it won't be knowing that there is some problem in this whole code. Okay, and generally those programming languages are called scripting languages. So this C++ is not a scripting language. Okay, so it is a compiled language. And another is general purpose language. This general purpose language makes this C++ very strong because you can write code for not only graphics, you can write code for almost anything in C++. Okay, we use C++ for gaming purpose, for application software development, for driver development, for firmware development. So there is no limit actually, okay? Because I can take so many names, but you won't be knowing that maybe if you are a beginner. And why people prefer C++ is that is the best beauty part of this C++, and that is the speed of execution. Generally, all the gaming engines are built on C++ because C++ gives object-oriented way of developing your program, which is really a faster way of developing bigger projects. And second thing is, it is really very fast in execution. And what do I mean by that? It means it has less overhead than other programming languages. It is built in that way. I'm not comparing any language here. This video is not about comparing the languages. I may create that in future. But I personally like C++ because it is really very fast. And when I was giving programming competitions, I was using this language only because it has almost everything for you and it runs really very fast. And I love this language. So this was the last point. So I think we are done here. I hope you like the video. Now let's look at the next video, which is about sample program in C++. So this you might not get because you might not be knowing what is this integer and all these things. What is this bracket, what is this return 0, what is this hash include IO stream and all that. So I'm explaining that in the next video, and from next video we'll start our C++ journey. So go ahead and start learning. I'll see you in the next video. Hello there, this is Rupesh and welcome to CPP Nuts video series on C++. In this video we'll learn about how to write a sample program in C++. So this is kind of a sample program. So let's try to understand this from this very first line of this program. Okay. So this line is including this IO stream header file. This is a header file somewhere in your computer. You are including that. So if you are absolute beginner, you will find it a little bit difficult to understand what is this inclusion and all these things are. But let's try to understand this in this way. If you want some functionality in your program, like this is Cout and this is used for giving output to your screen. So, and this is the message which will be displayed on screen. Okay. So you are using the functionality of giving the output to the user. So that functionality is available in this IO stream. So until unless you include this, you won't be able to use any of the functionality of this header. Okay. So let's suppose tomorrow you are in mood to make some string operation. You might include some another header file. Let's suppose another one is string. Okay. So this string is for processing the string in your computer. So if you are including this, then here you can process strings. Until unless you're including this string, you won't be able to process that. Okay. So it's that simple. You want something, include that. That's it. So that inclusion syntax is like this. This is hash include and then you give the name of the header file. Now the question comes, how would you know what file you need to include? So that comes with practice. Okay. So I'm there. Don't worry about that. So this was about this header file. Now let's talk about this using namespace std here. Using namespace is a command which includes libraries. So this std is nothing but a library name. This stands for standard, and this semicolon is mandatory in order to terminate any statement in your program. Okay. So this is statement you are terminating it with this. This is also a statement you are terminating it with this. So you have to terminate all the statement with this semicolon. Okay. But you might be thinking that why I'm not terminating this line with this semicolon and this line and this IO stream, because these lines are not the statement. They are not statement. Don't worry, you will get this statement thing very quickly. Okay. So what is this standard? As I told, this is a library. You can think of as your college library, like it has lots of books and lots of informations. So this std is also having a lots of informations in that. So we need those information in order to run our program here. Okay. For example, this Cout belongs to this std library. Actually, this is created in std library, but its declaration is there in this IO stream. That's why we are including this one as well as this one. Okay. This IO stream is nothing but input, output, stream. So this was about using namespace standard. Now let's talk about this line here. So first of all, we'll talk about this main here. this is a function. This whole thing is a function here, which is starting from this starting curly braces and ending it with this ending curly braces. Can you see that this is like opening and closing curly braces? And it is telling that the main function is starting here and ending here. Okay, and this main function returns integer. So it's like you are calling something and you are executing line by line. Once everything is done, you are returning something from here. So you need a data type, which is this integer. We all know what is integer data type, like 0, 1, 10, 1000. Okay, so that is integer. That's why we are writing this integer here. So this is a rule that main function should return integer from your program, and main should be only return one time in your whole program. Let's suppose you are having tons and tons of lines of code, but in that you will be having only one main function, then only your program will run. Otherwise it will tell there are more than one main functions. And why it should be one? Because your operating system search for this function only in order to start your program. Because you might be having thousands and thousands of lines of your code, and there won't be any way that from where you need to start. So that's why this main function was created. So everyone knows that, okay, there is this main function, I need to start from here. Okay, don't worry about this parenthesis for now. We'll see this later when we'll see how to call function and how to pass values in that. Okay, so for now it's enough to know this much about this main here. Let's talk about this line now. This cout is used for giving output to the system, and this is the way of doing that. You just leave this e and dl for now. We'll see this little later. This cout is an object residing in this standard library, and this is the way of giving output. This is stream insertion operator, and this is your character stream. So it is like you are inserting this stream into this cout, and this will show this to the screen. Okay, once we'll run this. So this is how it works. And next line is this return 0. We are returning from this main 0 because this is also a rule. If you are returning 0 from your main function, it means your whole execution was successful. So let's run this program and see how it looks like. So for running that, you go to this build here, come here, build and run. So press this. If you press this, it will show you this output here, hello my world. So this hello my world is coming as your output. So we'll recap quickly. This is the place where you include the functionalities, whatever the functionalities you want. Let's suppose you want to process audio or video, you will include some header files for that, and then you will be able to use those functionalities. Okay, here I am using functionality of giving output to the user. That's why I'm including this IO stream here. This IO stream is nothing but input output stream. Okay, and this one is including a library. You will pretty much write these two lines for almost all of your code, because you might be going for this cout, cin and all that. So this output will require this standard library and this IO stream header file, because this cout is written in this std library, and this is your main function. Your whole program will be in this. This is the name of your function, and this defines the start and the end of your function. You are writing whatever you will write, the statements will execute line by line. Okay, and at last you are returning 0. This 0 is of type integer, that's why you're writing integer here, and this is the rule, you have to write integer here, and that's it. So if you feel that it's like you have to remember IO stream, you have to remember using namespace std and all that, and you have to remember what is the syntax of this and all. Okay, yes, you have to remember it, but don't worry about that. Why? Because this is a language, and remember when you was kid, you was learning language without knowing the reason behind that. Whatever the language you was learning, your regional language, you almost remember everything. And we know languages are having so many words and so many grammatical stuff. Then also you know everything about your language. So this is also a language here, and it is not having that much big scope. Like in your language, you might be having thousands of words. This is having few hundreds. So you will start learning this language very quickly than your regional language. And learning some language always start with some mugging. So if you think you are mugging this program, don't worry about that. You will start making sense out of everything. Okay, so stay with me I'll make sure you're not having any problem in learning C++. So guys, this was your sample program video in C++. In next video, we will learn how to take input from the user and give output to the user. This is example of giving output to the user, but this is very basic example. We have lots of things to do with this. Okay, so I'll see you in the next video. Welcome back. This is Rupesh and you are watching CPP Nuts video series on C++. And in this video, we'll learn about how to take input from the user and give output to the user. So in short, we'll see input and output operation in C++ code. So this much you know because you have watched my previous video. So this is nothing but giving the output to the user. Okay. So this will come as the output. So let's go ahead and just quickly see that. See, let's suppose you're willing to give some another message like bingo dingo and compile this. Go and why there is this bingo dingo concatenated with this upper string? It's just because this cout work this way. It is taking input from here and pushing on the output string. So first it will take h I space t h e r e, like this. It will keep on taking and go up to this. Once it will reach there, it won't do anything. It will terminate this statement and go to the next statement. Next statement is also a cout statement. So it will start taking from here and pushing on the console. Okay, so it will start taking bingo and will start pushing in the same line. Okay, now you have to tell explicitly that I want to break the line. So for that the command is endl. Okay, if you'll write this, it will break. So let's check that. See, hi there, this is Rupesh and bingo dingo is coming in next line. Okay, it's not like you can use here only. You can use this end line anywhere in this line. Okay, you can use here also like endl and like this. But for that you have to tell that how much part of your statement is string and how much part is non-string. So this is string, then you're printing the next line, and this is string, then next line, then this is the string. Okay, so we'll see that. See, hi there is coming, then this end line is there, that's why it is going to the next line, and then it is printing this is Rupesh, and then again it is going to the next line, then it is coming in printing this bingo dingo. So this is how it works. Okay, so this was about how is endl work, which is nothing but and line. Now let's talk about how to take the input from the user. For that you have to create one variable. I know you might get confused what is variable, so let's just simply start with that. You will understand it. So this is the code to take the input from the user. Before, what you was doing, this was the syntax. Okay, so this was the syntax to take the output to the user. So this will be printed on the screen. Okay, so if you will remember it this way, that cout was the command to give the output, then cin is the command to take the input. Okay, and cout was taking input from computer, like hi there, this is the input, and going, see, it is going this way to the cout, but this cin is taking input from your user and giving it to number here. So there is this number thing extra, because you cannot just simply take value from user and put it somewhere. Somewhere is nowhere in your program. Okay, you have to explicitly take it and place it properly in your code. Okay, so if you are taking this number which is of integer type, then you have to give integer data type. Integer data type means 0, 1, 5, 10 and all that. Okay, you can give minus values also. So let's try to understand this number like this. This number is a variable which will store some value what you are giving as the input to the system. So where that value will go? We all are familiar about this name called RAM. Okay, it looks something like this. There will be so many slots. One of the slot would be there like this, and let's suppose you are giving number as 22 as input, then that 22 will go to the RAM, and that slot name is number here like this. Okay, so if you are creating a variable like this, then you are telling that I will be storing integer data type, which is nothing but 1, 10, minus 15 and all that in our computer. Okay, ultimately in our RAM. So what computer will do, computer will see that, okay, you want integer storage, okay, I will provide that. Then it will give this much of memory to your number variable, okay, where you can store your data. So it works like this. So let's go and take the input from the user. For that you will have to run this. So we'll run this. It is asking, now you put some value. See, your this statement is executed first, like hi there, then only it is asking for you to give some input. So it is standing here only. Until unless you will give some input, it won't go from here. So let's give some value 1, 2, 3 and hit enter. See, it has exited successfully. Now it is asking you to give some input, then it will go off. See, like this. So we successfully created space, then we give some value to that space and our program terminated. There is something missing, right? We didn't take the output, like we want to see what we gave as input, right? So you can take this number and give output, like how you are giving this hi there output, you can output this number as well. So let's go and compile this. See, it is asking for me to give some input. This time I will give 1, 2, 4, hit enter. See, this time you give input and it is showing you that as output also. So this is how you take the input from the user. It's not like you can only take the positive input, you can take negative input as well. So let's go ahead and run this again. Minus 12, hit enter. See, it is telling you you gave the minus 12 here. Okay, so this was about how to take number from the user. You can take string also. This is a string, character string. This is called character string in our computer programming languages. So for that you will have to use string data type. Okay, so for now remove this integer data type and we can use string, and as I told you can give any name. I will give str, which will tell that okay, it is just a simple string. Here we will write str and again str. Okay, so what we are doing, we are telling that this time I need a variable name str and its type would be string. Okay, so before it was integer, now we want string. Okay, so let's run this one and see the output. See, it is standing there waiting for your input. You can give input anything, bingo, and give enter. See, it is printing that bingo here. Okay, so it depends what type of input you want. You will create that type of data type and you will take that input using this cin into that, and whatever you want to do you can do with that. Okay, so I just forgot to show you one more case with that integer. You can perform any operation with that. So before it was like number and we were taking number and this was the print. Here while you are printing you can add any value. Okay, so let's run this and see how this will give the output. So run this. It is giving you the error. It is telling that your number name and this number name is equal, but this is not equal. This is some another number because this num and b is missing. Now it is okay. So let's go ahead and compile this again. See, it is waiting for my input. This time I will give 100, give enter. See, it is giving 110. So it is adding 10 into that. So you can do almost all the logical stuff, whatever comes in your mind. Okay, so we'll keep on learning stuff like this, and this is some theory part. If you are interested, you can note it down so that it will be a little easier for you to recap it. Okay, so we'll quickly recap the whole thing again what we learned here. If you want to take any input from the user, you will have to store it somewhere, and that depends what input you want to take from the user. If it is number type like integer and all, you will have to take that into the integer data type. If it is string, you will have to create the string data type. If it is in point, you have to create floating data type. That is a homework for you. Okay, just go ahead and search for float in your book and try to run program using that. Okay, and you can take the output also like this one. you are taking the output, you can perform any operation on variables like add, minus, multiplication, division and all that. Okay, so let's look at the division case here. Like if you will divide it with 10, what would be the output here? So let's give some value, suppose 30. It will divide it with 10, so the answer would be 3 here. See, so these things are possible in your programming. Actually this is very basic stuff. When you will see some advanced C++ program, you will enjoy a lot. You can enjoy, I know you will be enjoying this program also, because this is also like a magic only. So that's it. This was about how to take input and give output to the user. In next video we'll learn about variables and the data types in depth. So this was about how to take input and output. That's why I included this variable thing in here, because you cannot take input from the user without creating the variable. So in next video I will explain what is this variable in depth and what is this data type. Okay, because there are lots of data types. I will be covering almost all the data types, what C and C++, what C++ provides. Okay, so I'll see you in the next video. Welcome back. This is Rupesh and you're watching CP Peanuts video series on C++. Welcome to the quiz on C-in and C-out operator in C++. So this is a quiz time because that topic is little interesting and lots of questions comes in exam. Okay, sometimes it gets tricky. So I have these many points here for you. So let's discuss one by one. Okay, first look at this point. What do you think? What should be the output for this one? Let's compile this. So this is 1 plus 2 and this is 3. So it shows that if you are enclosing anything in between these two chords here, it will become string. Okay, so this is a string, but this is not the string. This 1 plus 2 is a expression here. Okay, so that expression will get evaluated and the result will be at this output stream. Okay, that's why you are getting this 1 plus 2 and 3. So this is the difference. Okay, now let's look at another one. So this is another one. Here we are having one string here and the same string we are printing with this single quote here. See, so what should be the output for this one? So people get confused much, like if I will put this single quote here, what would be the output? So let's clear that doubt as well. We'll run this and see, this is your output. So this first line is CP Peanuts. That's correct because we know how to print this CP Peanuts if it is string. But second is some garbage value here, 13162030 and all. Okay, it means you cannot print multiple characters using this single quote here. If I will print a single character, in that case it is okay. Let's check that. See, it is printing CP Peanuts and C, no problem. If you will print some another character, it will print that, no problem. Let's check that here. See, this CP Peanuts and M is coming. So what we understood from this, single quote is for single characters, this double quote is for multiple characters. Okay, so now let's look at another one. Here we are printing bingo and we are using this multiple semicolon. So whether it is going to compile or this is an error. Actually there is no problem in this because after this first semicolon everything is a empty statement. So empty statement doesn't create any problem. So let's check that. See, bingo, there is no problem. Okay, so if you will write like 4, 5 like this, and if you will compile, there is no issue in this. Okay, because this is a constant expression here and this is terminating with this semicolon. Okay, so there is no issue in this. If you will simply write it without terminating it, then it will create problem. Let's check that. See, it is telling expected semicolon before return. So it is messing with this whole thing. Now let's look at another one. So this is a string data type here. We are taking this string and we're going to print that. So it's very simple, you might be thinking, but we will take another example here which will show you something new here. So let's compile this and here we'll give some input like life is beautiful. Hit enter. Can you see something here? We was taking this life is beautiful in this string by using this C-in, but it only took the life here. So the rule is if you are taking string in your string variable with this C-in, it only take till the first white space or first enter or first tab and all that. Okay, so in short, it should not be an empty place. Okay, so if it is empty space, once you will write everything and hit enter, it will take only up to that empty space and push into this str variable here. Okay, that's what you saw here. So how to deal with this problem? Actually, you don't know what is functions and all, so it will be little bit hard for you to understand this, but still I will show you that what is the way of doing this. So there is some function called getLine, and the format of that is this one. First parameter of this would be this basic stream of characters, and another one would be your string data type. So here it should be an cin, and this one is your variable. That's it. So now if you will run this code, it will show you that it is taking the full line, like life is beautiful. Hit enter. See, it is taking life is beautiful and giving you into this str. So ultimately what is happening here, you are invoking a function and passing these two as parameter, and that function's job is whatever is coming in this cin option, it will take the whole line, this whole line, and push that line into this str. Okay, so that's the specific job of this function. Okay, so now let's look at the next one. So this is another example of taking this integer variable and pushing 3 numbers in that. So that number could be anything, whatever is in between the range of this integer data type. Okay, so here you might be saying something new, like you are taking 3 numbers in one row. Okay, so yes, it is possible how this cout can take number of inputs, cin also can take number of inputs. Okay, so let's run this. So it is asking me to enter some numbers, like 1, I will give 1, 2, and then hit enter, and 5, 6, and enter, and then 8 and 9, and then enter. So see, it is taking 3 numbers, and after that it is printing that. So 12 is printed, 56 is printed, and 89 is also printed here. Okay, but there is no space in between these two, that's why it is concatenated with each other. So if we will give the spaces here, like this one space, and here another space. So let's compile this again. So this time we will give 2, 3, 4, and yeah, you can give space also, so there won't be an issue if you are giving spaces. 2, 3, 4, 3, 4, 5, 90, and space 90. Hit enter, it will take that value and give as it is. Okay, so multiple inputs are also possible in cin and cout both. So I think I'm done here. If you think you have some doubt, you can comment out in comment section. Otherwise, let's look at the next video. Hello there, this is Rupesh and you're watching CPP Nuts video series on C++, and in this video we'll be learning about comments in your program. So what is the comments? So we know how to print something, like if you will print it like I love C++, and in next line you might be printing like this is good language. Okay, so if you will go and print this, it will print these 2 lines. Okay, there is no problem in this. But let's suppose you want to comment this out, like if you don't want this line to get printed, either you remove it like this one, then only this will not get printed, right? But there is another way. Instead of removing this line, you can just do it like this. So this 2 times / will make this as comment. Okay, so if you will run this program now, only 1 line will get executed. This is considered as comment, and your program does not include that as a statement. It thinks like user is giving some message to the person whoever is reading your program. That's why it is called comment. Okay, because whenever we write very big programs, it becomes very confusing when someone else is looking at your program, because sometimes what happens, you have given some statement for some reason, but someone else is looking at your statement and they are thinking something else. So it is really very useful when you write a comment about your statement, like what this statement is doing. Okay, so you might be writing it like c is equal to x into x, plus 34 and minus y into x. Okay, so what is the meaning of this statement here? If someone would look it, they won't be able to understand it. But let's suppose you have found some new formula, and this is some formula like bingo formula. Okay, so you will write it like bingo, so someone will understand, okay, this is the bingo formula. Okay, so it's like that. You give some comment for something. Okay, so this is executable, but this is not executable because you have given into the comment. But what if you want to give lots of lines as comment, like bingo here, and you are keep on writing something like this, and you want this whole thing as a comment? So there is another way of doing that, which is like forward slash, hit this star button here, and then star, and then forward slash. Okay, so whatever is coming in between these two stars will become comment. Okay, so this is also a way of keeping comment, and this is also a way. So this we generally use when you want to make so many lines as comment. Okay, so this is the way. So whatever will come in between these two stars will get commented and will not going to execute. Okay, so this was about comment and why we use that. Okay, so I'll see you in the next video. Bye bye. Welcome back. This is Rupesh and you are watching CPP Nuts video series on C++. So in this video we'll be learning about what is escape sequence in C++. Escape sequence is used for string formatting and structuring. So let's see how it helps us in order to achieve string formatting in our code. Now suppose we want to print something like this. I love C++. Okay, but I want this love C++ come in next line, because if you will print this, let's go and run this one. So if you will run this, you will see this I love C++ in one line. Okay, so if I want to see love C++ in next line, what should I do here? Keeping it like this won't work. Okay, so it's not like you will do it like this and it will start working. No, this is an error. You cannot do like that. Okay, there are different ways of doing that. So one of them is like this. You write 2 times and print that. Okay, so this is also one of the way. Or let's suppose you don't want to write this cout 2 times, then in that case just write it like this. Okay, so in that case also I will come in one line and love C++ will come in next line. We can check that. See, I is coming here and love C++ is coming here. Don't you think you are writing too much to achieve very small thing? So let's try to use an escape sequence, which is new line escape sequence, which is written like this. That would make your life little easier. So this is an escape sequence here. Okay, so how this whole thing will work, we'll see that. So let's go and compile this. See, I is coming in one line, this space and love C++ is coming in next line. So how this whole thing is working, it is taking this I first, this cout is taking this I first, and then after that this space. Once it is encountered with this backward slash, it will get alert and it will check the next character. What is that? And it is n. So it will understand, okay, this is new line escape sequence. So it will print rest of the characters in new line. That's the job of this escape sequence, new line escape sequence. There is this tab sequence available. If you will write T here, it will give a tab. Okay, so we will compile and run that also. See, I is coming here and there is one tab and love C++ is there. Okay, so escape sequences work like that. And there are other escape sequence other than this n here. So let's check that out. Okay, so these are the escape sequence available here. So I have showed you this n, which is this new line, and this tab here. We can check this backspace also. This here we will write only B. So what this backspace will do? Backspace will remove one character, whatever is coming just above this. So that space is there, it will remove that space. Okay, so let's check that. See, we are having 2 space after this. Now it is giving only one space. Actually it is making confusion, so I will remove one of the space here. See, now it is removing this space, so it is printing like I love C++ without this space in between. If you will remove this one, if you will keep it like this, only love C++ will come. See, love C++. Okay, so these are the role of escape sequence. Let's suppose you want to print this backslash. How would you do that? Because that backslash is taken as some special input in your program, so it is not printing here, it is conveying some meaning. But what if you want to print that? Let's suppose you want to print some message like this is backslash and you want to print this. Okay, so how would you do that? Let's try to compile this program. It won't compile because if you are using this backward slash, it tells to the compiler that the very next character to this is some special character and this is a escape sequence. Okay, so this backward slash has some meaning. So if you want to print this, you will have to give 2 times backslash. See here, if you will give 2 times backslash, then only it will print backslash. Okay, so let's check this out. Compile it. See, this is backslash and it is printing that backslash. Got it? Did you notice that you are enclosing this string, whatever you want to print, in these double quotes? Okay, then only it is considered as your input string in your cout. But what if you want to print this double quote here? If you will write like this, then it will consider like this is back as one string and rest of that is another thing. So this is not going to compile. Okay, so if you want to print this, the solution is that only. You will have to give this backslash here. Okay, then only you can print this. Let's run this. See, it is coming like this is back and this backslash symbol is also coming here. Okay, otherwise it won't compile. See, if you will remove this, if you will compile this, it is showing that error. It is telling that there is some missing terminating character, this one, because it is thinking this is the start and this is the end pair. So this is one pair and this is also one character, double quote character here, but there is no other double quote pair to finish this. Okay, so that's why it is error. Don't worry, this thing comes under string operations and I will create another video for string operations because there are lots of string operations and we should be knowing that in order to change the string in very simple form. Okay, you will be writing very small code and you will be able to achieve very big thing using string operations. Okay, and that is very important. So we are done here. I'll see you in the next video. Welcome back. This is Rupesh and you are watching CPP Nuts video series on C++. In this video we will be learning two things. First is data type, this one, and another one is variable, these things. Okay, so let's try to understand what is this data type here. So as you can see, we are having these different data. So this 1, 2, 3, 4 and all that is integer data type. We all know that. Okay, and this A, B, C, D and all that is character data type. And another one is 1.5 and 2.6 and all that is float data type or double data type. Okay, so in computers also, if you want to store some value, you have to give specific data type for that. Let's see, if you are storing this 10 here, this is nothing but your integer data type. So you are creating a variable which is taking this value and storing inside it, and that variable is of type integer. So this is the whole key. Like if you want to store some value, what is the data type of that value? If it is point like this one 10,000.0, then this is a floating point number. So either you will store this number into this float data type or in double data type. And the reason for having two data type for storing same type of data is this float can store up to some limit only. Like this can store only smaller values in points, but this double is capable of storing very big number. Okay, so you can see that we are storing this character here in this variable called C. This could be anything, like you can keep it CH is equal to A, like this. Okay, so for simplicity I have given only very small names here. So I think it's clear, like if you want to store this data, you will be creating variable with integer data type and you will store this data in that. If you want character data like this A here, you will be creating character data type variable and you will store that data in that. Okay, so this whole thing is a data and this part is data type. Okay, so it's very simple. So this was about data type. Now let's talk about this variable in depth. So I'll remove this everything here. As I told you, you can create variable of data types like this one. So let's try to understand it little more deeply. Variable is nothing but a place in the memory. And what is that memory? Your RAM. Okay, so let's suppose you are having this RAM here, and in RAM you will store A like this. So it has stored in RAM. You will be having some address like 01026. It depends how much big your RAM is. It will start from 0 and end. And in middle we are storing that A somewhere in your RAM. Okay. This is RAM, this is the value, and this is the address to get this value in your RAM. Actually it works like this. There is 1 byte in your RAM. If you want to store some data into that, you store some data and you note down that where did I place that data. This is the address, and next time if you want that data, you come to that address and take that data. Okay, so it works this way. Now let's see what is this C here. So it is nothing but a place name. See, if it is like 1 2 6 8 and 2 3 4 6 like this, and you are having different data like C and B here, it will be tough for you to remember that number. Okay, that's why we started giving friendly name, and there is some conversion in your program that convert this name and find the address of that and go to the value portion and fetch it and use that. Okay, it looks something like this. This is the place where your value is stored like A. This is the name of that place. Okay, and there is this address like 01126. Okay, so this is how we understand this variable thing here. Okay, and now let's talk about how to give your variable name. Here I have given C, V, X, F. These things are bad practice because there is no meaning associated with this name. So if you will create some variable, then it should have some meaning. Okay, like if you are creating this integer here, then X is not telling anything, like what is the significance of this variable. So if you will create it like integer and like number, number is equal to 10. Okay, so this is telling that this is some number and it has some significance, but this X is just X. Okay, so this is a bad practice. We should not create variables like this. We should give the proper name so that if someone is looking your program, they can understand that okay, why did you create this variable. Okay, so give meaningful name to your variable. That's it. And there are some restrictions. You cannot just create your variable. So we'll see first what are those restrictions on creating variable name. So the first restriction is you cannot make it more than 255 character. Like if you are creating like class FD something like this, this whole number should not increase more than 255. Okay, if it is increasing 255, then there is a error. Okay, so actually no one goes till that limit, but it is still the limitation. So the second limitation is you must begin with letter or underscore. Okay, so this is letter, a character. Okay, or you can create it with underscore also, this one, but you cannot write like 1_c. No, this is not the proper way of writing a variable. Okay, if you will try to compile this code, it will tell you the error. Okay, and third point is after first character it can contain numbers. So this character is first character. If you will write C1, then that is valid name. And fourth point is special symbols are not allowed in variable name. Okay, and space is also not allowed. You cannot make like C space C. No, there are two different variables here then. and it is case sensitive. It means if you are creating this character C here, and let's suppose you are creating another variable with this capital C is equal to some another character, then it works. It means these two variables are different variables. Okay, and the last one is there are few keywords you cannot use as variable. Okay, this blue stuff whatever is looking here is keyword like integer. It is data type name. You cannot create your variable with integer name like character integer. No, if you want you can type full name like this, then there is no issue, but you cannot keep it like integer, you cannot keep it like character here, bool, integer, float, double. Okay, these things are reserved keywords, they have meaning associated with them, so you cannot use as the variable. Okay, so this was about restriction part in variable names. Okay, so if I will print something like here cout, we all know how to print something. So if I'll print small c here, it will print a here. So let's check that. See, it is printing a here. Okay, so similar to this one, if you will print this capital C, it will print R. So let's check that also. Capital C, run that again. See, first is A, second one is R. So like that it work. We can print this X as well, like this one. We will print that. See, 10 is coming. Okay, and if you will plus some value like 19, so it will add that value with this 19 here. So if we will run that, it will give the added value like this one, 29. Okay, so it is clearly showing that it is storing some value like this one, and you can use that variable wherever you want to use that. Okay, variables are having very big role in our programming, and this is not very hard part to understand. Okay, we can do lots of stuff with this variables. Let's try to do some manipulation here. It will be very easy for you to understand this. So let's suppose you are having this integer variable x here, and you are storing 10 into that, and we have some operation, okay, like printing that. So we'll print it. We know it will print 10 only. Let's do some operation like x is equal to x plus 10. Okay, then what it is doing, it is taking 10 and adding another 10 and pushing that 20 in that x again. Okay, so if you will print it, it will print 20 this time. Okay, let's just check that out. See, first is 10, another one is 20 here. Okay, so this is how you can manipulate your variables and work with them. Okay, and if you have got some book, you will see that in variable section it has some specific size, like this is integer data type, so it can store maximum up to some number. Okay, and if it is character, it can store up to some number. If it is float and double, it can store up to some number. So that is theory part. There is nothing to understand anything in that. So this was variable. Now let's create a constant variable. So if you want to make a constant variable, you just type const here. Now this variable has become constant. So what is the meaning of constant variable here? If you are creating constant variable in your program, once you have assigned some value, later on you are not able to change that. See, here we were changing it and we were getting some value like 10 and 20, but now if I will compile this, this program will tell some error. Okay, so let's try to recompile this and see the error here. See, it is telling that there is some error in this line because you are going to change it. And where is the error message here? And see, this is your error message. It is telling that assignment of read-only variable x. Okay, so if it is not visible, I will take this up here. See this one. Okay, so if you don't want this error, you just don't assign anything to this variable. And why we create constant variable? We want to store some value and you don't want that variable to change in future. Okay, so that's why we create those variables. So this was about variables and data types. So if you have any doubt, please comment. Otherwise, let's check out the next video, which is about escape sequence in C++. So I'll see you in the next video.
Hello friends, this is Rupesh and you're watching CPP Nut video series on C++, and in this video we'll be learning reference data members in C++. So before watching this video, you must be knowing what is a reference variable. If you don't know, I'll give you some hint here. If you have some variable x is equal to 10, and if you want to create a reference variable of this x, if you want to refer x, then you will write something like this. R is equal to x. That's it. Now, x and r both are pointing to the same memory location. You must be knowing that if you're creating a variable, it will have its own memory. But you're creating another variable, but this is a reference variable, so it will refer this variable. It won't have any memory for this one. And it cannot be null and all those things. If you want to know much about reference variable, please go ahead and watch reference variable video in my video series. And if you know that, let's continue this. So before this video, we saw a constant data member, and you saw that you have to use initializer list to create that, initialize that. So here also we'll use the initializer list. That is the only way you can initialize reference data members. So I'll create some reference here. Let's call it x, and let's write some constructor base, and inside this constructor you want to initialize this x here. So this reference a will come here, and x and a. That's it. You're done now. And let's create some base b and pass this val, and let's create this val is equal to 10. And now if you will print this b dot print, and let's give this function here, void print, inside this just print x. That's it. Now let's compile this and check this. See, you're getting 10. So what you're doing is you have this variable val outside your class. Now you're passing this variable as a reference and getting it here as a reference. This is very important. Don't miss this part here. This has to be reference. Otherwise it will not work. Because it's obvious, right? Because you're passing this val as a reference here, and this you're assigning as this one the reference. So this is also referring this value, and this x is also going to refer this value. And it's pretty clean that if you will not take this value as reference here, then this 10 will be passed here, and a will be referenced here. X will refer a, not value. So you have to pass this as reference. Don't forget that. And this is how you achieve doing this. So you have this reference variable which is referring val. Okay, and here comes the fun part. Even if this is private, you can change it without base knowledge. So as I'm printing this 10 here, let's see that again. The answer is 10. Now if I'm changing this val to 20 and b dot print again, this will have the different value. See, 20. But this x, this x is a private member, but still you can change it from outside, because even if it is private, it is referring this variable, correct? So you can change this variable without any problem, and you ultimately having the new value here. So this is how you do this. So this much video is for the newcomers. Like if you are learning C++ first time and you are following my series, then you should stop here, because now I'm going to talk about these points which you may not understand, but you can still choose to watch full video, right? So it's up to you. Don't tell me that you didn't understand this and that. So as this notes is for experienced people. Now let's talk about the first one. I might have missed few points. So if you know more than this, please comment. It will be a good fun. So the first point is use reference when you are okay with your data member can be changed without your knowledge. Without base knowledge. As you saw here, you end up changing this x and it is working fine, which is ultimately breaking the encapsulation rule here. But as it is always said, if you know what you're doing, then it is not breaking any law. So it's you who is creating this, and if you know what you're doing, there is no problem. So the first point you saw here. Now let's look at the second point. Use when you don't need to implement assignment operator in your class. This is a restriction here. Yes, it is a restriction. The thing is, you cannot create a assignment operator. Let me just give you a proof of this one. So base reference operator is equal to, and here const base ref object, and now if you want to assign this obj with your x, and this should return this one. Okay, so now this is perfect code for your assignment operator, and if you'll compile this, you won't get any error. See, you will not get any error, but if you will use it, you will get the error. I mean, not exactly the error, the what to say, actually when you use this one, you always mean to say that now this x should refer this x. Okay, this is what you are going to tell. Okay, so if, let me just write here, base b2 and b2 need to be initialized with b here, which is coming from this top. So if you will do this, you are ultimately willing to say that this b2 should refer this VAL. Okay, but it won't refer this VAL. And yeah, and one more thing, I have to give this default constructor, and this default constructor is a problem for you, because if you have reference, then you have to initialize that reference variable anywhere in the construction. Okay, so if you are not initializing, this will give you an error. So let's just check that. See, uninitialized reference member in this one. So you cannot have this kind of constructor. You have to initialize this anyhow. Okay, so if you are initializing this, it means you cannot use this one. Okay, so if you cannot use this one, you cannot construct empty object like this one. I mean the default object which is not having any value. See, B was having this VAL, so B2 have to have something. Okay, so that something could be a new VAL1 which is holding maybe 30. So you can write VAL1 here, or the previous VAL, whatever it is. I mean it should be a new or old variable which you can pass here as a reference. Okay, then this will make sense, and now the meaning of this one will change. Now the meaning will become like, you want to initialize B into B2, and as this B2 is pointing VAL, now you want to change this VAL with whatever is there inside B. So it will be a good practice. I mean example, if I will make it VAL20, no 20 is used, 30, and if you are passing this VAL1 here, now this B2 will refer VAL1 and B is referring VAL. Okay, so now if you are assigning B to B2, you are ultimately changing this VAL1, and we can check that here. Just print VAL1 and our doubt will be clear. Let's compile this. See, you created B2, VAL1 which was holding 30 was assigned to X of B2, but later you changed this with this B, and B was referring to this VAL which later happened to be this 20, so you got 20 in this VAL1. Okay, maybe it is little tricky, but if you will rewind this video and watch this again, you may get this point quite easily. So this was about this second point. Maybe I am stretching this video a little more, no problem. So third is, if okay with the contained object is not owned by the containing object, and thus their lifetimes are not bound. Yes, obviously. Let's suppose what is happening here, the lifetime of this VAL is, let me just remove all these things. Now what I'm trying to tell you is, B get destroyed. Before that, if VAL will get destroyed, then there is a problem. So you must be sure and you must be okay with this constraint that VAL will not get destroyed or VAL's scope will not go off before this B. Then only it makes sense. Otherwise, B will be referring VAL and VAL has gone. So this is a problem, right? So if you want to see that, how to show you, maybe it not be a good practice or good idea to show this, but it should work. So this is like this, and now you're passing this value here, and let me just compile this. Yeah, it's working. So what I'm trying to tell you is, let's just print this. Now I have a print function here, b dot print, which will print this. Let's run this. See, you have 10 now. Now you just delete this VAL, and now again try to print this b dot print, and let's see what will happen. See, boom, correct? So you have this pointer, you are referring to this pointer here. Actually, you're not referring to the pointer, you are referring to the address what it is holding, and that address is going off here. So that's why second print is a garbage print. Okay, so this is a dangerous situation. If you're not sure that VAL will not get destroyed or its scope will not go off, then only you use this kind of thing here. Okay, so that was our third point, I guess. Yeah. So fourth is, you need to ensure that the referred object is guaranteed to exist till your class object exists. Yeah, actually this is talking about the third point only. So you need to be very sure that B is going first, then this is going. Okay, so you saw that here, and I don't see any point left here. So let's summarize this video by saying that you should use reference data member when you want to have some dependency, because B is of no use. I mean, this base object B has no use if VAL is gone. Okay, so this VAL is some another entity which is coming outside from your class and getting assigned here. So in case if this is destroyed or no longer exists, then your B is totally waste. So this is like a dependency injection. You must have this before this, and since this is alive, this should be alive. Okay, so if you want to achieve some kind of dependency like this in your program, you can go for this one, because this will directly give you the message. If you are using this reference data member, if someone is looking at your code, they can tell you that okay, you are injecting this dependency. And I tried to find some another use of this, but I couldn't get much, because people are talking about this with their own experiences and no one has come up with the proper use of this. Okay, and this is my feeling for this particular variable, what should be the use of this. Okay, so I think we are done here. If you like the video, don't forget to hit the like button, and if you haven't subscribed yet, go for it. It would help you and me both a lot, because I'll be uploading videos like this quite often. So I'll see you in the next video. Bye bye.
Welcome back. This is Rupesh and you are watching CP Peanuts video series on C++. And in this video, we'll learn about something called arrays. So the first question comes in mind is, why we use array? So before we saw that we were creating variables, that variable was able to store only one value like 10 or 15. But what if you want to store lots of values? So there comes this arrays. Okay. So we'll learn few things about arrays, how to create them, how to initialize them, and how to get value and set value from array. Okay, so let's start it. So first point was how to create array. So for that you need two things. One, data type of that array, like what type of data it will store. Is it going to store number? Is it going to store characters or what? So let's suppose you want to store number. So this is the data type of that array, and you need to give name of that array, like what name you want to give. So let's suppose we are giving here some number, and size of the array, like what size you want your array to be, like how many numbers you want to store. Let's suppose you want to store 5 numbers. So you are done here. This is creating an array of 5 size. So actually it is something like this. As the size is 5 here, there will be 5 places where you can store the elements. Okay, so 1, 2, 3 and 4. So these 5 places you can store numbers, so any number can come here. Okay, so before you was creating variables like integer var is equal to, let's suppose, 10. So this var was storing only one number. If you will change something in var, this 10 will get changed. Okay, so the point is var can store only one value at a time, but this number array can store 5 values at a time. Okay, so what we understood is this is the type of the array. So this is type, and this thing is name of the array. Okay, so you cannot create any array without giving name, and this part is the size of the array. This can be very big number like 1000, 10,000, 1 lakh or something. Okay, so this is a size. So now you understood that how to create an array here. Okay, now we'll see how to insert values in that. So first thing is we'll try to initialize this array when we are creating them. So the way of doing that is like this: 1, 2, 3, 4 and 5. Okay, so this would look like this. There will be an array of 5 size 1, 2, 3, 4 and 5. And there is another way, like you don't need to specify the size if you are initializing them initially when you are creating that. Okay, because it is obvious that if you are initializing 1, 2, 3, 4, 5, which is of total 5 elements, the size would be 5. So no need to write that actually. Okay, you can keep this empty also. So this is the structure of creating an array and initializing it with numbers. Okay, now we'll see how to access these numbers. Let's suppose you want to print this 1 or 2 or 3. How would you access that? So we will access it like this. We will give name of the array. So your computer will always look in this array. Okay, oh, this is number, not number. You guys might be shouting like anything, right? I know that. No problem. So yeah, we were talking about how to access these elements. So if you want to access these elements, there has to be some indexing, right? Like I want at this location number, I want whatever is there at this location, I want whatever is there at this location. So something has to be there, right? So that something is called indexing. So let's try to understand it this way, like it contains 0, 1, 2, 3 and 4. So this 0th location contain 1, 1 location contain 2, 2 location contain 3. Okay, so remember, always indexing start with 0, and if it is starting with 0, it will always go 1 minus than the actual size. So the actual size is 5, so it is going till 4 because it is starting from 0. Okay, now let's print that. So in order to print this 2, as I told, this 2 is at this one location, you will have to give one location here. Okay, so this is the syntax of printing something. So let's go ahead and print this. See, this 2 is coming here. Okay, so if you want, let's suppose this 5, you will be giving 4 here. Okay, so let's check this one also. See, 5 is coming here. So this is how you access the elements in the array. But what if you want to change whatever the value is there at some location, like this 5, you don't want this 5 to be there, you want 10. Okay, so once you have initialized it, how would you change that? So there is a way of doing that. It is very easy. How you was doing it, like number, and you was giving the place, what place you want to change, and just initialize whatever you want. See, you want 10 at this location, and simply you are assigning it into this location. Okay, so if you will again print it like number 4 location, you will see here it is printing 5 because you created it here and you are printing after this. So it is 5 up to this line, okay. But once you will change in next line and again you will print the same location, it will print 10. Let's check that. See, it is printing 5 and then 10, but I am not giving next line here, that's why it is messing up. So let's give that also. See, in one line it is giving 5, another line it is giving 10, okay. So this is how you can change the values. So if you want to change values at 0th location, you can put value at 0 location. So just need to do it like this, compiling and see. 1 was there at 0th location, but you change that 1 by 10 and you are printing that 0th location here, so that 10 is coming, okay. So it is that simple. So here we learn how to create array and how to initialize them like this and how to set and get the values from that, okay. In next video I have created a quiz video of arrays. So in that I will show you the boundary cases of arrays, like what if you are writing like 5 here, I want 5 size, and if you will create like very big array, okay. So what would be the situation there? And there are lots of things to discuss, not only this, otherwise I would have discussed it here only. So if you want to learn tricky part in arrays, watch out my next video. So I'll see you in the next video. Welcome back. This is Rupesh and you are watching CBBNet's video series on C++. This video is about quiz on arrays. Okay, so I have these points here. We'll be looking at them line by line. Okay, so let's start it. So the first point is it possible that you are giving larger size but initializing less values in that? Yes, it is possible and there is no problem in that. Actually, it would look something like this. If you will have this number here, there will be an array, let's say 0 to 10. So the last index would be 9 here, okay, and there will be total 10 boxes so that you can insert your values in these, okay. So it would be like this: 1, 2, 3, 4, 5, and rest of them will be filled with zeros, okay. So for your surety I can show you that. So if you will print this number, we all know how to print numbers here, right? So this is at 0th location, 1, 2, 3, 4. So 5 to 9 location is empty. You want to print 8 location here. So what would be the answer for that? So let's go ahead and check that. See, it is giving you 0 here. And the similar way you can print for others also, like number. So we can see here that we are printing from 0 to 9 here. Make sure I'm not missing anything. 5, 6, 7, 8, 9. Yeah. So from 0 to 9, as you can see here, from 0 to 9, we'll be printing all these values. So it should be like 1, 2, 3, 4, 5, and rest should be 0. So let's check that. See, it is telling 1, 2, 3, 4, 5, and rest are zeros. So what we understood from this, if you are giving more size and initializing with less values, remaining portions are getting 0 automatically. Okay. So this was first point. Now this is another point. Here you can see you are giving 10 as a size, but you are inserting till 11. Okay. So this is overflow. So you are telling that I will be creating till 10, but you are inserting more than this. So what should happen in this case? Let's check that. This is telling the error. Whenever this red comes, it tells that there is an error in this line, and it is telling that too many initializers for integer 10. Okay, so it is telling that in this array you are initializing too many values. Okay, so this was about second point. This is your another point. Can you write it like 3 and number like this? Remember when we were printing it like this, 3. Okay, but not like this here. Okay, this is not allowed. If you will compile this, it will give you an error. It is telling that line number, this one has error. Okay, so you cannot put it before that. Okay, but there is one interesting thing you can do. Okay, so let's see that now. You can put this inside the bracket like this, and you can view value outside like this one, 4 and number. There is no problem in this. Let's check this. See, 5 is coming as the answer. At 4 location, 5 is only there. Okay, see. So how come this 4 number is equal to number 4? So actually it is like 4 number is equal to number 4. Why these two things are equal? Actually the reason is whenever you write either like this or like this, compiler change it in its own way, and that way is something like this. Don't get confused much. Okay, it is like this. So whatever type you are writing, either you are writing it like this or this, compiler will convert both into this form, and compiler understands this very well. It is like number plus 4. So this number is pointing at the 0th location here. Okay, this location. So if you will give plus 4, so it will go like this: plus 0 location, plus 1 location, plus 2 location, plus 3 location, and 4 location. So it will choose this 5 here. Okay, so it traverses like this, and this is the syntax of doing that. Actually you can also write it like this. So let's try to run that also. We'll remove this and we'll place this here and we'll try to run that. So let's try that. See, again the answer is 5 here only. Okay, so this is also a syntax, and it is not like you cannot write this 4 here. Actually you can write 4 here and number here, then also it will work. Let's see that. See, it is working. Okay, so these are some tricky parts of your arrays what generally students don't know, and you can tell your friends also about all these. He or she will be very happy to know about this. But I wanted to clear one more thing, like what is this initial thing here? Actually this is the index part. Okay, 0 to 9. We know very well that how to access this. So this is called index. This 4 is an index and this is a value part. Okay, so this is how 4 is the index and this is the value part. Okay, but did you notice how that number plus 4 thing is working? Actually this number is nothing but a address in your RAM. Okay, so we all know what is RAM in our computer: 1 GB, 2 GB, 4 GB and all that. So it is nothing but a storage. So it will store like 1, 2, 3, 4. Let's suppose it is storing something like 1 here and 2 here and all the way till end, and this is some address. Let's suppose 0192. Okay, now if this location is having this as address, then this location will be having this address plus 1. It is very obvious, right? So this address would be 0193, and just after this address, let's suppose there is another value, let's suppose 3, then that address would be 0194. Okay, so this is how this 4 plus number thing is working. You are telling that I want this address plus 4th location. So as I told you, this number is an address, so we can check that. If you will just simply print number here like this, you will get some address. Okay, let's check that. See, this 5 is there because we are printing this, and this another line is having some number. See, 0x28ff08. So this is the address in your RAM. There must be some value in that address. Okay, so assume this is some address because I cannot know what address it will take. Okay, so this number is representing some address. Okay, so here we can assume like this number is nothing but some address like 0x112ff and C. Okay, so this address is nothing but your first location. Okay, this location. Don't get confused. Understand it like this. Your array name is not just simple your array name. It is an address in the memory like this. let's create another array here because that is getting a little messy. 0, 1, 2, 3. Let's make it 10. 0, 1, 2, and 3. Let's suppose this is some array like integer number 4. Okay. So there will be some address like 0 cross 29. Let's suppose this is the address. Okay. So this number is representing this 29. If you will plus 0 in this, you will be standing at this location only. But if you will plus 1, like 29 will become 30, so you will be pointing at this location. 2, then it will become 31. If you will add 3, then it will become 33. Okay? Sorry, 32. So it will work like this. So if you are adding 0, it is remaining at this location only. That's why it is called that array name contains the first memory location's address. That's how we understand it. Okay? And that is the only reason this thing is working. So as we saw here, this number is some address, and if you plus 4, it will go 4th location. So this is 0th location, 1, 2, and 3 and 4. So that's why it was printing 5 here. Okay? See this 5 here. Okay? And second line is address of this one. Okay? So don't worry that these things are very abstract in your mind. This is a programming language. It will take little time. Okay? So be with me, and if you have any doubt, comment. I will surely reply. Okay? I'll see you in the next video. Welcome back. This is Rupesh and you're watching CPP Nuts video series on C++. And in this video, we'll be learning about 2D arrays. So in previous video, we saw how to deal with 1D array. So if you have not watched my previous video, please go and watch the previous video first. So 2D array, so actually it would be like this, and your matrix name and the size. So this is how you give the size. Okay. First I'll write everything, then I will start explaining here. Okay. So if you will write it like this, it is telling you that there are 3 rows, 1, 2, and 3 columns, 1, 2, and 3. Okay. So this 3 is for rows and this is for column. Okay. So always remember, this is for row and this is for column here. So 3 rows. So this is 1 row, this is 2nd row, and this is 3rd row. 3 columns. This is 1st column, this is 2nd column, and this is going to be a 3rd column. Okay. So this is C, C, C. This is R, R, and R. Okay. So 0, 1, 2, and 0, 1, and 2 here. Got it? Let's try something different. Now we'll create 3 cross 2. So instead of 3 columns, we'll be having only 2 columns. So that would look like this. So 1, 2, 4, 5, 7, 6. Okay. And yes, notice this, you are creating integer 2D array. So that's why I'm putting this 1, 2, 4, 5 and all that. Okay. If we would have created something, let's suppose character here, like character, I would have kept it like A. Okay. Something like this. Because it depends what type of matrix you want to create. Okay. So this is a character matrix, so we are keeping characters inside. If it is integer, then we will be putting like -1, 10, 15 integer numbers. If it is floating point numbers in points, then we'll be using either float or double here. So it depends what type of matrix you want. On that basis, you will be creating the matrices. Okay. So let's suppose this is your matrix. Then how it would look like in your memory and how to access this. So let's make a 3 cross 2 matrix here like this. First we'll have A, then B, C. Okay. So these are the values at these locations. But what are all these locations here? So we all know that this is your column part and this is your row part. Okay. So this is row and this is column. So it start like this. This is 0th column. This is 1st column, and if something else is there, 2nd column, 3rd column, like that. So this is 0th row, this is 1st row, this is 2nd row. So we give numbering like this, and it always start with zeros. Don't forget this. your array always start with 0. So the first location in arrays, either it is 1D array, 2D array or n dimension array, it always start with zeros only. Okay, like this. So if you will start analyzing here, like what is the position of this A here, then this position is 0, 0. Why 0, 0? Because this comes under 0th row, okay, and 0th column. See, this 0 is coming from here and this 0 is coming from here. Now this 0 is coming from here to here also, and this 1 will come from here to here. So this is 0, 1 location, okay, 0 and 1 location. So how this would be, you can understand it like, now this is one row, so 1 will be like this. Now it is 0th column, so 0. So 1 row, first column, this is second, so second, and then this 0, second, then this 1 here. So as you can see how it is made, like 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. Let's try to understand it with 3 cross 3. That would give you a better insight about this. So let's suppose we are having this 3 cross 3 matrix is 0, 1, 0, 2. And then 1, 0. This 1 is coming from here and this 0 is from here. Okay. Then 1. So next one would be, I know you can understand this, 1 and 2. Then this is 2, 0, 2, 1 and 2, 2. So this is how we create our two-dimensional matrix. So let's recap this again. This is your row position. This is your column position. This is the name of your matrix. This is the type what you want to use. Okay. So this was about how to create matrix and what are their positions in the 2D array. Okay. So this A is at 0, 0 position. This B is at 0, 1 position. So once you will start using this 2D array, you will start realizing it really very quickly. Okay. So let's move to the next operation, which is nothing but how to set this value and get the value. So till now we were just simply creating. So let's try to get the values out of this. So we can start using, like, if you want to print something, like what is the value at matrix of 0th and 0th location. So 0 and 0 location is always this first location, right? So this should give you A here, right? So let's check that. See, it is giving you A here. Okay. So this is how we access your matrix. So if you want to give 0 and 1, which is this B, because this is 0th location and this is 0th location and 1 location, so B will come at that time. So let's check that. See, it is giving you B here. So this is how we access the elements in matrix. Now let's check how to change the elements. Like if you want to change something in your matrix, the same thing is applicable, like what is the location you want to change. Here I want to change 0, 0 location, which is this A here. I want to keep like Z there. Okay. And if I will again print that matrix of 0, 0, that will print Z for me. Okay. So let's check that. See, first it is printing 0 and 1, which is this 0 row, and 1, which is this B here. Now we want 0, 0, then it is printing Z, because we have modified the value of 0, 0 location. That's why it is printing Z. Now we are left with the last point, which is about how to initialize in different ways. So there are 3 ways of initializing your matrix when you are creating it. So let's look at them. So these are these 3 ways of initializing your element. So first you notice here that you are having this one as the previous one what I showed. Okay. So you will be writing like 3 and 2. So this is row and this is column. So this is the basic one. Okay. We all know this. There is something new here. See, you have not given 3. This is equal here, but here 3 is missing. Your computer is very intelligent. This portion is a column portion. So you are telling that I want 2 columns. So it can understand from here, like if you want 2 columns, then there is only 3 rows. So it will automatically put 3 here. Okay. Because see, if you want 2 columns and there are 6 elements. So total of 6 elements, you want 2 columns. So divided by 2 is equal to 3. So these many rows will come. So this 3 will automatically get placed here. Okay. So this is the second point. This was the first point. Okay, now this is a third point. Notice here I am not using these curly braces here. See, this and this. I don't have any curly braces here because there is no need of doing that, because you are telling that I will be having 3 rows and 2 columns. Okay, so your computer is very intelligent. It will understand that if you are telling you want to use 2 columns, then you have 6 elements, right? So it will start creating rows. So rows will start creating like R0. One row will have 2 columns. So this row 0 will have 2 columns, mean 2 elements. So A and B, we are done here. Then another row 1. So what we are left with? C and D. So C and D would come here. So, and another row 2. Then what we are left with? E and F here. And is there any element left? No. So this is how the structure would be. So that's how your computer understands, even if you are not given any parenthesis here. And it is not required like you have to keep it like A, B and then comma and then go to next line, then you start writing C and D and then go to next line and write like E and F. No, this is for our easiness, like we can understand it little better, like this is 3 cross 2 matrix, this is 3 cross 2 matrix. So no need to write it like this, you can write it in straight line also. So we'll see that. So we can do it like this. See, now it is looking very clean, right? See, I have changed it a little bit, that 0, 1 and 2, because you cannot have similar variable name in single scope here. So the scope start from here and here. So in between these two curly braces, you cannot have similar variable name. Either it is integer or character, whatever it is. Okay, so that's why I have started like matrix 0, matrix 1 and matrix 2. And we want to get this C here from matrix 0. So let's print that. See, it is giving you C here. Okay, now let's try to do something different than the usual thing. Like let's try to access 1 and 10 location. Like this is row location, so row number 1, which is this one, and this is showing that column number, but there are only 2 columns, 0 and 1. There is nothing like 10th column in this matrix. So let's see what would be the output for this. It is giving you some value. Okay, but this is not the perfect value here. So this is not the error actually. If you want to access some element which is not in your matrix, actually it works like this. Whenever you create any matrix, like suppose we are talking about this matrix here. Okay, so it will always store in RAM, because here all the variables and everything will always get stored in your RAM. So let's suppose this is stored somewhere here. Okay, so this whole thing is like coming from here and there. Okay, so this is your starting position, let's suppose 0, and it is going up to some value, like we are total of 6, so 0 to 5. Okay, so total 6 elements here. So we are having 6 elements, so this will come here. But what you are asking here is 1 and 10, which is nothing but some value in your RAM, and that might be coming from here. So what we got, that answer, this one here is lying somewhere here like this. Okay, actually that is not C, that is maybe some symbol like this. Okay, so that is somewhere here, but our array is between 0 and 5. Our array is at this location, but what you are telling, I want something which is at this location, because you are going out of your array bound here. Okay, so your array was from here to here, but you are going out of your array. Okay, so actually that is allowed, but the value what you will get would be undefined. Okay, so this was about 2D arrays. So we have learned 1-dimension array, 2-dimension array. Now we will be learning 3D and n-dimension array in next video. Okay, so if you think you should be knowing 3-dimension and n-dimension, go ahead and watch my next video. Welcome back. This is Rupesh and you're watching CBP Net's video series on C++. And in this video, we'll be learning about arithmetic operations. Okay, so arithmetic operations here. So we all know what are the arithmetic operations, like plus, minus, division, multiplications, and this modulo operator. This is little bit new for you if you don't know what is this modulo operator. We all know about plus, minus, division and this multiplications here. Okay, so let's go ahead and start with this first plus here. So we all know that if you will do it like 2 plus 1, this is going to result into 3. Okay, so let's check how to achieve this plus, minus and everything in our programs here. We'll take an integer variable. Let's suppose var is equal to 10, and we will print that variable with some addition to 10. So this variable plus 10 should print 20 because this variable is already having this 10 value, and 10 plus 10 would be 20. So let's check that. So this is giving you 20 here. Okay, you cannot only perform operations on variables itself, you can write it like this also, like 15 plus 10. So this will give you 25. Okay, so this is how we perform the operations in your programming language. Okay, this is pretty straightforward. Not only these two constant variables, you can have some different variable like var1 is equal to having, let's suppose, 23 value, and here you are using var1 and here var1. Okay, so var1 plus var, which is nothing but this 10 plus 23, and we are giving this into this Cout, so it will be 33. Let's check that. See, it is giving you 33 here. Okay, so this is how we perform the add operation. In the similar way, we will use this minus operation. So var is 23 minus 10 would result in 13. So we can check that also. See, it is giving me 13 here. What if it is like var and this is var1? So we all know, as per the mathematic rule, if the lesser number is positive and greater number is negative, the sign would be negative here. So this var is 10 and this is 23. So the result will be minus 13. So we can check that as well. See, it is telling you that the result is minus 13 here. So your computer understands very well that what operation you are performing, right? It is similar to the mathematics subject, right? Not only this, you can do like this also, like some another variable like result equal to var minus var1. So instead of var and var1, we will be using some variable names like a and b here. So it will be easier for us to navigate through the answers here, right? So b, a is 10, b is 20. So the result should be minus 13, right? So we can print result here. This would give you minus 13. Okay, so let's print this. See, this is giving you minus 13 here. Okay, not only this, we can perform multiplications as well. So a into b would be 230. So we can check that as well. See, 230. You could have simply written this whole expression here itself and the same result would come. Okay, we are using this variable so that I can show you we can initialize the operations inside our variables also. So let's check this. See, the same thing is coming here, 230. Okay, not only this, we have another option like division also. So a divided by b, which is 10 divided by 23, then it will be some point value, but let's make it little simple for you in the beginning. So b divided by a, so which is like 23 divided by 10 would be 2.3. So let's check that first. But as you can see, it is telling you 2 only. Where is that 0.3? So the idea is it is truncating that. Truncation means this b and a is like 23 divided by 10. So the result would be like 2.3. But this is taking only 2 because you are not telling that the result should be a floating point number. That's why it is taking the integer number, which is this 2 only. Even if it is 2.9, it will print 2 only. Okay, so the expression's result is coming as integer here. That's why we are facing this problem. Okay, so if you want this 2.3 to come here, you will have to typecast it. So this is a new term for you, I know that, but this is an expression like b divided by a, and this is producing 2.3. But when you are giving this 2.3 to your this Cout, this is not getting this 0.3 value because by default it is giving you the result as 2 only. So you have to explicitly tell that I want floating point result. So in that case, you will have to write something like this. Float. This is the way of typecasting your operation. Okay, like b divided by a, and you're done. So this, if you will write here, it will work. Let's check that. So if you will just simply write float here, this will give you the expected output 2.3. See, it is giving you 2.3. So by default, you just remember it like this. By default, this division operator give you non-floating result. If you want this to give you a floating point result, you have to tell explicitly that I want a floating point output. So this is how it works. It is not like if you will take like float some result and b divided by a, then if this is float variable, this will automatically initialize float only. No, that won't work because this will always produce 2 only. So let's check that. If you will print this result variable here, it will give you 2. See, it is again giving you 2 here. So if you want 2.3, you have to explicitly typecast as I told you. So if you will write float here, now it will work. See, there is 2.3 now. Okay. So there is this little bit of difference in floating point and non-floating point numbers. Okay. This you will understand better when you will start programming in C and C++. So extensive. Okay. In first time, everything look like you are remembering only, but later you will start realizing the reason behind that. Okay. So now there is this divide operation. So the last point is this modulo operator here. So let's perform the modulo operation. B modulo A here. So once I will show you the result, then we will start analyzing that. So the result is 3. Okay. So why it is 3? I'll tell you that. It is 3 because you are doing it like 23 modulo 10. So you will start counting 10 table like 10 ones are 10, 10 twos are 20, and 10 threes are 30. So as you are going above this variable, I mean the value, so this is 30. So you will not go till 30 here. So you will go up to 20 only, and whatever value you get here, you will just do the minus in this. So 23 minus 20 is 3. Okay. So this is the result. Okay. So let's take another example here. Let's suppose you are doing 10 modulo 2. Then what should be the result here? So what I told, start counting 2 table like 2 is a 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10, 2 sixes are 12. But this 12 is more than 10, so you will go again one back. So this is 10 here. So whatever this value is, you will do like 10 minus 10 is equal to 0. So the result would be 0 here. Okay. Let's take another example here. 5 modulo 2. What would be the result here? So we'll do that again here. Like we'll start counting 2 table like 2 ones are 2, 2 twos are 4, 2 threes are 6. But this 6 is greater than this 5. So we'll stop here and we'll go one step back. So the value was 4. So 5 minus 4 is 1. So the answer is 1 here. Okay. So this is what your modulo does. But you might be wondering that in left side I am always keeping greater value, like 23 is greater than 10 here, 10 is greater than 2 here. Okay. So 5 is greater than 2 here. Let's try with another example. So first I will erase everything. No, I won't erase because it will be helpful for you to analyze the result. So this time I will keep 3 modulo 5. What would be the result? The result would be 3. You can directly tell by seeing the operation here if your this value is less than this value, then the result is this value only. Because remember how we was doing that. We were counting the table like 5. 5 ones are 5, but this 5 is greater than 3. So you will stop here and you will go one step back. So going one step back would result into nothing. That's why we are not doing any operation on this, and the result is as it is. Okay. So if you're doing it like 10 modulo 11, then also this 10 is less than 11, the result is 10 only. Okay, so the result is always 10. So this is how it works. So if it is 1 modulo 1000, we know the answer is equal to 1. Okay, if it is 2 modulo 5, answer is 2, because this 2 is less than 5. Okay, but what if it is equal, like 2 modulo 2? What would be the result here? So let's do the same operation how we was doing that. We'll start counting the table of this 2 here. So 2 ones are 2, 2 twos are 4. This 4 has increased by 2. So we'll stop here and we'll go one step back. So that one step back is this 2 here. So what we was doing? We was taking this value and doing the minus operation with this one. So 2 minus 2 is equal to 0. So always remember, if your left hand side modulo operation with right hand side is given to you, where left hand size is equal to right hand size, then in that situation your this L modulo operation with R modulo operation would result into 0. Okay, and there is this logical proof also, like 2 modulo 2 is equal to 0. Why? Because you will start the table of this 2 here. 2 ones are 2, 2 to the 4, 4 is increased, so you will go one step back here. This is the value you want to do minus with this one. Okay, so 2, which is this one, minus 2, which is this one, result into 0. So the answer is 0. Not only 2, if it is 3 modulo 3, answer is 0. If it is 4 modulo 4, answer is 0. Okay, if it is 1000 modulo 1000, answer is always 0. So left hand side and right hand side is equal, then the result is always 0. Okay, so this was about arithmetic operators in C and C++. Yes, it is equal in C also, because we have taken everything from C itself. So that's it. Now we know how to perform operations like plus, minus, multiplication, division, and this modulo operator. I know people might have liked this modulo operator a lot. So in next video, we'll be learning pre and post operations. So what is this pre operation and post operation? We'll see in the next video. Okay, so I'll see you in the next video. Bye bye. Welcome back. This is Rupesh and you're watching CVPNet's video series on C++. And in this video, we will be learning about the assignment operator. How the assignment operator works. I know you might be knowing the assignment operator, which is like A is equal to B here, like integer A is equal to, let's suppose, 10 here. Okay, so we know what is the job of this assignment operator here, which is like taking the right hand side value and assigning into A. But there are lots of ways you can use this assignment operator, which we'll be learning in this video. So let's start that. So let's suppose you are having this A is equal to 10 and B is equal to, let's suppose, 20 and C is equal to 30 here. Okay, so we'll see use of equal to operator like this, like B is equal to C is equal to A, and if you print, what we have done here is we have initialized A into C and C into B. So ultimately everything is A now. Okay, so if you will print it, you will get the 10, 10 and 10. See, 10, 10 and 10. If it is equal and equal and equal and equal, it will go to the last equal. So here it comes to A here, and whatever the value of A is, it will get initialized into C. So this C has become 10 now, and whatever the value of this variable is will go inside B. So this B is also 10 now. Okay, that's why you are getting 10, 10 and 10. Got it? So this is how this A plus plus. Then can you imagine what would be the answer here? So as it is post increment, as I told you, if it is post, then this increment will come in the next line. So in this line it will come. So we can divide this into this expression like B is equal to C is equal to A, and this A, whatever this increment is happening, will happen like A is equal to A plus 1. Okay, so the result would be like whatever the value is there in A, which is this 10 here, this 10 will come here, so this C is also becoming 10, then that C is coming into B, so the B is coming as 10. So 10, 10 and 10. That's why this B is 10 and C is 10. But in next line we are changing A. So this A is 10 here in this line. So in next line also this A will be 10 here plus 1. So the result is 11. This result is going inside this A now. So once this whole thing is done, we are going to print in this. Okay. So next consecutive line would be like, that's why this A is 11 because A is changed as 11, B is still 10 because B was not changed after this expression, and the C was also not changed, so that C is also 10. That's why if you will run this, you will get like 11 here, 10 here and 10 here. So let's check that. So if you will run this, you will get it like 11 here, 10 here and 10 here. So A is 11, B is 10 and C is 10, and you know the reason why it is like that. So this is how this equal to work. Okay, so I think you got the point here. And let's check with this pre also. We checked it like post, so we can check it with pre also. So in this case we can break it into like this. So as I told you in my previous video when I was explaining what is the significance of post and pre, so if it is pre, then what is the meaning of pre here is you evaluate yourself first prior to initialization. Okay, in post it was like you do the initialization first and then you increment yourself, but in case of pre, if it is pre, you increment yourself first, then you initialize. So this whole expression would look like this: B is equal to C is equal to A is equal to A plus 1. So as you can see here, this is changing like what is the A value? It is 10 plus 1. This is becoming 11. Okay, so this 11 is going inside A here. So this A is becoming 11. Now this A is going inside C. So C is also becoming 11. Then C is going inside B. B is also becoming 11. So everything is 11, 11 and 11. So we can check that now. If you will execute this, this is like 11, 11 and 11. And you know the reason why. Okay, it is like this. Got it? So this is how this equal to, which is called assignment operator, work. Okay, it evaluate the rightmost side first and then it traverses from here, and if something else is there then it will keep on traversing. Okay, so it starts from the right hand side and it goes like this into the left hand side. Okay, so this is your left hand side, this one, and this is your right hand side. So it was working like this and going to that left hand side. Got it? So I think we have got the point here of this assignment operator. Okay, so let's look at the next video now. Welcome back. This is Rupesh and you're watching CVNet's video series on C++. And in this video we'll be learning about equality operator. So for that you need a requirement. So the requirement is there are two inputs, like there is one A here and there is another variable B. If these two variables are equal, then we'll print equal, otherwise we'll print not equal. Okay, so it would be like if A is 10 and B is 10, we'll print equal. Okay, if it is 10 and this is 11 or something else, then we'll print not equal. Okay, so for this you need two variables, A and B, and we'll take input from user, or we can directly assign input like this. We are assigning into this X here. Okay, so let's try with this example. Like, so as I told, we need two variables like A and B is equal to 10, and we'll check if A is equal to B, you print equal, otherwise you print not equal. So else you print not equal, not equal. Okay, so we have two variables a and b, and here we are going to learn this equality operator here. So let's run this and try to understand what is the result of this. See, it is printing that the value is equal. So a is equal to b. Okay, so a is 10. So if you will write 10 here, which is nothing but the equal thing here. So a is equal to 10. Yes, it is true. So again, it will give you equal only. See, okay. So if you will give it like 10 is equal to 10. Yes, it is true. So it will give you equal here, as we can see here. Okay, and let's suppose you are giving 11. Okay, which is not equal to 10. So in that situation, it will print not equal. See, this will not equal. Okay, so this is how we check the equality here. This equality doesn't work only with this integer, it works with characters, string and all that. Okay, so we'll try with this character now. Let's suppose you are having this character a and another one is also a. So in that situation, this character a is equal to character a. So in this case, it will print equal. See, it is printing equal here. But if it is something else than a, like b or c or anything else, it will print not equal. See, it is printing not equal here. So it is like this. We are executing this whole program. It is coming at this line, initializing a is equal to 10 and b is equal to 10. But we are not using these variables here, so don't worry about this. And then it is coming to this statement. This is if statement, and we check the conditions inside if statement, and this is the syntax of writing that. Okay, we can work with string also, not only with this integers and characters. So we will see the string case here, like C++ is equal to C++. It is equal, right? This C++ is equal to this C++. So if we will print this, it will give you the result as, oh my god, what is this? Not equal? Yes, it is not equal because this C++ is having this C as capital, where this C++ is having this C as small letter. So these two strings are totally different string. They are not equal. So if you want this to be equal, you have to make it like this. So if you will print this now, it will give you equal. See, it is telling you the equal thing. Okay, so we can equate two stuff using this operator. So now we know how to use this equality operator. So let's look at the next video now. Hello there, this is Rupesh and you're watching CPNet's video series on C++. And in this video, we'll be learning about relational operators. So these are the relational operators we have in our C++. So let's see one by one how this whole thing will work. Okay, so we'll just give you a very basic example here, like if 1 is equal to 1. Yes, it is true, and it will print true. Okay, nothing fancy. That's it. So this is the use of this thing. Okay, so let's go ahead and print this. See, it is printing you true here. Got it? So it is not like you can have only this constant 1 is equal to 1. You can have variables also, like you are having integer a is equal to 10 and b is equal to 12. Then you can equate 1 with b. I mean a with b here. Okay, so in this case, if it is not true, we should print something like false, right? So this is false. So this will now print false here. Let's check that. See, it is printing false. So this is how we check whether this a is equal to b. So this is for checking the equality here. Okay, so this was about how to check this equal thing. Now let's check whether it is not equal. So if you will apply this not equal sign, then this will become true. Before this was giving false because it was not equal. But if you will check a is not equal to b, yes, it is true because it is 10 and this is 12. So this expression will become true because it is telling that a is not equal to b, which is true, right? So in this case, it will print true here. Let's check that. See, it is printing true here. Okay, so this is how it works, and I hope you know how this if and else and how this variable thing works. So if you have not watched my previous videos which talk about this if else statement and how this variable thing work, please go ahead and watch that first. So we were talking about this greater than now, so let's check this one now. A is greater than B. No, it is not, because A is 10 here we can see and B is 12. So 10 is greater than 12. No, it is false. So this expression will become false here. So in that case, if this is false, you are not going to go inside if, you will be going inside else. Okay, so here false will come. See, false. So this was the case of greater here. If you want to check it is greater than or equal to, we can check that as well, greater than or equal to. But in this case also, this is neither greater nor equal. Okay, so if you want to print it like, no, before we'll check that now. See, it is false, right? Because it is neither greater nor equal. So if you want to make it equal like this, so this time this equation should be true. So what this equation tells, as it tells like either it should be greater than or it should be equal. So A is not greater than B because A is 10 and B is also 10. So it is not greater than, but it is equal because both are 10 and 10. So second condition will become true. Okay, then it will go inside. Got it? So let's check that. See, it is going inside because it was not greater but it was equal. So this expression become true and it went inside that. Okay, so the same case with less than here, we can check that A is less than B. No, A is not less than B because both are 10 and 10. So let's execute this. It is telling you false, which is correct output. Okay, and the similar case for less than or equal to. So if you apply less than or equal to, which is this one, this will become true because A is not less than B, but it is equal. Okay, so let's check that. See, it is true. So this is how these relational operators work, and it does not work only with this, it works almost all the data types. Okay, so this is a simple understanding of how this whole thing will work. Now it's up to you how you want to use your relational operators. Okay, I'll give you a simple example here, like C++ is equal to C++, and we'll check that with this equal operator, which is nothing but this operator which tells that if this is string, this is a string, right? This is not 1, 2 or something. This is a string. One string is equal to another string, and this is going to print yes. See, it is coming yes. So as I told, you can apply this equal operator for almost all the data types available. Okay, so that's it. Let's look at the next video, and the next video is about logical operators. So this was relational operator. Now we'll see logical operator in next video. So let's look at that.
Hello guys, this is Rupesh and you're watching CPP Nuts video series on C++, and in this video we'll be learning logical operators. So these are the operators. First one is AND operator, second one is OR operator, and third one is NOT operator. And as the name says, we will be applying our logics using these operators. So let's start this. So till now you might have seen something like, if you have some variable and its value is 10, and if you want to put some condition like if A is equal to 10, then do something. Let's print yes. Okay, then this is a nice looking code, right? But let's suppose you have another variable B, and your condition is like this, like B is equal to 20. So now what will happen? You want something like if A is equal to 10 and B is equal to 20, then only print yes. Okay, so here comes the AND operation. You will apply double address and it is AND operator. Now you are telling to the computer that I got two variables. If A is equal to 10 and B is equal to 20, then only go inside. Otherwise, go to else if you have given else part and print no. Okay, so it's that simple. And not only this, you can apply this AND operator as many time as you want. You can say that okay, A should be less than B also. Okay, so if this is the case, then only you go. So what you are saying, A should be equal to 10, B should be equal to 20, and A should be less than B. So it's obvious if these two are correct, third one is always correct. But this is not the point. The point is all these conditions, first condition, second condition, and third condition should be true in order to go inside if statement. Either of this is not true, you will not go here. Okay, so that's what the use of this AND operator. AND means this one true and this one true and this one true. So it's like true, 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 true all the time. All expressions should be true only. Okay, so this was AND operator. Now let's look at the OR operator. There could be a situation where you will say that okay, I have this A is equal to 10 and B is equal to 20, and either of this is true, you go inside this. Okay, so if let's suppose here B is 40 initially and you want to check whether you will go inside this or not, definitely you will go inside because this condition is true, and this is OR operator which says that either of this should be true. And one important point, if your compiler will see that first condition is true and you are using OR operator, your computer will not bother to go and check this one, because what it needs is only one condition to be true if your OR operation is applied here. Okay, so it will definitely go inside if first one is true. Let's suppose you did like this, A should be equal to 1000 and B should be equal to 20. Now here both are false, so it will not go inside this. Let's make this one true. Let's make this one 40. Now what will happen? B is 40, A is 10, but you are comparing A with 1000, which is false. So this first condition is false and you are using OR operator, then your computer will go and check the next condition, and next condition is found to be true, so it will go inside this. Okay, so this relation is OR. This one true or this one true, or other expressions are there. If any of those expressions are true, you will definitely go inside this. So that's the use of OR operation. Now let's look at this NOT operation. So before going into the NOT operation, I want to tell something to you. We all know numbers, right? They all are like minus infinite to, let's suppose, -4, -3, -2, minus. Now, if you will apply this NOT operator on any of the numbers except 0, it will be false. I mean to say this one. Let me just remove this. No, I will just remove this one. So, A and NOT operator like this. So, if A is not, so if A is 10, so it is telling that if A is not, but A is there. Not means 0 only. Maybe you didn't got it. So let me just run this. The answer is no. Why it is no? Because you was looking for not, but you got some value, and not means 0. So if this operator will get any value other than 0, this is not going to go inside this. It means it is looking for 0 here, then only it will go inside this. That's what it is telling. If not, then only I will go inside. Okay, and not is 0. Other all values, -1, -5, -10, 10, 1, 5, 11, whatever it is, all are true. Okay, only this one is false. So if you will write A is equal to 0, and let's compile this again and run this, then only it will go inside yes. Okay, so you saw that if it is 0, then only it will go inside this. So this is the use of NOT operator, and this is not the only way you can use this. Actually, you can use like this. If A is less than B and at front of this expression you are putting this not here. Okay, so what it means, if this expression, what this expression is getting evaluated into, it's like a is less than b. Yes it is, because a is 0 and b is 40. Yes, it is true. So if this whole expression is evaluated as true and this not is looking for false, 0 means false and 1 means true. Okay, don't forget that. So as it is looking for false, this will not go inside this. Let's check this again. See, it is printing no now. Okay, so if it is false, means like this. If a is greater than b, then only it will go inside this, because a is greater than b. No, it is not. So this expression, what is there inside this round bracket, will produce 0 or false. Then only this not operator will get satisfied, because it got false or 0. Then only it will allow you to go inside this. So let's compile this and check. See, it has gone inside this. Okay, so these were few points about logical operators. If you like the video, don't forget to hit the like button, and if you haven't subscribed yet, go for it. It would help me a lot. Thanks for watching. I'll see you in the next video. Bye bye.
Hello there, this is Rupesh and you're watching CPNet's video series on C++. And in this video, we'll be learning about what are the bitwise operators. So before this, we learn about relational operators, logical operator. So let's go ahead and study what is this binary AND operator. So first of all, we'll be learning what is this AND operator. Okay. So let's first talk about what is the bit operation. So in left hand side, I'll write the binary of 0 to 7, like 0, 1, 2, 3. So the binary of this one is 0, 0 and 0. 6 is 1, 1, 0. Okay. So this is the binary representation of respective numbers here. So we'll be understanding this video on the basis of these binary numbers and these numbers. Okay. These are the decimal number. This is decimal. This is binary here. Okay. And we're going to learn this bitwise AND operator. Okay. So if you are writing AND operator like 1 and 1, then what it will do, as it is bitwise AND operator, it will take bits of A. So what is this A bit? 0, 0, 1. See this one. And it will apply the AND operation on the same thing. So AND operator work like this. This 2 should be 1 in order to produce 1. So the rules for AND operation is 1 with 1 is 1. So this true with true is true. It's something like this. So this is binary, okay, not this decimal. So this one is 1 bit and another one is 1 bit. So 1 bit and with 1 bit produce 1. So if it is 0 and with 0, it produces 0. If it is 0 and with 1, produce 0. If it is 1 and with 0, produce 0. So remember this, 1 will always come when both side 1 is there and we are using this bitwise AND operator. Okay. So as we all know what is the meaning of AND. AND tells I want this side and this side true in order to produce true. Okay, and we consider 1 as true and 0 as false. Okay, so this is our rule set, okay, for AND operations on bits. So this is 1 bit, this is 1 bit, this is 1 bit, like this. So this is not a decimal, this is a binary bits. Okay, and these are the outcome of these operations. So we were talking about what is 1 and with 1. So the result is 1. So we'll be writing 1 here, 0 and with 0, 0, 0 and with 0, 0. Okay, you can check it here. Got it? So if you are writing it like inside some if, this is 1 and this is 1, so 1 and 1, and you will be allowed to go inside this loop because this is producing 1 here. And let me tell you one thing, if you are writing inside if, and if you don't know, you'll be surprised to know about this. If you are writing anything in your if, you would be allowed to go inside like this. If you're writing here, whatever, like -1, 1, 10, 1000, or A or C or D, whatever you want to write, if you're writing inside this, you will be allowed to go inside if, because all the values are considered true. The only thing which is not considered true is 0. So if you are writing 0 here, this is false. Other than that, whatever is coming inside if, that is true. Okay, so here this 1 and operation with 1 would result 1, so this would be replaced as 1. So as this is a non-zero value, this if statement is evaluated as true and you will go inside if. Okay, so this is how it works. So let's take some another value like 3 and with 7. So 3 is nothing but 0, 1, 1 and 7 is 1, 0. So we are going to perform AND operation. So we know the rule: 1 with 1, 1, 1 with 1, 1 and 0 and with 1 is 0. So this is 3 and this is a non-zero value. So if you have written this expression, it like if 3 and operation with 7, you would be allowed to go inside this if. Okay, because this is producing 3 here and 3 is non-zero, so you would be allowed to go inside this if. So this is how this AND operation work. Okay, so let's go for the bitwise OR operators. So this is your binary OR operator. So how would you use that? So let's first write the rule for this. So if you are applying binary OR with this 0 and 0 bit, the result will be 0, and if it is 1 OR with 1, it is 1, 1 OR with 0, 0 OR with 1, it is 1. So it is 1 whenever there is at least one bit in your operation. Okay, so it is exactly the opposite of your AND operator. Okay, so let's check this out. So if you are writing expression like if 1 or 1, so let's see what would be the result for that. So don't get confused with this. This is an OR operator and this is 1 and this is 1, decimal 1. Okay, so as this is a binary operator, this will perform binary operation on 1 and 1. So 1 is this and this is this. So this OR operator would result in 1, 1 with 1, 0 and 0. So as this is a non-zero value, this would replace as 1, and if it is non-zero, you are allowed to go inside your if statement. Okay, so this is how it works. And let's take another example like 4 OR with 0. So 0 is 3 times 0, 4 is 1, 0. So OR with 0, 0, the rule says 0, 0, 0, 0, 0, 1, 1. So the result is again 4 here, which is a non-zero quantity. So this expression is evaluated as true here. Okay, so this is how this OR work. So let's look at the next one, which is this binary XOR operator. So this XOR operator is little bit difficult to understand, but let's give it a try here. So this is the sign of your XOR operator here. Okay, this particular sign. So we'll write the rule here for 0 XOR with 0, 0 XOR with 1, 1 XOR with 0 and 1 XOR with 1. So the rule says if both are equal, like either 0, 0 or 1, 1, it produces 0. And if both are different, it produces 1. So this is the rule for XOR operation. Okay, you go ahead and see in your book, you'll get this. Okay, so the same thing for any operation like if 1 XOR with 5, this would result in 1 means 0, 0, 1, 5 means 1, 0, 1. So 1, 1 produces 0 in XOR. So this will be 0. So both are 0. So I mean both are equal. So it will again 0. Both are different. Then it will be 1. So as this is a non-zero quantity, because this is 4, so this expression will be evaluated as true here, and you would be allowed to go inside your if statement. Okay, so this is how this XOR operation work. So this is the rule for your XOR operations. Okay, now another one is this binary ones complement. The use of the binary ones complement is like this. The symbol is this one, and the rule for this is like this. If this is applied on true, result will be false, and if this is applied on false, then result would be true. So if it is applied with 0, the result would be 1, and if this is applied with 1, the result would be 0 here. Okay, so this is the job of this one. So these operations are always on binaries. Okay, so if I'm talking about these operations, always performing on the bits. Okay, so 0 bit will become 1 and 1 bit will become 0. So if you are writing it like this one and 1, so notice this is a unary operator. You are not writing it like 1 and 2. No, before what we learned, that AND operator, OR operator and XOR operator, those operators was binary operator. Like for this you need have left hand side and right hand side, left hand right hand side, left hand side, right hand side. But for this one, for particularly for this operation, you don't need left hand side and right hand. You need just one expression. Okay, so this expression could be anything like if, negation, and here you can have 1 and 2. Okay, so this will get evaluated like 1 and operation with 2. So 1 is nothing but 0 0 1 and 2 is 0 1 0. So you are going to perform this AND operation, which is nothing but 1 0 0 0 1 0 0 0 0. So the result is coming as 0. So this whole expression from here to here is producing 0. 0 is false value. So as I told, false applied with negation, which is binary ones complement, which does the complement. So whatever is there, it will reverse that. So if it is false, it will make it true here. Okay, so if it is false, it will make it true here. So this whole expression will be evaluated as true and you would be allowed to enter. Okay, but notice this, for this to work there is only one value, right? This one was expression, so this expression get evaluated and resulted into either false and true, and we are feeding that false and true into this operator. Okay, so this one will be like true only because this one is having 0 0 1 and you are applying this inverter. We can call it lots of things. Okay, so this is a complementer, so it will complement or it will invert everything because it is one's complement. So one's complement does the reverse thing, it will make 1 as 0 and 0 as 1. So this is the result. So as this is a non-zero quantity, actually this is 6. So if you are writing 6 here, which is a non-zero quantity, so you are allowed to go inside that because that is not 0. Okay, if it is producing 0, then only you are not going to enter in. Okay, so we are left with this binary left shift and binary right shift. So let's try to understand binary left shift here. So this is the symbol for binary left shift. So what is left shift? So let me tell you something about your computer. We all know when we write integer v is equal to 10 here, there is some place in memory called v and we are storing 10 into that. So how that thing actually work? So let's try to understand that. As we tell, we are creating integer type. So this integer type is having size as 4 bytes. So if you don't know what is byte, let me tell you, 1 byte is equal to 8 bits. Okay, so if you are writing consecutive 8 bits like this one, this one, this one and this one, this is like 4 and 4 8, so this is 8 bits, which is nothing but 1 byte. Okay, so this could be anything like 1 here, 0 here, but the main point is the numbers should be 8 times. So 8 bits are total bits are 8 bits, that's why it is called 1 byte. Okay, so if it is 4 times, then it is 4 byte. So you can assume that if you are creating variable v as integer which is of 4 byte, so it will be taking memory in your RAM. How much? 4 times 8 bits. So how many bits will be there? 32 bits. So you will be taking from 0 to 31 bits in your memory, which is nothing but your RAM here. Okay, so like this, these many slots will be there. Inside that you will be having either 0 or 1 or 0 1 0 1 0 1 0. Okay, so let's assume you are inserting 10 in that. Okay, so I'll show you how this would look like, but you don't know what is the binary of 10, right? So let's assume you are inserting this 5 in that. Actually, the binary of 10 is 1010, but let's not talk about that because we are working on this one. So let's suppose you are inserting this 5. Okay, so how it would look like in your memory? There is going to be 0 0 0 0 0 0 0 0 32 bits. So again our this 5 will come here. So this is how it is going to store in your memory. There is something called little indent and big indent. I won't be confusing you a lot because if I'll start talking about little indent and big indent, this will get messy because in one style this start from here and in another style this will come here and consecutive zeros will come here. So for simplicity I'll keep it like this only, and I won't talk about little indent and big indent. We'll talk about in future coming videos if we'll require. Okay, so for now you just think like if you are writing integer v is equal to not 10 like 5 here. Okay, so this 5 is going inside your v and this is like this. Your v is in your RAM looking like this. Okay, you might be thinking why these many zeros are there, then at last it is getting 101. Yes, because we can store 1 lakh, right? 10 lakh, 20 lakh. So as we will increase our value, these 1010 mixing will start coming here. Okay, so the maximum number you can store in integer is some number, I don't remember that, but here it will be like 1 1 1 1 1 1 1 1 1 1 1 1 all the way 1 only. Okay, that would be the biggest number, and the smallest number is 0 0 0 0 0 0 0 all the way 0 up to 0 here, which is nothing but in decimal if you will talk about, which is 0. Okay, so this is how things get stored in your RAM. So I was talking about shift, right? So this is our left shift. Now you're ready to understand what is left shift here. So as you know, this is the representation of your decimal number 5. Okay, this bit representations. Now if you will left shift it, so let's try to understand it like you are performing some operation like v, which is your 5, which is having this bit representation with left shift by 1. For simplicity, we'll think about this 1 first. So this whole bit representation will get shifted by 1. So this 0 will go here. So if it is going here, this is getting lost. Okay, because this is the boundary. Okay, so this particular 0 will come here, this 0 will come here, so it is taking one left shift. So as it is left, it is going inside this direction. Okay, so this 1 will come here and this 0 will come here, this one will come here, and there is this empty space here, right? Because this particular 1 will come here, so there will be this empty space, and always remember empty spaces are always get filled with zeros. So in short, I will take this snippet to explain this left shift. So let's assume you are having this 0 0 0 0, this one, and one more time 0 1 0 1. So this is this memory area. Rest are 0, so we should not take care of that because it will take so much time. So let's suppose here this 0 is going here, this is going here. So the left shift of 1 on this binary representation produced like this: 0 0 0 0 1 0 1 0. So remember this, I told there will be this empty space after this 1 will get shifted here. So this empty space is getting filled with 0 here. So this would be the result. Okay, so if you notice here, if you know, this is going to produce 10. Okay, because binary representation of 8, 9 and 10 is 1 0 1 0. Okay, so it is like this. 8 would be 1 0 0 and 9 would be 1 0 0 1 and 10 would be like 1 0 1 0. Okay, so that's why it is producing 1 0 1 0. That's why if you will print this expression like Cout, this is going to print 10 for you. Okay, so let's check this. This is very interesting, right? So see, I have written exactly the similar what we saw here. Okay, so v is having 5 and we are giving left shift. This is the left shift operator here by 1. Okay, so this is the syntax of writing that, and whatever the value is coming, we are just simply printing that. Okay, so let's print this v also. It will be very easier for us to understand. Okay, so let's print this. See, this is 5 and another one is 10. Okay, so as I told here, it is representing 10 here, so it is giving you that one. So this was about left shift, and you are shifting it by 1 only. If you want to shift it by 2, you just simply shift it by 2 here, and we'll see the result. What is that? By just shifting it by 2. So first try to understand it here, like if you will shift it 2 times, then this is the result of 1 time shift. Again, if you will shift it 1 more time, it will be like 1 0 1 0 0, and here 3 times zeros. So this is I don't know. So let's calculate this. So we'll learn something new today. 0 0 0 1 0 1 0 0. So how to calculate the decimal of this binary here? So I'll tell you one rule. This place is 2 to the power 0th place. This place is 2 to the power 1. This is 2 to the power 2. This is 2 to the power 3. And this is 2 to the power 4. So we will consider whatever is 1 here. So this is not considered, this is not considered, this will be considered, this is not considered, and this will be considered. So what is being considered? This one and this one. So we'll add this. So 2 to the power 4 is nothing but 16, and this 2 to the power 2 is 4. Okay, so 2 to the power 2 is 4. So add is 20. So this is 20. So this is how we calculate this. Okay, so this number is producing 20 here, and this was 10. This was 5. Can you make out any pattern here? So the pattern is, I'm going to tell you that, just listen it very carefully. So the pattern is, whatever the number is you are going to shift it, if it is 1 time shift, it will get double. Okay, like 5 to 10. If it is again 1 more time shift, it will again get double. Then the current value, I mean with the current value, okay, not with this 5. See, 1 time shift 10, another time shift 20. If you will shift it again 1 more time, this will become 40 here. Okay, so like this it will work. And the same scenario is for right shift also. So if there is this right shift operation, then the only difference would come here is, instead of left shift, you will be writing right shift. Okay, so we'll remove this. So instead of left shift, you will be writing right shift here. Okay, so whatever is there in V will get shifted by right, and whatever the value you will be giving. So as this 0 was going and getting discarded, now this time let's suppose if your V is this initial position 5. So let's take the example here. Sorry for not removing everything here. I'm so lazy. So let's suppose we are shifting right time. Okay, right side I mean. So the bit pattern is like 0 0 0 0 0 1 0 1. This is nothing but your 5 in decimal. So if you will right shift it, this is the boundary we all know. So if you will right shift 1 time, this would look like this: 0 1 0 0 0. So that's it. You are done. This one will go out and get discarded. Okay. And I told you, as this is going this way like this, one empty space will come here because this 0 is going here, okay, and this 0 is going here and this 0 is going here. So in last there will be one space, so that space is always getting filled with zeros only, okay. I told you here, right? So this is going to be your result, which is 2, okay. And if you will again right shift it, it will be like 1 and then 7 zeros, 1 2 3 4 5 6 7, okay. So this is going to be your again one more right shift on this one, I mean this 2. So this is going to represent 1 here. So there is another one pattern here. If you are doing right shift, the value is getting divided by 2. So 5 divided by 2 is result 2. I mean it is 2.5, but we don't consider point values, okay. So if 2 is divided by 2, result is 1 here, okay. You can see this. And if 1 is divided by 2, which will produce 0.5, and as we don't take decimal numbers, floating point numbers, we will be ending up taking 0. So as you can see, if we will make it one more time right shift, this 1 will go here and got discarded. So the result will be 0 0 0 0 0 0 0 0. Okay. So like this it will work. I think I have not messed it up so much. So let's quickly see the programs for all these operations. Okay. So let's first learn about this bitwise AND operator. Okay. What we learned first. So as we know, this would result into binary operations. So let's run this one. So this operation would be like 2 is nothing but your 0 1 0, and this 3 is nothing but your 0 1 1, and there is this AND operation, and we know the rule. If there is 1 0, the AND would be 0 only. So 1 1 1 0 0 0. So this is 2 only. See, this and this both are equal. So this is producing 2. So the answer for this one should come as 2. So let's check that. See, the answer is 2 here. Okay. So this is how we do the AND operation with these numbers. You can have variables also in place of these two numbers. For simplicity, I am keeping it like this because this video is going to be very long video otherwise. So let's check this binary operation for this now. This would be like again 0 1 0 and 3 is 0 1 1, and this time we are going to operate on OR operator. Okay, so OR is like if anyone is 1, the result will be 1. So this is 1 and this is 1, and both are 0, so the answer will be 0. So this is nothing but your 3 here. So the answer for this should be 3. Let's check that. See, it is 3 now. Okay, so this is how it works. So the XOR is, it comes with 6 number on your keyboard if you're not able to locate it. XOR is something like this. This is 2 0 1 0, 3 is 0 1 1, and we are applying XOR, which is nothing but when both are different, then only it will produce 1. So these two are equal, so it will be 0 0 0, which is equal, so it will be 0. Okay, so this is going to produce 1. So here this expression should produce 1 here. Let's check that. See, it is producing 1 here. Okay, so this is how this XOR operation work, and we already saw how this binary left shift and right shift will work. So let's give it a try here. So for simplicity, I'll shift this 1 3 times. Okay, so don't forget the placement here. Left hand side is always your operand. Okay, what you want to operate with, and how many times that shift should be is coming on the right side. Okay, so if this is the situation here, this would be like this. There is this 1. Let's suppose we are talking about this 1 with 4 bits only, because no need to write whole 32 bits because that would be very long. So if you are applying 3 times left shift, so left shift is this one. So this 1 would come, 1 shift here, second shift here, third shift here. So this would be like 1 triple. So this is nothing but your 8. So this expression should produce 8. So let's check that. See, it is producing 8 only. Okay. So the same thing will work for right shift also. So in this case, if you are shifting it left side, this is going to be 8, and if you are shifting it right side, this is going to be 0. Why 0? First, let's see the output here. See, it is 0, and the reason would be like we know how to write this 1. Okay, so this is the binary representation of your 1 with, assume you are having this 28 bits as zeros, okay, here. So this is how it would look like. And if you are making it right shift 3 times, so as we know, this is like this whole boundary. If you will make it one shift, this one will get lost here, so everything is 0. So it doesn't matter how many times you do right shift and left shift, zeros are always zeros, okay. That's why it is producing 0, okay. So that's it. I think I made this video so long, so if I bored you, so sorry for that. But if you think you learned something, hit the like button and share this video with your friends. So I'll see you in the next video. Bye bye. Hello there, this is Rupesh and you're watching C2 Minutes video series on C++. And this video is about pre-increment and pre-decrement. So we'll see what is pre-increment and pre-decrement operator here. So this is pre-increment and this is your pre-decrement, where this a is some variable like integer a here, okay. So what is the meaning of this plus plus here? Actually, whenever you write like this pre-increment and pre-decrement, or if it is like post increment and post decrement, so this is the post increment and post decrement. Actually, we are not talking about this right now. This is explained in the next video. So just you remember this is pre just because this plus plus is coming pre to a, and this is post because this plus plus is coming after this a, okay. So we will not talk about this. And what is the meaning of this plus plus a and a plus plus? So this implies this a is equal to a plus 1, okay. So if you're writing plus plus a, which is nothing but a is equal to a plus 1, and if you're writing a is equal to a minus 1, which is nothing but minus minus a, okay. So let's suppose if you want to increment your variable by 1, either writing this expression, you could have just simply written this one, okay. And if you want to decrement your variable by 1, instead of writing this one, you can simply write this one, okay. So this is just a shorthand for this one, okay, and this is shorthand for this one. So let's take the look in the code here. See, I have given a code like so. We are having this a here is equal to 10, and we are pre-incrementing it. So this is nothing but a is equal to a plus 1. So in that case, this a should be 11 here, right? After that, you are decrementing it. So it is decrementing by 1. So this should again get 10. So here it should be 11 and here it should be 10. So let's go and check this. See, it is 11 and 10 here. Okay. So as I told, this will increment it by 1. This will decrement it by 1. So you can do lots of operations also, like you can assign this value into some b here, okay, and you can print that b. So we'll print now like b and b here, and the same result will be in b here, okay. So let's check that. See, 11 and 11 here, okay. But what if you want to increment by 2 or 3 or something? Then what would be the situation here? So there is a way. It is like a plus is equal to 2. Then this a will get incremented by 2 here. Let's check this. So if you will print this like a and giving a here, and you print this. So let's compile this, and as it is incremented by 2 here, see, it is giving 12. It was 10 incremented by 2 here. So this is a shorthand for writing increment in your variables. You can increment by any value, okay. And same will work for decrement also, like a minus is equal to 2, okay. So it will become 8 now. See, it is 8 now. Got it? So this is nothing but your a is equal to a minus 2 here. How this minus minus a is equal to a minus 1 here, and plus plus a is equal to a plus 1 here, okay. So like that, if it is a minus is equal to 2, this is a is equal to a minus 2 here, okay. So whatever the number is, if it is 5, this will be 5. So like this, okay. So as equal for this a plus is equal to 2. So if this is like this, then it will be like a is equal to a plus 2 here, okay. So
this is for incrementing by 1 and this is fixed. This is going to increment by 1 only. But if you will choose this way, you can increment by any number. Okay, you can increment even by 1 also. Okay, no problem. So this is pretty good, right? And you know what? There is a very big difference in between pre and post. Actually, I was explaining here pre increment and pre decrement, right? Which was like plus plus a and minus minus a, right? So this is pre. So why it is called pre and what is the significance of that? I won't be able to explain that typical significance of pre because I have not explained post here. So the plan is like you go and watch next video which is about post increment and post decrement, and there is a separate video which will talk about the difference between post and pre. Okay, there I have discussed the main difference between pre and post increment and decrement. Okay, so go ahead and watch the consecutive videos to get the whole concept. Okay, so I'll see you in the next video. Welcome back. This is Rupesh and you're watching CVPNet's video series on C++. And in the previous video we saw that how to deal with pre-increment and pre-decrement. And in this video we'll be seeing about post-increment and post-decrement. Okay. So as it is post, let's suppose we are having this integer variable, let's suppose a here, and as it is post it will be like this one and this one. Okay. So this is nothing but a is equal to a plus 1 here. If you have watched my previous video, you will be able to understand this little quick here. Okay, so better I recommend watching this video before you go and watch my previous video of this video. Okay, so we know that if it is a plus plus, the expansion of this one is this one, and if it is a minus and minus, this is the expansion for this one. Okay, and why it is post, this plus plus is coming after a. Okay, that's why it is post. Got it? And the same for this minus minus also. Okay. So here we can see that this is post increment and this is post decrement. So this is nothing but a is equal to a plus 1 and this is nothing but a is equal to a minus 1. So like this. So let's compile this and try to understand what is happening here. So before that I'll tell you that this is a is equal to a plus 1. So this will become 11 and we are decrementing it. So this will again become 10 here. Okay. So let's check that. See. It is first 11 and then it is again 10 here. Okay, but you know what, there is some magic when you use post increment and post decrement. So let's see that magic, and that magic happens when you use some another variable and you initialize that variable with this expression here. Okay, so we can use it like this, c is equal to a minus 1 here. Okay, so let me write this everything, then we'll understand it. So this is your program and we'll be understanding that magic with the help of this one. So let's run this, then only we'll discuss about that. So what you expected, a is 11 here, but b is 10 here. So what is happening here? See, after that this minus minus is resulting c as 11. So this c is 11, but a is 10. So what is this? So let's try to understand it this way. And yes, that magic whatever is happening here, like a is equal to 11 but b is 10. Okay, so you was thinking maybe it will be like a plus plus, so this will become 11 and 11 will go inside b. So a is also 11, b is also 11. Okay, but this a is 11 but b is 10 here. So this magic happens when you initialize your post expression into some another variable. Okay, so we'll see the reason behind that. So whenever it is like b is equal to a plus plus, it works like this. Computer does break up here. Computer does like this. B is equal to a and then a is equal to a plus 1. That's why your a was incremented, but b was the a's old value. Okay, see here. B was old value, which is this 10 here, and a was incremented. So this one expression will get replaced by these two expressions. Okay, so it works like this, and same for this minus also. So if it is like c is equal to a minus minus, computer will break this into something like this.
c is equal to a here, and then a is equal to a minus 1. Got it? But why it is doing like this? Actually, the convention is, if it is post increment or post decrement, then it should decrement later. First, it should initialize whatever the value is. Okay, so what is the value is a here? It is 11 here because it is incremented. Okay, so that 11 will come first here, then only a will get decremented. So that 11 is coming here, then this a is becoming 11 minus 1, 10. Okay, and same for this. If it is post increment, you increment post before you just assign whatever the value is. Okay, that's why this b was 10 and this a was 11 here. Okay, so this is how this post increment work, and there is no magic in pre increment. If it is like this, so this we was talking about post here. Okay, if we will talk about pre here, that pre is something like this. If that pre is plus plus a here, then computer will translate this into one single line only, and that line would look like this: b is equal to a is equal to a plus 1. So see, if you will start executing this line, you will see I am supposed to initialize this b with a. So, but this a is not the final value. I am supposed to change this a with some another expression. So you will come here. So there is no further expression. So you will evaluate this expression. So let's suppose your a is 10 here. So this is like 10 plus 1, 11. So 11 will go here. So that 11 will come here. Okay. That's why this a and b both would be having the updated value. But that is not the case here because it is breaking into two different statements here. Okay. So this is the difference between pre and post. Got it? Actually, I was thinking that I'll be creating a different video for the difference, but that is not a very big thing. So I have concluded that here only. Okay. But I may keep a quiz video to explain different cases and different questions possible with this pre and post. Okay. So that you can expect. So we are done here with pre and post increment and decrement operators. Okay, so let's look at the next video now.
Hello friends, this is Rupesh and you're watching CPNet video series on C++, and in this video we'll be learning conditional operators in C++, and this is the syntax of using conditional operator, which is also called a ternary operator. So ternary means 3. So it requires 3 operands to work with. Okay. So if you have seen these steps like a is equal to b plus c, then this plus is a binary operator. It requires b and c to work with. Okay. This equal to is also a binary operator. It requires left hand side and right hand side. So same way, this ternary operator requires 3 things to work with. Okay, so we'll see that how it works. So let's suppose you have some variables like a is equal to 1 and integer b comma c, and b is like 10 and c is, let's suppose, 20. Okay, so if you want to use this operator, this is the syntax of using this. You will be saying that a question mark b colon c. What is the meaning of this? So the meaning of this expression is your first place is true, then execute this statement, otherwise execute this statement. Okay, so it's like this. You have this expression 1 question mark expression 2 colon expression 3. Okay, now if you have achieved true here, then you will consider this one, and if we have got false here, then you will consider this one. This is the only meaning of this ternary operator is. Okay, true this one, false this one. That's it. Whatever it is, if it is expression, you can write it like this also, like a is equal to 1, then you can see that this expression is true because a is 1 and we are comparing is a is equal to 1. Yes, it is. So we produced true here. So if true is produced, this b will get executed. And what do I mean by executed means? Like this. If you have some another variable, like suppose k, then b will be assigned to k. Okay, if this expression is true. So let's run and check this whether it is working or not. Okay, so we can just simply print this k. We will get to know that. See here, we got 10. 10 means b. So b is going here. Let's make this one false. Instead of 1, we can compare it with 10. So this will become false now. So let's compile and run this again. See, this time it got 20. 20 means C. So as I said, first position, this one is true, you will execute this one. If it is false, you will execute this one. Okay. So not only this, you can do lots of things with this ternary operator. You can make it like this also, like if a is equal to 1, like this, and if this is true, then print something, or if it is false, print no. We can just run this. See, we got yes. Okay, so I'm not giving any new line here, so it is printing here itself. Let me give some new line here. See, this time it is yes and 20. So this is printing yes because a is equal to 1. Now let's change this. Then you will find that it is printing no. So we are clear, right? If this statement, the first expression here is producing true, then this. If it is producing false, then this. That's it. And not only this, you can use nested also, like if a is equal to 1, then here you can again use b is equal to 10, then print yes. Let me write this. Otherwise, print no. Okay. Let me just copy this one and paste here. Okay, so this is nested, but we are not done here. This question mark need another colon here, and you can say that printf a is not equal to 1, something like that, not equal to 1. Okay, so if a is equal to 1, let me give some space here. So if a is equal to 1, in this case we will go here. So this is what we will run. So inside this again one ternary operator can be used. Inside that another can be used. So you can use it in nested way also. So as this is true, you will execute this one. And if it is false, you will go directly here. Skip everything which comes between question mark and colon. Okay. So let's run this as well. See, first it is printing no, because a is equal to 10. Let me comment this one, and let me comment these all things. Just this one. See, it is printing yes. So a is equal to 1. Yes, it is. So it will go inside this. B is equal to 10. Yes, it is. So it is printing yes. Let's make this one 11. So it will print no now. See, now it is printing no. So I think you got this video. So we are done here. If you like the video, don't forget to hit the like button, and if you haven't subscribed yet, go for it. It would help me a lot. Okay, thanks for watching. I'll see you in the next video. Bye bye.
Hello there, this is Rupesh and you're watching CPPNet video series on C++, and in this video we'll be learning about sizeof operator. And we'll be considering these things 1, 2, 3 and 4. First we'll see the size of class and struct, size of the array, size of inbuilt types like integer, character and all that, and the size of the pointer. This is also a very important part. Okay, so let's start with the classes, but before that let me tell you, if it is 1 byte means it is 8 bits. Okay, so 4 bytes means 32 bits. Okay, so let's keep this here for the reference. Okay, And in case if you don't know what is the size of integer, what is the size of character, let me write that for you. So if it is integer, int, it is 4 byte. Yeah, I'm going to give you the data of your inbuilt types. Okay, so integer is 4 bytes, character is 1 byte. And one more thing to remember, your size of operator always returns bytes, not bits. Okay, float 4 byte and double 8 byte. Okay, so this is your basic data, and this is another basic data. 1 byte means 8 bits, 4 bytes means 32 bits. So let's write the class first. Class base, and if you are keeping integer x and getting the size of x, I mean base class, then it would give you 4 bytes. Okay, let's compile this. See, it is giving 4 here. Okay, why 4? Because integer is of size 4 byte. Okay, so if you will make it like integer y, it means 2 integer variables, it is going to be 8. Okay, C. But if you will include a character C, then it will become 12. Let's see that. And the reason is this happens because of the structural padding concept. So if you don't know what structural padding is, I'll be giving the link in the description field. In case if I forget, please ask me. Okay, so this is how you calculate the size of your class. Okay, not only by writing the class name, you can use the object also. Okay, so if it is base class object O, and if you'll write that, you'll get the similar output. Okay, so instead of class, you can write struct. Okay, and it will give you the same output, because there is no much difference in between struct and class in C++. Okay, C struct is different than C++ struct. Okay, there are two different struct, C struct and C++ struct, so don't get confused with that. So we saw the way of getting the size of your classes. Now let's move to the array. So remove this base function. Let's suppose you are having some ARR of few elements like 1, 2, 3, 4, 5, and you want to get the size of this array. Okay, like size of ARR. Let's print this. It is 20. Why it is 20? As we are holding integer 5 elements, and I told you that integer is of 4 bytes, so 4 into 5, 20. Okay, so this array is holding 20 bytes. If you are passing this function, I mean this array, into some function like this, and you want to get the size of your passed ARR there, you won't be able to get that. Okay, so if you are getting it like here, integer ARR, then you won't be able to get the size of your array there. Okay, what's the problem? It is giving you the warning. Actually, there is no error. It is just the warning saying that size of an array function parameter ARR will return the size of integer pointer, and that's what I want to tell you. Okay, see, the result is 4 bytes. So why it is happening like this? Why it is not giving you 20 here? The reason is your compiler knows the size of your array in that function only where it was created. Okay, so this ARR was created in main, so if you write size of, it will calculate the size correctly, and this case is for arrays only. Okay, not other data types. So this array size calculation in different function is not possible. That's why we pass another parameter in the function like size. Okay, so here we will get the integer size if you want to process this array inside some another function. Okay, that's how we implement the array passing. Okay, we pass the array pointer here and pass the size explicitly, and how we calculate the size of the array is like this: integer size is equal to size of your full array and then size of one element, ARR of 0. Okay, so here you will get how many elements are there in this array. Okay, so we will send the size here and we will get size here. Okay, and this time I'm talking about the elements in this. This size denotes how many elements are there, because the result of this size of ARR would be 20 and result of this would be 4. So 20 divided by 4 would be 5. So we know how many elements are there inside this function by passing this size here. Okay, and we already know the type because we are passing that array with this integer. Okay, so whatever we needed is there in this function. Now you can iterate over this array inside this function. Okay, so that's what happens when you deal with the array in different functions. Okay, so I think this array topic is completed. Now I don't think we need to go for the inbuilt type, because I have already told you that the size of inbuilt integer is 4 byte, character 1 byte and all that. There are other data types like short and long, but I won't discuss those data types. You go and check how many inbuilt data types are available in C and C++. Okay, how the size of operator work, we are discussing that part only. Okay, and one more thing I wanted to tell you, that size of operator look like it is a function, like size of, and you are passing this array and getting the size of this particular array from some size of function. But let me tell you that this is not a function, this is an operator. Okay, operator means how you use this plus, minus and all that. In the similar way, this size of is also an operator, and this is evaluated at compile time, not runtime. Okay, so if you are writing size of and your compiler is compiling this line and this line, and when your compiler will encounter size of array, at compile time only it will check what is the size of your array. Okay, it is not going to wait till runtime. Okay, that is also a very big point about size of. So let's look at the pointer now, and if I miss something, tell me that, I may include in some other videos. Okay, so now let's look at the pointer case here. If you have an integer pointer p is equal to new integer, and let's suppose you want value 10. Okay, and you want to get the size of p, it is going to be 4. See, and why 4 I'll tell you in a moment. So let's create a double pointer d is equal to new double, and there we will have 15.3. okay, and we will get the size of your double, and that's it. And let's compile this again. See, you're having 4 and 4, but as I said, this double is of 8 byte, but still the pointer of that double is printing 4 byte. Let's have another example. Let's create character pointer. Character pointer c is equal to new character, and let's suppose we are having a in that, and let's print the size of your character also. Okay, this is also going to print 4 byte. So why this 444? If you are printing the size of object itself, I mean the data type itself, it will be different. Let me show you that. Cout size of, instead of d, you can dereference the value in that, and this time you will be getting 8. Okay, so the value is 8 byte, I mean the double, but the double pointer is still 4 byte, and all the pointers are still 4 bytes. Why it is like that? So let me give you another example here. If you are dereferencing pointer c, then this will give you 1. See, first you created for the pointer, so it is giving 4, but second is 1, so this is giving you 1. So this is exactly how I told you here. Okay, but why this much difference? The difference is there because whenever you print any pointer, this one, and this one, you will always get 4 byte. Whatever the pointer is, doesn't matter. Okay, even if it is holding 1 byte data, we know character is of 1 byte, but still the pointer of that character, which is this one, would always be a 4 byte, but it would be 4 byte in 32-bit operating system. Okay, so if your operating system is of 32 bits, means 4 bytes, then your all pointers would be of 4 byte. Okay, but in case if your OS is 64 bits, it means 8 byte, then your all pointers would be of 8 bytes. Okay, so it depends on your operating system, what type of operating system you are using. And from where does this 4 byte size comes? Actually, there is a RAM. We all know because we know that. Okay, so this is the value part of your RAM. So this is value, and here is the address from here to here. Okay, and it start with 0 cross something something something, but this address is of 32 bits in 32-bit operating system, and the same this address is 64 in 64-bit operating system. Okay, so whenever you apply size of on some pointer, it will always give you what is the size of your address part in your RAM. Okay, and that depends on 32-bit and 64-bit operating systems. And as I said, classes and structs have little different size of calculation because there is something called structural pairing. Okay, and if I have not included this video's link in this video's description, please ask me for that because I may forget. Okay, so let's look at the next question now.
Welcome back. This is Rupesh and you're watching C++ video series on C++. In this video, we'll be learning about switch case statements. So before this, we saw how to use if and else statements and nested if and else statement. But there are some drawbacks of using if and else because when it comes to lots of conditions, like the requirement could be like user will give input from 1 to, let's suppose, 100, and if user is giving 1 as input, you perform some set of operations like this. If user is giving 2, then you perform another set of operations, and if user is giving 3 as input, you perform some another set of operations. Okay, so like this, if it goes to 100, then using if and else, like if else and if else, if else, if else, will make your life so tough that you won't be able to manage your program. Okay, so when it comes to these many conditions, then we should go for switch case. So let's try to see how it works. So instead of taking 100 input, we can use 3 or 4 inputs and we can simulate the requirement here. So integer, let's suppose we are keeping the variable name as well here. We are taking the input from the user, and this is the syntax of using switch cases here. So let me write it first, then we'll understand. So this is your whole program here. So as you can see, this is your switch and case statement. Okay, and as we told, the requirement was if user is giving 1, you execute some set of statement. If user is giving 2, you execute some another set of statements, and if it is 3, you give another statements. And let's suppose user is not giving either 1, 2 or 3. There is this default case. This default case will get executed and will get printed something, whatever you want to print. Okay, so there is a default case here. Okay, so default case will execute some another set of statements. Okay, so if it is 1 here, so we'll check it like this.
there is this cn. We know how to use this cn, and val, this is our variable. This val will have some value given by user, and then value will be checked in switch statement here. So we will have to write it like this, switch and then that value. So this switch will compare this value whatever we have given with these cases here. Okay, case 1, case 2, case 3, and if it is not getting any case, it will execute this default case. Okay, so it works like this. Let's suppose user have given input as 1 here. Okay, so 1 will come here, we'll check case 1. Yeah, this is matching with that 1. So this is the 1 which will match with this one. So yes, it is true. So inside this, whatever is there will get executed. Okay, so this is the syntax. Like you have to give this colon here and write your statements, and after ending whatever you wanted to do, write a break statement here. See, everywhere we have this break statement. Okay, so we had entered 1, we came here, we printed this like this is 1, and then we hit this break here, then this whole switch will break and will come out of this. Okay, and let's suppose you are printing something here after this switch, which is this ending here. We can print whatever you want to print here, or whatever operation you want to do after this switch. Okay, once this break will execute, we will come out. Okay, so let's run this. It will be very easier for understanding. So this is the same program here. Let's run this. As it is asking me input, I will give 1. See, it is taking this is 1, so I gave 1. This is asking me the value. I give the value is entered into this variable which is of type integer. Okay, now that value will be checked here and will get compared with these cases. So first it will come to this case and it will check whether it is 1. Yes, it is 1. So it will go inside this and it will print this. Okay, now after printing there is another statement, this break. So once this break is encountered, we'll end this. So if you want, I can print something here like end of program. Okay, so if we will run this now and give some another input, we will be able to see, like let's suppose this time we will give 3 here. So let's give 3, hit enter. See, we are coming inside this, and how we are coming? It is coming first at case 1. It is checking whether this 1 is equal to this 3. No, it is not equal. So it will go to another case. This 2 is equal to this 3. No, it is not equal. It will come here. Then this 3 is equal to this 3. Yes, it is equal. Then only it will go inside this. That's why it is printing this is 3. Okay, and once it is printing this one, next statement is break here. So it is breaking from this whole switch and it is coming out. This is how the whole this switch thing work. Okay, and let's suppose you are not giving either 1, 2 or 3. Let's try to execute this default case here, and in order to run this default you will have to give some another value. Let's suppose you are giving 10. So see, it is executing this default case now because 10 is not present in either of these cases. So it is running this default. Okay, and after running it, it is breaking and coming out. So let's try to understand, if you will not write this break, then what will happen? So let's suppose we'll remove this break from here, we'll remove from here, here and here, and execute the program. And let's suppose you are giving input as 1 and hit the enter. See, this is the problem here. If you are not writing break, then it will enter into one case and it will keep on doing all the statements written after that because there is no break. So 1, yes, it is true, it will come inside this, and this is printing this is 1, this is 2, this is 3, and this is default. Everything is printed. Let's suppose if you are not having break and you are giving 2 as the input. So it will not go inside this 1 because this is not matching. It will come here and it is matching with 2. This time it will go inside and it will keep on printing everything. So see, it is printing 2, 3 and default. That 1 is not coming now because it is not going inside 1.
because it is 2 here. Okay, so that's why we write break. Okay, and there are some restriction with switch case. You cannot use it with floating point number like 1.7 or 5, and if you are writing it like 1.7, which is like 1.7 is equal to 1.7, or this VAL is having 1.7 and you are writing VAL here, what we was doing before. So this is not going to work because it doesn't work with floating point numbers. Okay, it works with integer numbers and characters. Actually, it works with the integral value. If you don't know what is integral value, we'll see in the coming videos. For now, you just try to understand that not the floating point numbers, not string, nothing, just the integral values, which is like 1, 10 and all that. Okay, and yes, character also work. Like we can have that example also. Let's suppose this is a character and you are giving some character here, and we know how to use this character thing. Let's suppose we are having it like this, and at last we are having, let's suppose, this C here, and we're done. So this is A, this is B, and another one is C. Okay, so this is okay. You can do this character stuff. Okay, so let's give some input. A, hit enter. As you can see, it is going into default case. So this is default and the input is not matching. Why? Because this A is a case sensitive. This is a capital A and you are giving small a. That's why it is not matching. So let's try it again. This time you give capital A here, then it will work. So let's give this capital A, hit enter. See, it is coming inside and it's telling that this is A. Okay, so I think I have covered almost everything. If something will be left, I'll cover in the next video. So now we know how to use these switch case statements. Let's look at the next video. Welcome back. This is Rupesh and you're watching CPP Net's video series on C++, and in this video we'll be learning about for loop. So first of all, try to understand what is loop. So when someone tells loop in your program, it means something like this. Keep on rotating. Okay, so we call this a loop, right? But in our program, we have three things to maintain these loop. Okay, so first one is start. So this will tell from where your loop will start. Okay, and another thing is where it will end, and the middle part is executing the statements. Okay, let's try to understand it like this way. You want to print some message 10 times, then you will be writing like Cout and that message, and this thing you will repeat for 10 times. Okay, like this, and the last Cout, which will have the same message. Okay, so this is first time and this is ninth time, so all this between is 0 to 9 means 10 times. Now let's suppose you want to print 100 times, then you will have to write this single statement 100 times, right? Like Cout the same message. Like let's suppose you are printing C++ and you want to print this 100 times. Okay, so 0 to 99 means 100. So are you going to write it that many times? Is there any way to write it little shorter way? Yes, there is a way, and the answer to that is your loop. Okay, so let's try to understand this, how this loop work. So for that I'll write a very simple program which will take the start and the end of the loop. So for that we need one variable. Let's suppose I here. Okay, and you will initialize it with 0, and let's suppose there is another thing called for loop. I will be 0, I less than 10, I plus plus, and then you are printing your message. What message you wanted to print? Let's suppose I was telling you C++, right? So we are printing C++. Okay, so no need to take variable value here. Yeah, so this is going to work as you want it. Okay, so this is going to print C++ 10 times. Okay, 0 to 9. I is less than 10. So we'll understand this little later.
First, let's print that. So count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is total 10. So let's try to execute this line by line here. So first you are coming here. You are declaring a variable name I. That is okay. There is this white space, nothing is there. You will come to this. This is a for loop. Okay, and this is the syntax of writing that. There are three portions: first portion, second portion, and third portion. So let's number them. So I'll tell you how this whole thing will work. This is for loop. It will come here and it will initialize I is equal to 0 first time. So this will execute. So I is having 0 now. So let's initialize it with 0. Okay. Now second statement will execute and it will check I is less than 10. Yes, this 0 is less than 10 here. So this is true and it will go inside this loop. This is not going to go inside this third statement. Third statement will come once this loop is over. Okay, so after checking this second condition, yes, it is true, it will go inside loop, and inside loop we have this statement. So this will execute. Once it is executed, and let's suppose there are other statement also, those statements will execute it, and once it will hit this AND bracket which tells that this is the end of this for loop. So the start is this one and AND is this one. Once it will hit this AND, it will go again back. So this time it will not go from here. This time it will go from here. This is very important point. And it will execute this one now. So I++ will get executed. We all know what is this I++. This I++ is nothing but I is equal to I plus 1. Okay. So I will get incremented by 1. So this time I is 1 here. Now after executing this one, it will go to this one. Remember this step. First it came here, it executed this one, I was initialized with 0 here. Then it went here, I was less than 10, yes it is true. Once the condition is true, it entered into the loop, executed whatever the statements was there, it hit this end of this for loop, it came back from this side and now it is executing this I++. It is executed, now it is again going to check this condition. Okay, then this 1 is less than 10 here, yes it is true. If this is true here, it is again going to enter into your loop and then it will again execute your Cout. Okay, once it is executed, it will hit this end of this for loop, then it will again come here like this and it will increment I++, which will make this 2 less than 10. So this is 2. Now again it will go here. So it will check I is less than 10. Yes, 2 is less than 10. Then yes, you are allowed to insert inside loop. So it will again execute this C++. Once it is executed, it will hit this for loop end bracket. It will come back again this way. Okay, execute this I++. It will make it 3. Then this I will get checked. It will go to this one again and it will check I is less than 10. Yes, it is less than 10. It is true. If it is true, it will again insert. Did you notice this is not coming now? This I plus 0 is not coming now because this is one time execution. Later on, we'll be dealing with this one and this one only. Okay. So this is how this whole thing works. We need a variable like I to simulate some loop here. Okay. So this is very easy to understand. Okay. So instead of this plus here, we can use minus code also. So let's check how to work with that now. So instead of plus, we can use minus. But for that, you need this I is equal to 10 here. And then I should be greater than 0. Okay. So this will work now. So we can execute this now. Let's execute this and see the result. Again, the same 10 times C++ is coming. Okay. See. So it is just a logic. So as I told, your first statement will execute one time only. So this I is equal to 10 will execute one time. So let's write it like this. This will get executed.
this is first, this is second, and this is third. So this will get executed I is equal to 10. So initially I is equal to 10 here. Okay. Then as I told, after executing this one, it will go here. So I is greater than 0. Yes, it is greater than 0 because it is 10. So is it greater than 0? Yes, it is true. So it will execute your Cout. Okay. I mean, it will go inside your loop. So it entered inside loop, executed this statement, whatever statement we have written. There is only one statement, that's why it is printing only one thing and executing only one statement. If you will write 10 or 1000 or more than that statements, it will execute that. And once it will hit this 4 ending bracket, which tells that this is the limit of this 4 and this 4 start here and end here, so it will come back. So as I told, once it is hitting this, it will come back from here and will increment this. But in this case, it is going to decrement because this is I minus minus. So I minus minus is like I minus 1. Okay. So I is equal to I minus 1. Got it? So this time I will become 9 here. So after executing this one, we'll go here and we'll check this I is greater than 0. Yes, it is true because I is 9 and it is greater than 0. So it will again insert into this loop. So likewise, it will keep on coming and executing, keep on coming and executing. So it will execute 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 times. So when it is printing 10 times, so that time I would be I is equal to 1, which is greater than 0. So it printed that. But when it is printing last time, it is again coming back and I is equal to I minus 1, which is this statement is making this I 0. Okay, because one time it will become 0, right? It is keep on decrementing. So as it is 10, 9 and one time, like it is going from here and here, it will become 0 sometime. And then this condition will come and we'll check, is it greater than 0? No, it is not greater than 0. So once this condition is false, this for loop will terminate and will come out of this. So out of this means whatever the boundary of this for loop would be will come from that. So will come from this whole program, whatever is this much, and we'll start executing from here. But there is no line in here, so we'll just return. Okay. So this is how this whole thing execute in for loop. So this is how this for loop work. Got it? This was a very basic video about for loop. If you want to learn advanced thing about for loop, watch out my next video, which is about quiz on for loops, which will help you out to understand this for loop even better. Okay, because there are lots of corner cases, like if you are not writing this one, then what would happen? If you're not writing this one, what would happen? If you're writing this I minus minus here, then what would happen? So lots of things are there which I don't want to cover here because it will get so much messy, because someone might be looking just for the sake of knowing what is for loop. They don't want to get into that much. But there are few people who want to master everything in programming. So if you are that kind of people, watch out my next video. Okay, so I'll see you in the next video.
Hello guys, this is Rupesh and watching CPP Nuts video series on C++, and in this video we'll be learning about while loop in C++. So this while loop will be common for C, C++, Java, Python and mostly all the programming languages. So if you learn this, it will be really very easy for you to understand all those loops. Okay, so let's start it. First of all, what is the use of loop in C++? And if you don't know what is loop, this is loop. Okay, keep on doing something again and again. Okay, so this is what the looping is. And what is the use of this kind of loop in programming? I'll show you that. Let's suppose you want to print CPP nuts for, let's call 100 times. Then what are you gonna do is like Cout this 100 time. Are you going to write this from 0 to 99 time in your program and run that? No. What you will do, you will create a loop, okay, and you will say that, okay, dear loop, run from 0 to 99, it means total 100 time, and execute this statement. So Cout whatever the expression you want to print, let's call that CPP nuts, and you're done. Okay, this loop will do the job and you have to write only one time. I'll show you the expression here. This is how the code expression look like. I told you if you want to print CPP nuts 100 times, so let's keep that for 5 times for simplicity. Okay, and this is how you create the loop. This is the keyword for writing loop. You will write while, and inside this round bracket you will write the terminating condition. Okay, and the terminating condition is x should be greater than 0. So initially you initialized 5 with x and you checked 5 is greater than 0. Yes, it is true. So if it is true, then only you will come inside this loop. Okay, so initially x is 5, so 5 is greater than 0. Yes, it is true. You will go inside this. Okay, so this is the start and bracket. This is what defines the loop. Whatever is coming in between this start and end is considered inside loop. So this line and this line are inside loop. Okay, so there are other ways of writing this loop. Actually, you can write it like this also. Okay, so this is your start bracket, this is your end bracket. It doesn't really matter where you are writing this bracket. Okay, this can be here and here also. Okay, but only one starting bracket and end bracket. And here comes the condition. So our condition is x should be greater than 0. Yes, it is true. You will come inside, you will print CPP nuts one time, and after that you will decrement x by 1. So x will become 4 now. So as you will hit this end bracket, you will again go up. This is how while loop work. You will go here. Now you will check the x value. X is 4, 4 is greater than 0. Yes, it is true. You will come inside again, print CPP nuts again. Now after printing this, you will do x minus 1. So x will become 3. Okay, because you are decrementing x by 1 and initializing the new value inside x itself. And after this, you will again go here. So 3 is greater than 0. Yes, it is true. Like this, you will be like 2, 1, and once it will become 0. After this, you will come here and you will check 0 is greater than 0. No, it is not. So this whole while loop will get terminated. Okay, and you will come out from this loop and you will execute the next statement, and next statement is this return. So you will complete your program and you will go back. Okay, so let's run this code and we'll see it is printing 5 times. See, 1, 2, 3, 4, 5. If we increase this, let's call this 10 times, it will print 10 times. Okay, let's compile this. See, it is printing 10 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is how the loop works. As I said here, you will create a single loop and you will put whatever you want to execute n number of time, and you will define that n and run till that time. Okay, so I think we are done here. Thanks for watching. I'll see you in the next video. Bye bye. Hello friends, this is Rupesh and you're watching CPP Nut video series on C++, and in this video we will be learning about do while loop. Okay, so if you have not watched my previous video which is about while loop, then I strongly recommend please go and watch my previous video and you will get the link in the description field. So don't worry, go ahead and watch that first. There I have explained what is loop and how it exactly work in languages. Okay, and why do we need that. So if you'll see that, it will be real fun for you to understand this do while loop. Okay, so I hope you know while loop before going for do while loop. Okay, so as we know, while loop work like this. This is start and end, and here comes the statements you want to execute n number of time. Okay, so this is the structure of while loop. The do while loop is also doing the same thing, but it look like this. Do starting bracket and bracket, you will write while here and then round bracket similarly, and your condition, your condition is x should be greater than 0. And one more important point, you have to remember this semicolon here. Okay, and this is what your do while loop look like. Okay, and this is called entry control loop, and this is called exit control loop. So let's see why it is called entry control loop. Let's suppose you are not having n here. There is some expression like x should be greater than 0. Okay, and before entering inside this loop, you have something like integer and x is equal to 0. So after this statement, if you are going to execute your while loop, and as it is entry control loop, it will stop you in the entry area. Okay, so it will say that you are not allowed to enter inside while loop. Okay, so if this condition is false, you will run statement after this while loop, but you will not go inside this. So this is controlled inside entry time. Okay, but this is called exit control loop because the condition checking is happening at exit time. Okay, so let's suppose this is the statement before executing your do while loop, and as it is the same value for x, we'll come here and we'll execute whatever is there inside this loop one time, and after executing everything for one time, we will check is x is greater than 0. If that condition holds, we will go back and we'll do all those things again and we'll check this again. Okay, and let's suppose this x is equal to 0 and you wanted to print, let's call CPP nuts, and you printed that. After that you check x is greater than 0. No, then you won't go back, you will terminate. So that's why this is called exit control, because we are having this condition check at exit time. Okay, this is your exit area, this is the entry area, so that's why it is called exit control loop, and this is how it works. So let's see the program here. So if you have watched my previous video, that also looked the similar program. Instead of do while, we had while there. Okay, so let's understand the working of this. So before working, we'll compile this and we'll say, see, 1 2 3 4 5, so 5 times it is printing. Okay, and exactly doing the same thing. And as I said, if this x is 0, then also this will print this statement, and for that case just comment out this statement here, and if you'll run this, see, it still executed our CPP nuts one time and then only it is exiting. Okay, instead of this, if we are using while loop like this and x is greater than 0, it's checked and we are supposed to print the same message CPP nuts, then it will not print this. Okay, so let's comment out this whole thing and we will just run this one and we'll see nothing is happening. Okay, let's compile and see, your finished message is coming but nothing is printed. So this is entry control and this is exit control. Okay, I hope you enjoyed the video. Thanks for watching and I'll see you in the next video. Bye bye.
Welcome back. This is Rupesh and you're watching CPP Nuts video series on C++. And in this video, we'll be learning about what is goto statement. So goto statement is always used for jump. Okay. So let's see what is jump here. Let's suppose you want to execute this one, but you don't want to execute this one and this one. You directly want to execute this one. Is it possible? Yes, it is possible. But without goto, you will have to either remove it or write some another logic. But with goto, it is really simple. Without removing these two lines, you can directly execute this one and this one without executing these two lines. Okay, so let's check this, how we can achieve that. So as I told, we want to print this one. So the syntax of that would be, you would have to write like goto and some label, like any label like A. Okay, and this label should be where you want this goto to come. Okay, so if you will start running your program would run like, it will come into this main function, it will execute this Cout, it will execute this goto and check where am I supposed to go. I'm supposed to go to A, and where is this A? This A is here. So these two lines will get skipped. Okay, so it is going to jump from this line to directly this line. That's why it will print 1 and 4, but it won't print 2 and 3. So let's check this. See, 1 and 4 is coming, 2 and 3 is not there. Okay, so this is the sole purpose of writing this goto in your program. But generally people don't prefer using this goto because sometimes it doesn't make a good sense. Okay, but I don't think there is some problem in goto, because if there is a problem, it won't be there in your programming language. Okay, so it has a significance, that's why it is there. Okay, so this was about goto, and this is how we write it. Okay, so let's recap it again. This is the syntax. Let's suppose you want to execute this line but don't want to execute consecutive lines, so you will put go to here and you will tell where to go. So you go to this A here, and this A is written here, that's why it is coming here, and you're printing 4. Okay, so this is how it works. So I think we're done here. Let's look at the next video now. Welcome back. This is Rupesh and you're watching CPNet's video series on C++. And in this video we'll be learning about what is break keyword in C++ or in C, because this is there in C also. So this break does what it tells. Actually it break the loop. Okay, and yeah, you cannot use this break without loop. So it has to be there inside loop only. Okay, like this. Okay, it cannot be without loop, like outside somewhere here. Okay, this is not a valid code, this is not going to compile. Okay, so let's write some logic like printing from 1 to 10, but when it is becoming 5 you break the loop. Okay, so we will write the logic for that. Integer I is equal to 0 while your I is less than 10. If I is equal to 5, you just break it. Otherwise, print whatever the value of I is. So we can make it a little fancy. I. Okay. So this is like you will be coming here. I is equal to 0. I less than 10. Yes, it is less than 10. It will go here. I is equal to 5. No, I is equal to 0 here. So it won't go inside this if statement. It will come here and print I. And yeah, you need to increment it also, like I plus plus. Okay, so now this will become plus plus. So I will become 1. It will go again back here. It will check I is less than 10. Yes, 1 is less than 10. So it will come back here. And now it will check 1 is equal to 5. No, it is not true. So it will not go inside that. So it will go till 5. And once it will hit 5 is equal to 5, it will break and come out of this loop and will print something like end of the program. Okay, so let's print this. See, it is printing from 0 to 4 and it is taking end of the program here. Okay, because this is becoming 5 here, it is going up. 5 is less than 10. Yes, 5 is equal to 5 and it is breaking it. Okay, so that's why you're not allowed to print your C out after this. Okay, so this is how it looks like. Got it? So we use break to break our loop. Not only while loop, you can use break inside for loop and do while loop also. So it should be in loop, doesn't matter what loop you are using in. Okay, so this was about breaking your loop. But what if it is inner loop, like one loop is inside another loop? So in that case, what should be the scenario here? So which loop will break? So let's check that out. So let's suppose if you are writing your while loop here, first while loop, and there is this starting bracket and there is some end bracket here. Inside this there is another while loop, okay, like this, and this is start here and end here. And let's suppose you're breaking it here, then only this loop will break. Like wherever this break is written, its immediate loop will break, not the upper one. Okay, so this will not break, only this loop will break. Okay, so let's suppose there is another while loop, like here another while loop is there and you are breaking So still it will be breaking this one only, not this one or not this one. But what if you are breaking here, like break here, then this is inside this while loop, right? So this break comes under this while loop, not this while loop. So this will break this while loop, okay? And if it is coming here, this will break your this loop, okay? So it will come out from all the loops, like this whole loop here, okay? So this is how it works. So we'll see one simple program so that it will be very clear for us. Let's suppose you're having this program here, which will be working like this. We have this I is equal to 0. So I will go from 0 to 2 because 3 will become false here. Okay. So in that situation, we'll break from this outer loop here. Okay. So let's run this first. We'll understand it a little better. See what is happening here. You're printing 0, 1, 0, 1, 0, 1 3 times just because your outer loop is working for 3 times and your inner loop is working for 2 times. See, this one is 2 times. So always j will be equal to 0 and j will be going from 0 to 1 and I will be going from 0 to 2. So that's why we are printing 0 to 1, 0 to 1 and 0 to 1 3 times. Let's try to understand the working of this because lots of people get confused like what will execute how many times. So initially this I is 0 and j is 0. Okay, so we are standing at this location while I is less than 3. Yes, I is less than 3 because it is 0, so it will come inside and integer j is equal to 0. So this is also j is equal to 0 now, and while j is less than 2, this is also true because this is 0, so it will go inside and print j. So this is resulting 0. Now we'll go to this line now and we'll increment the j. Okay, so j has become 1 now. We'll go again back because this is the end of the loop. So we'll go back and we'll check now. J is less than 2. Yes, it is less than 2 because it is 1 now. So it will again come inside and print j. So this will result 1. So after printing this line, it will come here and will increment the j by 1. So now j will become 2 here. So after incrementing j here, it will come to this line and it is end of the loop. So it will again go back. And now j is 2. So 2 is less than 2. No, it is not true, so it will become false and will come out of this loop. Okay, and then we'll execute this line here, I plus plus. So this whole thing resulted 0 and 1 as the output. Okay, when I was 0. Now let's see for I is equal to 1. So I is getting 1 here now. So I is equal to 1. Sorry, 1. We'll go back because this is the end of the loop here. So we'll go back from here to here now. So it will check I less than 3. Yes, it is less because it is 1. So it will go inside. J will become 0 now. See, and while j is less than 2, which is 0 less than 2, yes, it is true. So it will go inside again. And this time it will print again j as 0. So j was 0 and it resulted as printing 0 here. Now j will get incremented by 1. So j will become 1 here. Okay, we'll go back in the loop again and we'll check. Okay, 1 is less than 2. Yes, it is true. So it will come back again and j will get printed. So we are printing 0 and 1. Then again we'll be incrementing it. It will become 2. So see, whenever this j is becoming 2, we are coming out of this loop and going to increment this I. So this time again it became 2. So j is 2 now. So 2 is less than 2 here, condition will be false. We'll come out from the loop. We'll do this I plus plus, which will make this I is equal to 2 here. And once we executed this one, we'll encounter this bracket. So we'll again go back here and here. So 2 is less than 3. Yes, it is true. So it will again come back here and the same thing will happen. So 0, 1, 0, 1 and again one time 0, 1 will execute. And after again executing this 0 and 1, j will become 2 sometime here. This loop will get terminated. So like this it will work. Okay. Now let's put some break statement in between here and try to understand what will happen then. So let's suppose you are putting break here on some condition like if j is equal to 1, then break. Okay. So if I'm not giving any bracket like this one we used to give, right? So don't get confused, like we have not given bracket here. even if I am not giving bracket, this if will still work, and it will just consider this only one line whatever is coming after this if inside this if condition. Okay, so if I'm not writing these brackets here, this break is only considered as inside this if. Okay, this cout is not inside this. Got it? And no need to write this break after one tab here like this. Actually I write it like this because it gives you a good indentation and good understanding of your program here. Okay, so let's compile this program now and we'll get the output as 0 0 0. Okay, why? Because when you are printing 1 here, before that we have kept this condition. See, whenever we will go and try to print j, before that there is this condition, j is equal to 1, yes, then break. So this loop is getting break and we are coming again here, I is getting incremented by 1, while going back again. So like this it is happening. Okay, so as we can see, only inner while loop is breaking, outer while loop is not breaking. So if you want outer while loop to break, you have to write somewhere in the outer while loop, right here. Okay, so if you write break here, which is not inside this one, the boundary of this while loop is starting here and ending here, and the boundary of this while loop is ending here and starting here. So this is the boundary. So if you will write in this boundary, then only this break is considered for this one. Okay, so here we learn how break work inside inner loop. It will break your inner loop only, not the outer loop. Okay, so we are done here. Let's look at the next video. Welcome back. This is Rupesh and you're watching CPP Nuts video series on C++. And in this video we'll be learning about continue statement. So what is the meaning of continue in your program? Actually that is a keyword here. So we use continue in loops. Okay, so we have studied 3 loops: while loop, do while loop and for loop. So you can use continue in either of the loop. Okay, so let's look at the job of continue and we'll take the example of while loop here. Okay, so let's write some code and understand this. So we are having something like I is equal to 10 here. So this is your while loop. Execute this. I love plus C++ is coming 10 times here. Okay, so that is okay. But now let's try to understand the use of continue here. So let's suppose you are writing continue here like this. Okay, and let's execute this now. Oh my god, where is that C++ here? Nothing has come. So this continue does what it tells. So it will be like this. You will come here, execute I is equal to 0 and check, yes it is true because I is equal to 10 here. So I is greater than 0, yes it is true. You will come here, you will decrement it. So I will become 9 before it was 10. Okay, and then you will execute this continue, which will tell, okay, you go back. So continue means continue. You continue, don't go further here. Okay, you continue the loop. So it will come again here, I is equal to 9. It is okay. It will come inside, I will become 8, and this continue statement will again come. It will tell you go back. So like this keep on happening and you will be ending up to 0, which is 0 is greater than 0, so it becomes false. You will come out from this whole loop and we are just returning. So nothing is printing because you never reach to this statement. Okay, got it? This is the role of continue. Let's try to write some logic here. And I know you know how to use this if, so we will write it like, so let's try to execute this code now. See, it is giving you I love C++ 5 times. Why? Why? Because it started from the beginning. I is 10, 10 is greater than 0, yes it is true. I minus minus, it became 9. 9 is less than 5, no it is not. And you assume like there is this bracket like this. Okay, so it will not go inside this condition, so this continue is not executed. That's why C++ will get executed and it will go back here. I greater than 0, I was 9, yes it is greater than 0. It will come inside, this will decrement it. So initially it was 10, it became 9, now it became 8. So 8 is less than 5, is it true? No, it is not true, so it will not go inside this if, so it will skip this and you will again print this I love C++. So like this you will keep on printing for 5 times, like till 5. Okay, so 7 and 6. So once it will become 9 you will print, it will become 8 you will print, 7 print, 6 print, 5 print. So see, 1 2 3 4 5. Once it will become 4, so here it will be 4. So 4 is less than 5. Yes, it is true. So once it is true, it will go inside your if statement. Inside this continue is there, so it will execute continue. So it will tell you again go back here. Okay, so this I++ will not execute after that. So once it is become 4, after that it will become 3. So 3 is again less than 5. So it will again enter in this and it will again go back. Okay, so that's why this is coming as 5 times. Okay, so next 2 1 it won't come. Okay, and 0, that's why it was printing 5 times. Got it? So this is the use of this continue. So if you have some logic to implement and you don't want to execute further, if you have made some logic in your program or in your loop, you can use this continue statement here. This is very important. Okay, and yes, you can write continue only in loop. So it is allowed in while loop, do while loop, and only for loop. So it is not allowed in any other places. So if you will write it like it is an error. Okay, let's check this. See, this red symbol has come here. It is telling some error. So we can check the error message here. It is telling that continue statement with no loop. Okay, so there is no loop. So it is giving you the error. So as I told, you can use this inside loop only. Okay, but it doesn't matter you are exactly writing in inside loop or like this. This if is inside this loop, right? So you should not think like this continue is under this if. No, this continue is under this loop here. So if you will go up in the hierarchy, you should at least meet one loop, which is this while loop here. Okay, that's why it is allowed to use it like this. Got it? So I think we are done here. Let's look at the next video now. Welcome back. This is Rupesh and you're watching CPP Nuts video series on C++. And in this video, we'll be learning about how to call function with values. Okay. So there are 3 videos: pass by value, pass by reference, and pass by pointers. So this video is about pass by value. So we'll learn how to pass values. Okay. So let's start it. In previous video, we saw that how calling of the function works. And in this video, we'll see how to pass the values. So as you can see here, this is an integer variable and it holds 10 value and we are passing that val into this function. So we are calling this function and this is the way of calling some function here. You will write the function name and round brackets and whatever you want to pass, you just write there and the semicolon. So the control is coming like we know how this whole program works. Actually it starts from the main here. So it will start from here, it will come here, it will come here, fine, it will create a variable, it will come here and it will see, okay, there is this function here. So let's call this function. So it will call this function, okay, with these parameters because we have given the parameter. So it will pass like this, x will catch that parameter like it is having 10, so x will also have 10. So we are just simply printing here and we are just not doing anything, coming back because this is the and boundary of this function. So once this will encounter this AND line, it will come back. Okay, and then after coming back from here, we'll just simply print our value here. So 2-time print is there. So let's build this code and see how this will work. See, as expected, x is 10 and value is 10 here. Okay, so this is how you pass the value. Not only variable, you can pass directly 10 also, no problem. Okay, let's check that. See, the same answer is coming. X is equal to 10 and value is equal to 10. And you can pass several values like 20, 30 like this. And for that, if you are passing 2-3 values, you will have to get them right. So like this, it will work. And you are passing 10, 20, and 30. Then we will be printing it like y is this one. and z is okay. So we can print whatever we are passing from here. So not only variables, you can pass any number of arguments here. Okay, so let's execute this. This is going to work. See, 10, 20 and 30 is coming here, and after that lastly you're coming out of this function and you're printing this one. Okay, so we learn how to pass variables. Now there is something called default parameters. So you can assign some default parameter like this here. This z is equal to 100. So if you are not passing this third value, this will take this 100 value. So let's check that. See, it is taking x is equal to 10, y is equal to 20 and z is equal to 100 here. Okay, because you are not passing that 30. But if you will pass this 30, it will override this 100 and it will take 30. This default facility is given just because if user is not passing, then I will take this default value. Okay, so if you are passing explicitly, it will take 30 only. See, it is taking 30 now. Okay, so this is how this default variable, default values work. But there is a problem. You cannot do like having z is equal to 100 and thinking that if I will not pass anything and keep blank here and try to compile. No, there is the error here, and that error is telling that default argument is missing for parameter 2. So this is telling that if you are having default value for this one, then after this whatever the parameter is, that cannot be blank. That is also supposed to have some default value. Okay, so let's keep it like this and we'll go and compile this again. So this is telling you the error at this position. Why? Because you cannot keep first element or second element empty if you have third element. Okay, so it is like this. You can keep third element empty like this. If you just remove this, it is like you are not passing the third element. If you will remove this also, it is like you are not passing second and third. But if you don't want to pass this first element, there is no way. There is literally no way of doing that, and no way of doing like this also. Like if you don't want to pass this second also, no. If you're not passing second, you're not supposed to pass this third also, like this one. Okay, then only it will work. Otherwise, it will not work. We can check that. See, okay, because it does not know how to think that what you are passing and what you are not passing. Okay, so whenever it encounters this one here, it assumes that this is for first element. Okay, so whenever you will call this, see, it is passing 10 to this x, which is coming from here, and then remaining values are by default values. So y is 19 here, that's why it is printing 19, and z as 100, so it is 100, so it is printing 100 here. Okay, so that's how this default value work. And if you want to keep this x also default, then don't give anything. Just call this update function. It will take all the default values. Check this out. See, it is taking x is equal to 100, y is equal to 19, and z is equal to 100. Okay, so we are done with this value passing thing here. So there was this function, he was passing the values. Okay, so now there is another type of function calling and passing the values. Here you were just simply calling either with the variables like this or the values like this. Okay, but in next video we'll see how to call with the variables here like this and change this variable here in your function. Okay, and yeah, that is allowed. So let's check out the next video for that, and that is called function calling and passing parameter by reference. Okay, so pass by reference. So I'll see you in the next video. Hello there, this is Rupesh and you are watching CP Peanuts video series on C++, and in this video we'll see how to pass any value in your program using reference here. Okay, so let's look at the code here. This is your function, and let's suppose this is your main function. You are creating this variable val, and we are printing the value of that val, and after that we are passing that into this function and we are taking it as reference here. So this is what we are going to learn today. Okay, so what is the significance of taking it as a reference? Before in this video we were not taking this as reference here, so in this video we'll see how to take it as reference and what is the significance of taking it as reference here. Okay, and what do I mean by taking it reference here? Okay, so we'll compile it line by line. Like first we'll come to this line, then we'll come to this line and we'll create a variable value 10 in that. We'll come here and we'll print the value, so 10 will be printed. We'll come here and we'll see that okay, update function is there. We'll call this with the value variable. We'll go here and integer reference. So how this will get in your memory, we'll see that. So what we are doing here is we are taking this val as reference. Okay, so there is this 10 somewhere in your memory like this, and this val is pointing to that memory. Okay, and the value at that memory is 10. Okay, so by taking this as reference here, you are telling that I am going to create another variable called x, and this x is also pointing to the same memory location, and that memory location is holding 10 as value. Okay, so if you will change x here like x plus 10 and initialize that value into the x, which is making this x as 20, so what you are doing, you are changing this x, means you are changing this only. Okay, so you are removing this 10 from here and you are putting 20 here. So after doing this, you will come to this, and this is the end of the function. You will come back and now you are printing value after change. So here the same variable, this val, will print 20. Okay, so here it was printing 10 because it was holding 10. After updating this variable, it is printing 20. Okay, because indirectly it was changed by x, which is pointing to the same memory location what this value is pointing. Okay, so this is how this passing by reference work. Okay, so let's check that. If we will run this, it will give you the output here. See, value before changing was 10, after changing it is 20. Okay, and both the time we are printing this val only. Got it? Let's suppose you are not passing this reference here. Then what would be the scenario? Run this. See, even if you are changing here, this change is not coming to this val. See, both the time it is 10 only. So let's try to understand this case now. So forget about this one now and forget about this reference also. Okay, there is no reference here. So in that case, if you will pass this, as you are passing it without reference, only 10 will come here, and there is this another memory location get created and 10 will be assigned to that, and x will point to that memory location. Before, x was pointing to the same memory location what val is pointing, but now this time val will be like this, 10 val, it is pointing here, and another memory location will get created and x will point to that memory location. So as you can see, both are pointing to the different memory location. So in that case, if you will change x here, so x will be changed and 20 will be changed here where this x is pointing. So it won't affect this val. That's why this time we are getting here only 10. Okay, it is not being affected here. So this is the difference between calling by reference and calling by value. Okay, so let's look at the next video which talks about how to call by pointers. So this was about calling by reference here like this, and now in next video we'll be talking about how to call by pointers. Okay, so let's look at the next video now.
Hello friends, this is Rupesh and you're watching CPP Nuts video series on C++, and in this video we'll be learning about a function called by pointers. Okay, so far we have learned about function called by value and the reference. Now this is about pointers. Okay, so first I will show you why we need to call function by pointers. Okay, so for that I need an example here. So let's create a variable x and initialize it with some value. Now pass it to some function. Okay, like this and create another function and get that value here, new x. Now new x you want to change here, okay, and let's suppose you are printing this x here, okay. This is fairly simple code. What is happening is you are creating a variable called x, passing that x to this function. Now that x will become this variable. Now you're changing that variable 20 and coming back from that function because you have terminated, and after coming back here you will go to the next statement and you will just print the value of x. So let's compile this. See, the value is coming 10. Shocking, right? Maybe. If you notice the point here, the point is you are changing this x here, but still it is not getting changed. So if your requirement is like you have one variable in this function which is a main function, and you want to change the variable which is local to the main inside some another function like this, then you have to pass it by pointer or reference, okay. So reference we have already talked about. Now we'll see the pointers, and why this is not working I'll show you the example here. So this is the example. Your x is a variable. We all know if you are creating a variable it needs a memory, okay. So let's call this memory address 21 and we are holding 10 inside that, okay. So this is 0 cross 21. This is the address part and this is the value part, okay. So we are pointing this x here. Now you are calling this change which is taking you here, and in the entry point only you are creating this new x, okay. So this is like this. We have space for this one and this is 0 cross 22 and you're passing 10 here. See, we are passing x, so 10 will come here also. Now what you are doing, new x is equal to 20. So you are erasing this one and writing 20 there, okay. And after completing this function you are coming back from this function and executing this line. So x is still holding 10 here, okay. So this was the memory location which was given to x, okay. So it is still holding 10, that's why we are getting 10. We are not getting 20. And if you want to get the 20, your answer is either use reference or use pointer. We have already talked about the reference in my previous video, so this video is about using pointers. So let's go ahead and implement that function. So you just have to pass the address of x like this, and there if you are passing the address you have to get it as integer pointer, and this should be dereferenced, okay. And that's it. If you will compile this now, you will get 20. So this is what we wanted, right? And why this code is working, let's try to understand this code now. So the same thing will happen in this code also. This x is created, we have the memory where we have written 10 and that address is still 0 cross 21, okay. And after this line we will execute this line. So change is calling this function, but wait a minute, this time we are sending the address of x. So I told you this is your address and this is your value. So we are sending address, not the value, okay. In previous case, this one we were just sending 10 here. See, we are sending x, okay. But in this case we are sending address of x. So we will send this part, okay, 0 cross 21. Now if it is address and you have studied the pointers, in that case if this address is of type integer, see this x is integer, okay. So this address of x would be of integer type. So for that you have to create an integer pointer here in order to get that address. So what you did, you created a memory. You will have your own address. Let's suppose we are calling it 0 cross 22, and what you are doing, you are initializing 0 cross 21 here, okay. So this is what this new x would look like. Okay, so this is your x variable, this is your new x. Okay, and the address of your new x is this one, and the value at that address is this one, which is ultimately the address of x. Okay, so this is the value and this is address. Now what we are doing after coming inside here, we are just dereferencing by using this star operator the actual x. Okay, what do I mean by that? If you are writing this statement, it means this dereferencing operator and new x is currently holding this address. Okay, so 0 cross 21 is equal to 20. So what you are saying, this is the address, I want to dereference that, and dereferencing means if you got some address, you want to dereference means you will be pointing to the memory area what it is pointing to. Okay, so this is your whole x part, and this x part is pointing to this memory area where you are storing 10, right? So dereferencing means you are pointing to this location. Okay, so if you are initializing 20 there, it means you are changing this location. Okay, now instead of 10 it will be holding 20 like this. So as you have initialized 20 here and we are hitting this curly bracket, it means we are terminating this function, coming back. So we have come back from here to here. Now we'll execute this statement. So x is holding 20, that's why we got 20. So ultimately what we have achieved is the local to this main function, I mean this variable was local to this main function, but we have changed this particular variable in another function by sending the address of that. Okay, so this was integer x, so you created integer pointer, and let's suppose you are having some character c is equal to a. Okay, so this is what you have initialized, and now you are calling that change function on address of c. Okay, this one, then here you will be writing it like change character pointer new c. Okay, and the rest of the things will go like dereferencing to that particular memory, new c is equal to, you are changing it to b. Okay, so c was holding a, you pass the address, you get it into character pointer because your variable was a character, so the address would be character pointer. Okay, and now here same star sign is used, and this star sign is for dereferencing that particular memory what you are holding inside this new c and trying to initialize the new value on that particular memory address. Okay, so this is what the function call by pointer says. Okay, it is really very simple. You want to change something, send the address of that, don't send by value. Okay, and you can achieve the same behavior by using a function called by references, which I have already talked about, and maybe in future I will create a video talking about the differences between sending by reference and sending by pointer. Okay, so what is the difference between these two? So for this video, thanks for watching.
Hello there, this is Rupesh and you're watching CPBNet's video series on C++. And in this video we will be learning about how to pass one-dimensional array in some function. Okay, so for that you need a function. So let's create some function here, and in this function you will be passing some array. So let's create the array first. Okay, so let's suppose you are having 1 2 3 and this is your array, and you want to pass this array inside this function. Now if you are writing like this, then you are just passing the 0th element to this function. Okay, but if you want to pass full array, then you have to write only the name of that. Okay, so this is your array Let me give some space here. Okay, so you will be passing ARR. Now how to get it? The way is you will be writing like this. Okay, this is the syntax for getting your array. And if you are sure how many elements are there, you can put the number of elements as well. Okay, so you know how many elements you are taking from here, so you will be keeping it. Otherwise it is optional, you can skip that. Okay, and another point to remember is the size of the array will be available only inside main function. I mean only wherever the array was created. If you will pass array like this inside this function, you won't be able to get the size of the array. Okay, because that is not known to this function or any other function. So for that we pass size explicitly. Okay, so I know that size is 3, so I'll be passing that size, and let's get that size also here. Okay, and simply we can just use that size and print the elements in this. Okay, so let's do that. Cout ARR of I. Okay, done. Now there is another problem. You are statically giving the size here, so whenever you change your array you will have to change here as well. So in order to remove this dependency, you can create a size here as well. So to get the size of your array, the syntax is like this: ARR divided by size of your single element in that. Okay, let's suppose we are taking 0. So let's understand what is the meaning of this one. This will give you the size of array in bytes. So you are having integer, it means 4 byte, and 3 elements means 4 into 3, 12. So this will give you 12 as the result. Now you want to find the number of elements in that, then you have to divide by this element, I mean this size, and the size of array 0 element, which is nothing but this 1, will be 4. So 12 divided by 4, you will get 3 here. Okay, so that's how we generally pass the size of the array. Okay, so let's compile this code, and you can see 1, 2, 3. So this is how you pass array in your function. Okay, and let's write the size of this one. There won't be any issue. Let's compile this again. See, it has compiled again, no problem. So this is how we pass array in function. Now let's look at the next video, which is about how to pass 2-dimensional array in function. That is little different than passing 1-dimensional array. I'll see you in the next video. Hello guys, this is Rupesh and I'm watching CPU Nerds video series on C++, and in this video we'll be learning how to call a function with 2-dimensional array in C++. Okay, so there will be 3 different ways you can do this, and we'll see one by one. And yeah, if you know any other way, please comment. It will be really good to know that. So the first way is you have to keep the global information saying that my row and column will be so and so. Okay, so here is your array which contains 1, 2, 3, 4. So 2 rows and 2 columns. So one row is 1 and 2 and second row is 3 and 4, and you're passing this in this function. So first one is very simple. You will be passing this array by its name as you was doing in 1-dimensional array, and you will get it by declaring the size of row and column both. Okay, so this is the first way, and let's quickly run this. If you will run this, your answer is 1, 2, 3, 4. So this is correct. Okay, there is no problem in this code, and this is the first way. Now let's go for the second way. For that I need to comment this, and this is your second way. In second way, you will only pass the column. I mean, you will only write the column, and you must have column in your global space. Okay, and this is row, what you are passing from here. So in first case, you was not passing row and column, both you was having in global space, but in second case you are passing row, okay, and column is coming from the global space. And let me tell you guys, you cannot skip this column here. Okay, you cannot just write it like this. Okay, no, you don't have that option like you was doing in 1-dimensional array, and I'll tell you why it is like that. Actually, the point is, when you pass two-dimensional array, then let's suppose we have this two-dimensional array and this is 0 and 1, 0 and 1. Okay, this one value is 1, 2, 3 and 4. So this is case of two-dimensional, and let's write one-dimensional case. Let's suppose you're having these many entries 1, 2, 3 and 4. Okay, now let's discuss why this C is important. You have to give the column, okay? But in case of one-dimensional array, you was free to skip this size here. So the reason is you see two-dimensional array like this, but in computer it is still like this. Let me write it. In computers it is still like this. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, so this is 1, 2, 3 and 4. And let's suppose you are writing it like ARR of 1 and 0. Then you're selecting this position. Then your pointer, which is pointing at this starting location, because your ARR is pointing at this location, right? The 0th location should jump to this location. Okay, and this location means it has to skip 2 columns. Okay, so if you are not giving this C, then there is no way your compiler can find that I am supposed to skip 2 columns and jump to this place. Okay, there is no way if you are not giving this C here. And why it was okay to keep the size empty in one-dimensional, because whenever you give size in one-dimensional, let's suppose you are writing ARR of, let's suppose 4, and this is some 5 and 0, 1, 2, 3 and 4. Now your compiler knows very well that your size is, the data type is integer, so it is supposed to skip these many bytes multiplied by this number. Okay, so 4 into 4 is equal to 16 and 4, 4, 4, 4. So it will directly come to this location. But here you have to skip this full column. That's why you need the column information. Otherwise you won't be able to jump directly. Okay, you just think about it, you will get the answer. So that was about giving only C inside the global space and passing your array like this. Okay, now let's look at the third one. In third one, you don't have to keep any global information about row and column. Both you can pass from your function itself. Okay, and you can pass your double pointer. This array is of pointer of array. Okay, so you can typecast that into integer pointer and you will get that as integer pointer, and this is the way of accessing your elements in the array. Okay, this I into C tells that how much you need to jump to access this jth location in one row. Okay, so this is the formula if you are using this kind of array passing, and I think this is really a good way to do this, because you don't have to keep the global information, and that is really good. But here you can dynamically give when you are calling the function itself. Okay, because you will be knowing the size of your array when you are creating it, and you will pass that here, and you can keep this dynamic by keeping R and C here itself. I have not taken care of that much, but still I think you got the point, right? So this is very good way to do this. Okay, and one more thing, I forgot to mention one thing in previous video, which was about how to pass one-dimensional array in function, and that was like this. And I said that you can skip this size giving thing here, and this is the way of doing this. There is another way of doing this. You no need to have this bracket as well. You can just remove this bracket here and keep this as a pointer. Then also it is okay. This will work. Okay, so let's just compile this. This is going to be your G++ 4.5. Let's run this. See, 1, 2, 3. So there is no problem in this. You can do like this as well. I just forgot to mention in previous video. So thanks for watching. I'll see you in the next video. Hello friends, this is Rupesh and I'm watching CPP Nuts video series on C++, and in this video we'll be learning function overloading in C++. So this function overloading feature is not there in C, it is available in C++. We'll see how to use function overloading, where to use function overloading, and in what scenarios your function will get overloaded successfully and in what scenarios it won't get overloaded at all. Okay, so first of all we'll see what is function overloading. And yeah, one more point, how compiler does function overloading, I'll tell you that also. So stay with me, we'll learn all these things. So let's start this. Function overloading is nothing but, let's suppose you have two functions like add and another one is also add, but the parameters are different. One is taking integer x comma integer y, and the first one is taking maybe double x and double y. Okay, so if you will do this in C, this program will not compile, but in C++ it will compile. Let's check that. See, it has finished and it is compiled successfully. What is the actual use? I mean, why we are keeping two functions at same scope and giving the same name? The reason is, sometimes you want to keep the function name similar but want to get the different behavior, okay, by depending on the parameters you are passing in that function. Okay, so let's suppose you are passing 1.3 comma 3.2. so if this is the case, then your function which is having double and double will get called, and if you are passing some integer value, then this function will get called, and in another one we will give the second one. So second, and see, first one is calling first one and second one is calling the second one. Okay, so this is how you overload the function depending on your parameters. Okay, so this feature was not there in C, it is new in C++. And if still the use of this is not clear, let me give you an example here. Write something like void print, and here I am passing integer x, okay, and creating another function print and another function print, calling this one, then it is like first, and if you will print, okay, okay, so let's compile this. See, first, second and third, both, I mean all three are print function only, but depending on the parameters type we are able to achieve this. Okay, let's suppose there is some database, this is your DB, and you have some set of functions where you will get the list of people from this database, and one function is like get persons, and here you will pass date of birth. Okay, so this will return list of people. Got it? Now you want to create another function with a similar name like get person, and it will return the similar thing, list of the people, but you want to change the number of parameters, or you want to change the parameter itself. Maybe this time you want to give the name of the persons, maybe John, then all the people who are having John as their name will come out as a list. Okay, and another function you can create by similar name, and you will create a different parameter for that, and that could be the minimum age. Like you can pass a variable, I mean the type minimum age, so all those people who are having at least this much age will get out as a list. Okay, so this function will return the list of those people. Okay, so as you can see, you are keeping get person and get person, but you are changing the parameters. Okay, and this is obviously a good practice, because if you will create a function like get person by date of birth, get person by name, get person by minimum age, then it doesn't look good. Okay, as a programmer you should not do that. So this is the best use someone can achieve using this function overloading. Now here comes the question, how compiler is actually doing this function overloading stuff. Actually, what happens when your compiler is compiling it, it will check, okay, this add is this one or this one. So it will make it like this, add 1 and add 2, and this one as add 1 and this one as add 2. This 1 and 2 depends. If you will go inside and check the compiled code, it might look like XCD. So here XCD will come, and here could be something like that, QA, then here QA will come. Okay, so compiler is changing your function name, and accordingly it is keeping that function here so that you can call that function without having any problem. Because when you run some function, when you run your program and you call some function, that function address is used to call that function. Okay, so in order to get that address, all function names should be unique in the list. So this is a back processing. This is called name mangling. Okay, if you want to Google it, you can Google it, you will get more detail about that. But you don't have to worry about that name mangling because that is compiler's job. So how compilers will get to know that this one is this one? Actually, it is checking that, okay, both parameters are floating point, then only it is keeping this one here. And if it is checking, okay, both parameters are integer, it will map to this one. Okay, so that's how it is mapping. Got it? So this was about function overloading and how it is implemented internally and where you will use that. Now there are few places where you cannot use function or overloading by keeping your parameters in some ways, and those ways are like this. I have written some rules here. These rules are saying that function declarations that differ only in the return type. So you might think, if I am keeping both as double, and if I will change here like integer and maybe double, or if I am keeping it as void also, no problem, then you might think that this will get overloaded. No, you cannot overload using return type of the function. Okay, if you will compile this, you will get the error, even if both are returning different data types. So first point tells that you cannot overload on the basis of return type only. Okay, so the second is, in class, if we have similar function name and parameters, but one is static function and another one is non-static function. So what is that? Two functions, one is static function which is returning void, and let's call that function as fun, and then people might think that, okay, one is static and another one is non-static, so you can overload like this, but this is an error. Let's check that. See, it is giving error here. So you cannot do like this. So the second point is this one. Third is, when we receive array as a pointer or array, both are similar. Let's suppose integer array. Okay, and you might think, okay, this add is different than this add because both are having different parameters, but it is not. Okay, so let's compile this. Let me comment this one first. So if you will compile this, it will say that ambiguity. Fourth is constant and volatile doesn't make any difference. So the constant, okay, then also both are equal. So if you will compile this one, then also it is giving you the error. And if you will make the volatile, okay, so if you will compile this, see, it is giving you the error. Okay, so constant and volatile doesn't make any difference in function overloading. Okay, so let's look at the fifth point here. One function parameter declared as function type and another as pointer to the same function type, both are equal. Let's see that also. So if you are taking integer this as a function type, and in another function you are taking the pointer of that type, then also if you will compile this, both are equal. Okay, it is telling you the ambiguity. So both are equal. This is a function type, which is taking nothing and returning integer, and this is the function pointer, which is taking nothing and returning the integer. So in case of function overloading, you cannot overload on the basis of function type and function pointer type. Last one is two function parameters are equal if they differ only if one of them is having default parameters. So if one function is like this, integer x, and another one is integer p is equal to 10. So if you are familiar with this default parameter thing, you will understand it better. So in one function you are passing default parameter, another function is you are not passing default parameter, but the type of the parameter is similar, then also this is ambiguity. Okay, compile this. See, it is giving you the error. So we are done here. Thanks for watching, and if you like the video, don't forget to hit the like button. It will help me a lot. And if you haven't subscribed yet, go for it, because you will get the latest videos when I will upload one. Okay, so thanks for watching. Hello friends, this is Rupesh and watching C video series on C++, and today's topic is constant keyword on function overloading in C++. So there is a different behavior when it comes to the constant keyword when you are overloading the functions in C++. So I have listed down 2 points here. First one is C++ allows to overload member functions on the basis of constant and non-constant functions. So you know that we can have constant member functions which won't allow you to change data members. So we can overload functions on the basis of constant and non-constant functions in our class. And the second point is constant parameters allows to overload member functions and normal functions, but it should be reference or parameters. What I mean to say is, let's suppose you have two functions, fun, and this is taking integer and another one is taking constant integer. So these two functions are similar functions because it is taking value or the parameter by value. But if you want to overload function on the basis of constant only, then you have to have these parameters either reference or pointer. Then only it will be different. What I mean to say is, if this is integer pointer and this is constant integer pointer, then these two functions are different functions. So you can overload these two functions. But previous case was like this. You didn't had any pointer, so you cannot overload these two functions. Actually, they both are similar. Okay, so let's do the programming and check that. So the first point is we need to have some class. So I'll write the class very quickly. So this is the class, and let me explain what it is doing. It is just a test class. We have one data member what we'll not be using here, and this is the constructor. Doesn't make any sense for our example. The main point is these two functions. First one is taking only integer value and another one is taking constant integer value, and we just printing those values. Okay, and here I have created the object t, and we have this k with 10 and constant integer p. So we have non-constant and constant. So let's call these two functions. So t dot print, first we'll pass k, which is a non-constant value, and then we will pass this p, which is constant value. And we may think it will work because this k is a non-constant value, so it should call this one, and this p is a constant integer, so it should call this one. But it is not going to compile. So let's check that. So we have got the error. Let me show you the error here. It is telling that error, class member cannot be redeclared. It means it is thinking these two functions, this one and this one, both are similar. So as I said, we cannot do this. And this is the second point. So yeah, we are working on second point. I forgot to mention that. So as I said, this should not be passed by value. If you want to overload this, you should be using either reference or pointer. Okay, so let's make this reference and let's see if it is working or not. So if it is reference, and you know what, if you are making reference or pointer, then only it makes sense, you know, just think about it. So compiling, and voila, it is working, 10 and 20. So there is no problem at all. These two functions are different functions now. And let's go ahead and try the pointer. So if I will make this pointer and this also pointer, then we have to have this as here and here. And instead of passing k, we should pass address of k and address of p. Let's compile this again. See, it is compiled and working fine. So if you want to overload two different functions but on the basis of constantness, then you should use either reference or pointer. And yeah, I was telling you that it makes sense with reference and pointers only. Why? Because you will be keeping some parameter constant for these reasons only. Because you don't want this k, which belongs to this scope, changed here. That's why you are keeping it as constant. So you can only change this k here when you are passing by either reference or pointer. So it makes sense to keep this pointer or the reference as constant. If you are passing by only value, it doesn't make any sense. So this was the second point. So let's look at the first point now. First point says C++ allows to overload member functions on the basis of constant and non-constant functions. So let me just remove all these things. We don't need this anymore. And instead of this, I can print some message like non-constant. And here we can have constant. And I will make this function constant. So for that we need a constant and a non-constant object. So this t is a non-constant object. Let's create test t2 and make this one as t1. This test is going to be a constant object. And we can call t1.print and t2.print. And let's see if it is working. See, it is working. So T1 is calling the non-constant version of the same function. You can see that these two functions are looking similar. Returning void, taking no parameter. Returning void, taking no parameter. But the only difference is it is constant. And yes, we can overload functions if they are constant and non-constant in class. So that's it. If you have any doubt, please comment. And don't forget to hit the like button. It would help me a lot. If you want to help me, please hit that like button. Thanks for watching, and I will see you in the next videos. And yeah, make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. See you. Bye-bye.
Hello guys, this is Rupesh and you're watching CPP Nuts video series on C++, and in this video we'll be learning what is inline functions in C++. Okay, and the advantages and disadvantages of using that. So this is your program. You're calling print me function with this string and we're taking it and printing it. Okay, and this we are doing for 10,000 times. Now inline keyword is used like this. You will just simply write inline here. Then this function will become inline function. Okay. Now why you will make some function inline? Because if you know C, you would have not make any function inline, because this inline is a C++ keyword. You won't get it in C. So why you will make some function inline? The reason is when you call some function like this, then there is a overhead when calling is involved. Okay. So as you can see here, you're calling this function 10,000 times. So what will happen 10,000 times? You will save your current state of main function. Then you will pass this argument to the new stack. I mean this print me function stack. Let me draw that. So as I was telling that you will be having this stack here, and this is your main stack. Okay. So main stack. Now you will be having this print me. So there is this print me stack, print me. Okay. So what happens when you call some function like print me? You was executing your whole flow and you encountered this print me function here. Okay. Now what you will do? You will stop executing your main function. Okay. Then you will go to that function along with the parameters what you are passing. Okay, so taking this parameter along with you move this value from here to here,
and now you started executing this function. Okay, you are executing, and then after completing you will just return from here to the main function from where you called it. Okay, like this. So that return also requires some operations to perform, right? It won't come just like that. Or if you didn't understand, if you are returning some value, we are not returning anything from here, but suppose if you are returning something from this function, then that return statement, whatever you are returning, should be converted into assembly, right? So let's suppose you are returning some integer variable, then you will have 2-3 assembly language for returning that. Okay, so those things will happen if you are calling this function. But assume that instead of calling this function, if there is a way to replace this statement, whatever is this, here itself, no need to go there and come back, go there, come back for 10,000 times. Instead, you can just copy whatever is there inside this and paste here, and you are not doing this, compiler will do this. Okay, so if you are writing inline at front of function, your compiler will think, and notice this, I am telling think, that whether I should replace this function body with this function call or not. Okay, so now you understood why we need inline function. Instead of calling something for so many times and making this whole thing for very silly thing, instead of doing that, you can just tell to the compiler that, dude, this function is inline function, and you replace whatever I am doing here to the calling side. Okay, so compiler will replace this with this statement. Okay, and you are done. You don't need to do anything. Compiler will do this. So this was about what is inline functions. Now let's look at the advantages of using inline function. So advantages are function calling overhead reduces. Okay, I told you that you don't have to go, come back, go, come back, go, come back, because going and coming back requires so much effort. You don't know what is happening behind the scene. Okay, you just see this, okay, I'm going from here to here, but taking the control from here to here and coming back requires so much effort. I mean, so many assembly codes. Okay, so this was the first point. Second point is variables push and pop on stack is reduced. Obviously, if you are having 2 or 3 or 10 number of variables, then you will be pushing these variables on top of this stack. Okay, then that is also one extra burden. Instead of that, you could have just replaced this here. So that was the second point. Third point is return call from the function overhead reduce. We saw that also, if you are returning something, then also your compiler will generate some code for that, and that is also unnecessary code. Okay, and fourth is increases locality of references by utilizing instruction cache. This is something which requires operating system knowledge, but still I will try to explain that. Let's suppose you started from main function here and you are running, and all these things are just instructions. Okay, so you started running first instruction, second instruction, and these are assembly instructions. So what happens when your code will compile and the exe will get generated, and when you are running that instruction, I mean the exe, your CPU will see, let's suppose this program is creating 100 instructions. Okay, from 0 to 100, then these many instructions will be there. Then these instructions will be loaded inside cache. Okay, so there is this cache, there is this CPU. Okay, this is your cache and this is your RAM. So from RAM you will keep some information, I mean some instruction inside cache, and whenever CPU is executing some instruction, it will take from cache and execute. And if it is not found in cache, it will go in RAM and it will bring inside cache and then it will execute. Okay, so here we are using cache so that we can find whatever we need so fast. And there are two type of caches, instruction cache and data cache. We will not go inside much deep, but the whole idea is whenever your CPU is executing the instructions, as I said, you will be having so many instructions, your CPU does one thing. Let's suppose your CPU started executing some instruction from here, let's suppose from 0. Then what your scheduler will do, scheduler will take few more instructions, let's suppose from 0 to 15, it will take and keep inside this cache. Okay, so because it knows that, okay, if your CPU is running 0th instruction, then it will be needing 1 instruction, 2nd instruction, 3rd instruction. So it will keep this much of instruction already inside your cache. So CPU no need to go for RAM and search here, because RAM is always very big, right? 4 GB, 8 GB. So searching something inside RAM is always costly, so we keep things here. Okay, so the searching will be easier, and we always keep those instructions inside cache which are most likely to get executed by CPU in coming time. Okay, so as I said, it will keep 0 to 15 instruction inside cache and it will start running that. Now assume somewhere here your function call is there. Then what happens? From here you are not going to run the remaining instruction from here and here. Let's suppose your function call was hit on 6th instruction only. So from 6 to 15 instructions you are not going to run right now. You will be running this jump instruction which will take you to somewhere here. Maybe this function is here. Okay, print me. Then this instruction will take you here. So what will happen? As you are going here, your scheduler will think, okay, now you will be executing consecutively few instructions. So it will copy this much of instruction inside cache. Now what is happening? You are running here, but you are coming back. So you are coming back from here to here again. Okay, so now your scheduler will think, okay, I'm supposed to keep this much information again inside my cache. So as you can see, this will keep on happening, and this is just a wastage of time. Okay, you're not getting any benefit of doing this, and it takes really good amount of time to do these things. Okay, so if you are doing this just sake of printing something or adding something or multiplying something, or you are doing some very trivial thing, then you should always use inline function. So this instruction will, this statement will get replaced here, and you won't be paying the penalties like this. And let's suppose your instruction was replaced here itself. Then what will happen? Here it is so much messed up, so I will write here. Let's suppose this is 0 and this is 100. And as I said, from 0 to 15 will be loaded inside cache. So you hit this for loop here, and inside this you are running this cout. So you will be here all the time and you will be executing this cout again and again and again. Okay, so you won't be going somewhere else. Your CPU will always execute 2 to 3 instructions for printing whatever the message is this on the console. Okay, so 2-3 instruction, 2-3 instruction, 2-3 instruction. It will not jump and go somewhere else. Okay, so it is really very faster. Okay, so this was maybe a very big explanation about, maybe I don't know you got the idea or not. If you got it, hit the like button. I really need that. So the 5th point is, once inline is done, compiler can also apply intra-procedural optimization if specified. So what is this dangerous term here? This is looking very dangerous, but it is not that dangerous. It is just telling that if you have defined some function as inline here, then your compiler will have the option to perform further optimizations. And further optimization means maybe you are calling that function. Let's suppose you are calling that function here, and your code is like integer x is equal to 10. Okay, and let's suppose you are doing integer y is equal to x plus 15. Okay, and you're just printing str and you're coming back. Is there any meaning of this code? I don't think so. It is not doing any benefit to you. Okay, and yes, compiler can sense that. These things are called dead code. Your compiler will sense that, okay, this is not doing any good, so it will remove these things. Okay, so if you are putting inline as your keyword at front of function, compiler have the option to do these things. And nowadays compiler do this dead code elimination and all those stuff without doing this inline also. I heard that somewhere, I'm not sure about that, but yeah, compiler does that. So that was the 5th point, and that is not the last point actually. There are so many advantages for using this. I'm not listing everything because it will become very big video and I don't want to make this video so big. So now let's look at the disadvantages, and I'm telling you there are so many disadvantages also. Okay, and those disadvantages are from operating system side, so I'm not explaining everything. Okay, so just keep in your mind few things which are really important for your exam or for some interviews. Okay, the disadvantage is if used too many inline functions, then code size will increase. Obviously, look at the example here. If let's suppose you are having only one line here, let's suppose you are having 3 lines, 1, 2 and 3, and your function was inline. Inline means your function calling was replaced with the function body. So what you did, instead of one line you replaced 3 lines. Okay, 3 lines, 1, 2 and 3. And let's suppose these type of things you are doing maybe 100 times, then what will happen? If your compiler choose to make this function inline and really replace all these 3 instructions wherever this function call is happening, then it will end up replacing 100 function calls, function statements with 100 into 3. 300 statements will come. Okay, so instead of 100, 300 lines will increase. Okay, so your program is increasing, so the code, the exe size will also increase. And another is compilation overhead will increase if someone changes code inside inline function. Then all calling function will have to be compiled. This is little higher, but I'll try to explain that. Let's suppose this function is some function which is inside header file star.h. Okay, let's suppose it is some header file and you are having this function inside that, and you compile your program and everything is running fine, but later someday you decided to change this function. Then what will happen? Either you remove or insert extra statements inside this, and if you have done this change you have to compile, right? So when you will go and compile that time all those files whichever is including this function has to compile again, because you replaced few codes from here and now you have changed that code, so this reflection should go there, right? That's why that compilation will happen again, and it will take so much time if your project is really very big. And let me tell you, I am working on some project in my company and that takes around 20 to 30 minutes to compile. Okay, so if I have done modification in one code and if I want to see the full compilation, it generally takes 20 to 30 minutes on server. I am telling you on server, not on some local i5 or i3 CPU. So it really matters how you are using your program. So that's it. And yeah, I wanted to tell few more things. I have messed up this whole thing a lot, I know. As I said, this is the message to the compiler that if you want to replace this, please replace it. Okay, but it is not a command, it is just a hint to the compiler. Compiler has all the rights whether it should replace this with this or not. Okay, so there are a few predefined function types. They will not become inline even if you write inline at front of them. Compiler will never choose to replace them even if you are writing inline. Okay, and those function types are recursive function. So if you are having this function and you are calling yourself again from inside, calling again coming back, calling again, coming back, then it will not be replaced because your compiler cannot do that. And if your function is virtual function, then also it cannot be inlined. Okay, and there are a few other functions. I don't remember that. If you remember or if you know, please comment. It will be good to know that. Okay, so I think I'm done here. Thanks for watching. I'll see you in the next video. Bye bye. Hello friends, this is Rupesh and you're watching CBNet's video series on C++, and in this video we'll be learning what is class and object in C++. So this is a very basic video and we'll try to understand with this diagram here. So these two are the classes. So fighter plane is a class and the objects are MiG-29, Hall, Tejas, Mirage 2000 and all that. So these are the real objects. And this is like an abstract entity. Okay, so classes are like a blueprint. See, the phone is a blueprint. If somebody is telling phone, you will get some picture in your mind like this. Correct? But what phone? iPhone 10, Google Pixel, or Moto G4 Plus. So these are the objects. This is an object of phone. Okay, these are the objects. There could be so many objects of single class. So these are the objects of the classes. So as you can see here, in order to make any object, first of all you must have the blueprint. Okay, so if you are creating a fighter plane or iPhone or Google Pixel phone and all that, first you need to have the class of that, then only you can create some phone. So this was about class and object. So you might have understood that before you need to create the class and then only you can create the object out of that. Okay, what I mean to say is, before creating any phone, physical phone, people would have created a blueprint of phone, right? Like the phone should look like this one and this is going to be the screen part and here we'll put some buttons and all that. Okay, so the blueprint should be ready in order to actually create that. Okay, so before you need to create the classes in order to create the object. So first understand what is the requirement for creating the class. There are two things you need to create in class. First is attribute and another one is the functionalities. These functionalities you can understand like the operations you can perform on the object. Okay, and attributes like how it would look like if it is iPhone or Google Pixel and Moto G4, then what will be the screen size and what will be the chipset inside that and all those real attributes of some particular phone. Okay, so you will be setting the attributes and the allowed operations, that what operations you want to allow to your phone, like receiving a call and watching videos, playing some music and all that. So those are the operations. So let's create the class of phone. We'll understand there a little better. So in order to create a class, first you need to write a keyword name class and the name of the class. So our name goes like this. And there are some standards, like if you have written your class name, then the initial character should be an uppercase character. Okay, so this is our class and we'll start with curly and braces and this semicolon. So now whatever will come inside this starting and ending curly bracket will be considered the part of this class. Okay, so whatever you want to write should belong to your class. You will be writing in between these two. So as I was telling, the attributes. So let's write some attributes. So let's say that phone name, because our phones have name, and like size. So some pixel by some pixel. Okay, so these are the attributes. You can write as many as you want. I will be writing these only for the simplicity. And here comes the operations. So operations are called functions in programming language. And operations was like make, call, and another operation could be void receive call. Correct? So these two are the operations. Now it's up to you what you want to do inside these functions. And notice this, everything we are writing inside this and starting curly braces of our class. So these two are the attributes and these two are the operations. Now here is another thing, something called access specifier. So we have three access specifier: private, protected and public. Those access specifier I will talk about later in some videos because that is a big topic. For now you just understand that if you are making something as a public in your class, then you can access that part from outside this class. And if you make something private, you cannot access that private stuff outside this class. So access specifiers are written like this: public, public. So if you have written public here, it means whatever comes after this is public. So generally we keep the methods or the operations, whatever operations you are making for a particular class, we keep all those operations public so that you can call those operations from somewhere else. Okay, let's print some message which will give you good idea about this. So making call using this phone, pname, and here we can write like receiving call using the same phone. So till now our two things are ready. First is attribute of the phone, like how the phone would look like, what will be the name of the phone and the size of the phone, what chipset it will use and all that, and what operations are allowed. So for simplicity I am keeping just simple operations. So these things are ready. Now there is something called constructor, which is a special member function and used to construct the object. Okay, and this is how the constructor look like. There are 2-3 types of constructors that we'll discuss later, but for now you just understand that constructors are having the same name what your class name is, and they are used to construct the object. So as this is used to construct the object, it will take some parameters and assign these attributes. So I'll just show you, just bear with me till end, you will be really understanding the logic behind object and classes. So the string type name and string type size, and what we will do is p underscore name is equal to name and p underscore size is equal to size. Now we are almost ready. So these are the attributes. We generally keep the attributes in private section. And yeah, I forgot to mention that if I'm not writing anything like public or private, then automatically it will become private. See, before I was not writing this private here. So whatever comes under without any access specifier, that becomes private automatically. So this 2 lines comes under private section, and we keep attributes inside private section so that no one will able to change them without using our own class functions. Okay, so that you will see a little later. I mean, when you will see my whole videos and the full journey of learning C++, we will understand these things by taking the real-time examples. So for now, you just think that these are inside private section and these are inside public section. So public sections can be called from outside this class. So now let's create an object. To create an object, first you have to write the class name. It will say that what type of object you are creating and the object name. That could be anything, it depends on you. So I will say that phone 1. Okay, and you have to pass some parameters, 2 parameters. So this is where you are going to create a phone, and that phone would look like this. Okay, so this is your phone, it is going to look like this. And as you are creating a phone, you will end up calling constructor. This is your constructor. So as you can see, if you have some prior knowledge about programming, these are 2 parameters, and here we will pass the parameters. So first one is taking the name. So I will just say iPhone X or 10, and sorry for that, I don't know the pixel size of that, so excuse me for that. I will just simply say that, okay, 1000 cross 500. Excuse me for this. So actually I'm not a big fan of iPhone and phones. Actually I'm not into phone and all. So your object is ready. Ultimately your phone is ready. Now if you want to make some operation on phone, let's suppose you want to call somebody. Let's do that. Phone make call. Now you will get the clear picture. Let's run this. See, making call using iPhone X. Got it? So this is how you perform the operation using your object. You write the object name dot and write whatever operation you want to do. Let's do another operation on the same phone. So phone 1 receive call. Okay, this is another example, another function. Let's run this. If you're running this, receiving call using iPhone X. This is the beauty. You have a phone class. These are the attributes. These are the operations. And this is where you construct your phone class. Okay. Now let's create another phone. We are creating phones here, man. Oh my goodness. So phone class, again, how you create an object. Let me take it to this level, and this time we'll say like phone 2 or something, or you can just give the name, some meaningful name, so that if someone is reviewing your code, they will be able to understand it. So as this was an iPhone, I can say iPhone. Okay, and then we have to change here also iPhone, and here also iPhone. So this time if I'll create a Google Pixel, then I will be giving like G Pixel, and equally I will be passing 2 parameters here. First will be the name. So Google Pixel 2 XL, and let's assume this one is having 2000 cross 700, and gpixel dot make call and gpixel dot receive call. This will clear here so much doubt. So let's give some space here, and let's again run this. See, making call using iPhone X, receiving call using iPhone X, and making call using Google Pixel 2 XL and receiving call using Google Pixel 2 XL. So you can see that you have only one class, but you have different objects of that particular class. And here comes the beauty. You have defined a type or something called a blueprint of something. Now you can treat that blueprint and create so many objects out of it. So this was the basic about classes and object. So this is your class. Phone is class. iPhone, this one is an object. And if you're creating any object like this, then it will automatically call the constructor. Okay, and there are 3 types of constructor. This is parameterized constructor, one is default constructor, another one is a copy constructor. So the constructor we'll see in the next video. For this video, we'll keep this much only. So if you like the video, don't forget to hit the like button. And if you haven't subscribed yet, go for it. It would help you and me a lot. So thanks for watching. Bye bye.
Hello there, this is Rupesh and you're watching CPNet's video series on C++. And in this video, we'll be learning about what is this constructors in C++. Okay, so we'll note down few points about these constructors here, which will make sense when we will start programming. So first point is, constructor is a function and its name is similar with its class name. Okay, so whatever the class name would be, this constructor's name would be the similar name. Okay, and the second point is, they get called automatically when you create any object of that class. Okay, so get automatic call when we create an object of the class. Okay, third point is, it doesn't have any return type. So generally if you are writing some function, we type return also, right? Like if you are writing like void and print, and you're printing something like cout hello, like this, you write this return type like void or integer or something. If you're not returning anything, you'll be writing void here. Okay, so this constructor, which is a function, does not have any return type. Okay, so that is another point here.
So no return type. Okay. And fourth point is, if we do not specify any constructor in our class, your compiler will do that. Okay. So your compiler will internally specify the constructor for that class. So if not given by user, compiler will create itself. Okay. So these are few points we should always keep in your mind when you are dealing with the constructors. Okay. So let's look at the code to understand this. Or yeah, before going for the code here, let's talk about some requirements. So what we are going to code here. Okay. So let's suppose there is a requirement like you have this x-axis and you have this y-axis. Okay. And there are few points here like here and there like this. Okay. So this is 1, this is 1. So this point is like 1.5 and this is 1. So x is equal to 1 and y is equal to 1.5 or 2. Let's keep it 5 here. So you want to store this data. Okay. So we'll create a class which will do this. So let's look at the code now. So as I told that we will be having some class and the name of that class we can keep it like point. Okay. And we will be having x and y axis and they could be in point, so we will keep it like double x and double y here. So what is this first point here? That it is a function and its name is similar to the class name. So your constructor look like this. So this is exactly the same name as your class name here. And yeah, there is another point here. There are three types of constructors. First is default constructor. Okay. So in default constructor, second one is parameterized constructor and third one is copy constructor. So we'll see all these constructors here. Okay. So this one is going to be a default constructor. So default constructor will construct your object with the default values. Okay. Like this. So first let me write everything, then you will understand it a little better. I know you're confused. What are all these things? So let's create this object here, then we'll understand it a little better. So let's create the object of this point. So we'll create a P1 here and another one would be P2 with some values like 1.3, 3.4. Okay, and we will create a point P3. In that we will copy this P1. Okay, so these three objects are nothing but the demonstration for all these constructors here. Okay, so if this P1 is getting created, because whenever you create an object, the constructors are being called. Okay, so if you are creating object like this without passing any parameters like this, then in that case this default constructor would call here. Okay, and if you are creating object like this and passing some values, so in that case your parameterized constructor would be called here. Okay, because you are sending the values here, so it will automatically check whether we have this kind of constructors. Yes, we have this constructor, then it will call this type of constructors. And this is a copy constructor here, so it copies one object inside another object. That's why we are passing this point type only. Okay, here we are passing 1.3, that's why we are keeping like double here, which is this 1.3 type. And if we are passing this P1, which is of this point type, that's why we are getting it as point. Okay, and we are keeping it constant just because we should not accidentally change what we are passing here. Okay, so we'll talk about this constant later. For now you just think like if you are passing this RHS here, which is this P1, then you should pass it as constant. Okay, so this is what constructor does. Okay, so before going for the compilation, I should make this as public here so that it will be called, because we know that if something is private, you cannot call that outside your class. Okay, so this construction of the objects
are resulting into calling into these functions. So these functions should be a public type. And why I'm calling these constructor as functions? Because they are functions, but they are special functions which does not have any return type here. Notice this. And their name is equal to the class name. Okay. So let's compile this and check the correctness. See, it is compiling successfully, so there is no problem in this code. Okay, we are not printing anything, that's why nothing came into the console. So if you want to verify that, yes, P1 is calling this one and P2 is calling this one and P3 construction is calling this one, we can give some message here, like cout default call, and here we can give some message like parameterize. Okay, so I'm writing everything in one line, but don't worry, that is allowed in C and C++. Okay, so let's run this again and you will see the messages. See, first default is called, so you are creating this first, that's why this default call was printed first. Next is parameterize, so this is parameterized, and this is resulting into this copy constructor. Okay, so let's quickly print what you are getting here. So I will make some getters here very quickly. So instead of printing all these things, we can print some meaningful stuff. Okay, so for P2, if you are getting X and P2 get Y here, and let's suppose you are printing that, then you can visualize the results here. So let's go ahead and compile this. See, the expected things are coming here. Okay, so let's talk about the use of this constructor. We use constructor because constructors are the first member function which is being called when you create any object of your class. Okay, so you saw that as soon as this P1 is constructed, its constructor is called. Actually, that's why this is called constructor. Actually, it helps you to construct your object. Okay, so if you want to construct a default object like without any value, you will have a default call, and inside that you can keep any default value. I'm keeping 0 and 0, you can keep anything. Okay, and in case of parameterize construction, like you want to create this object, but it should hold some initial value, so you will pass those values. Okay, so in order to construct this type of object, there is something called parameterize constructor. Okay, so this parameterize constructor will be called, and you are setting those values. Got it? This X, capital X, is assigned into small x, and this capital Y is assigned into small y. Okay, and in case of this copy constructor is being called. Okay, so what you are doing here, you are copying one property into another property. Okay, so it is not looking like this copy constructor is being called with this statement, but internally it called this copy constructor only. So you remember this. Okay, whenever you create any object and simultaneously assign some another object in that, and at that time copy constructor is being called. Okay, and this right hand side object is going as a parameter here. So this P1 is of type point, that's why we are keeping it as point here. Okay, and this reference is just because we don't want to create another object, this RHS, so we are keeping it as reference here, which will indirectly point to this P1 only. So if you have gone through the reference variable video in my playlist, you will be very easily understand this, that why we use reference. Okay, so if you don't know, let's keep it like this. This P1 is coming here, and this RHS is nothing but this P1 only. Okay, just because of this reference here. So this RHS is referring through this P1 only. Okay, so we have RHS here, which is nothing but this P1. So in that case, P1.x will give you the x part of this P1. So you are initializing that x into this x, which is this P3x. So if you are not writing anything, it becomes P3. Okay, as this x was becoming P2x. Okay,
and this x was becoming the x part of this P1 here. In the same way, this x will become part of this P3. Okay, so it is something like this. You was calling this default constructor on this P1. So you was calling this parameterized constructor on this P2, and you are calling this copy constructor on P3. Okay, that's why you are getting these data members like this. And in order to get the RHS data member, you have to type it like this, RHS.x. Then only you can get the x part of this RHS. Okay, so you will initialize that x part into x and y part into y. Okay, so ultimately what you achieved, you copied whatever was there in P1 into P3. Okay, so this was about constructors in C++. If you have any doubt, please comment. Otherwise, let's look at the next video. And in next video, we'll learn about Initializer List, which is a new topic in C++. Before it was not there in C++. It has introduced in new C++, and that is really very good topic. So let's go ahead and learn that as well. Hello friends, this is Rupesh and you're watching CPP Nerds video series on C++, and in this video we will be looking into this Destructor in C++. So before this we saw what is constructor, now this is destructor. So the job of constructor was creating the object, and the job of the destructor is it will destroy the object when your object scope is over or your program is going to get terminated. Okay, so for that we need some class. So let's create some class here, class base, and here integer x, and this is gonna be a default constructor. This is, let's make it a parameterized constructor, and then this destructor. So this is how you create destructor. You need to use this symbol, and your function name should be the class name, and this is your destructor ready. Now whatever you want to do this inside this will happen when your object is going to get destroyed. So I want to just print that destructors. So let's read these points, it will be really more clear. So this is a special member function with same name as class with this at the front. So we saw that here, and this is also a special member function. It cannot change. So if your class name is base, you will have to write base here and use this symbol, and then it will become destructor. So special member functions are having the similar name what class name is. Now it will be very easy for you to remember this. So let's look at this second point. Used to destruct the memory of object which was constructed by the constructor. Okay, so this point can be made here, base b, and maybe that's it. So if you are having this b, it will call this constructor. So this is your default constructor, and this is your parameterized constructor. So as I said, when you are creating the object, it will call the constructors, and in this case it will call this constructor. This is a default constructor. You have seen the construction process in the previous video, so I won't go over that much. But when your main function is getting terminated, in another word, it is terminating the whole program. In that case, before terminating the program, your destructor will be called, and destructor will destroy this one. The destroy thing I will not write here because it actually happens automatically in case of normal data members. When you have used integer pointer here, in that case you have to delete that pointer here, but as you have not seen pointer data members yet, it will be hard to relate it for you, but still I will try to give you the example. So before going for that, let's just compile this and check. Yeah, I always forget this public thing here. Deconstructor and then destructor. So deconstructor means default constructor. Okay, so first it was constructed, and when your program was terminating, it automatically called this destructor. You don't have to call this, correct? Now let's look at where the actual use of this is. So for that, let's use this integer pointer here. And you might remember that when you was using integer pointer p is equal to new integer here, and later after this you would have to delete this p here, okay, because you have created this memory, because you created the pointer, so you have to delete that pointer so that memory leak will not happen. So the similar case will happen here as well. If you are creating the pointer, you have to give the memory for that. So this is how you will create these functions. I won't go much into the deep inside, just simple things. This will become pointer, and that's it. Now you will delete this x and done. And now if you are creating this b, the thing will look like this: integer, this 10. So here what you are doing is you're creating this b object and passing the address what is returned after this new expression. So this new keyword is used to create the dynamic memory allocation. So if you don't know this, you will find this tutorial a little difficult for you to understand. So for that, you please go and watch what does this new and delete operator do. And for those people who know this, let's continue. So as you know, new will ask the memory of size integer, and it will initialize 10 inside that, and ultimately you will have some address at this point, and that address is going here, and that address type is integer. So we are taking that as integer pointer and initializing that inside this x. So this x is now holding the address, not the value. Okay, so if this is not pointer, it would be holding the value, but as this is pointer, we are passing the address, and we are initializing that dynamically created address here, to x. So as you remember, as I told you that if you are creating any integer pointer or something, if you are creating any pointer, you have to delete that pointer. So in this case also you have to delete that, and that delete will happen inside this destructor. So you are deleting that. Okay, so let's compile this one and check. See, now p constructor was called because you are calling this with parameterized one, because now you are passing the parameters here. So this one will be called. That's why you got this p constructor, which is parameterized constructor. After everything is done, you are terminating, and when you are about to terminate, before that you will call this destructor, which will delete this b, and now you will write whatever you want to write, like delete x. Let's suppose if you are having another pointer, let's make it y, then you will delete x and y both. Okay, so this is generally the case with the destructor. You delete the dynamically created memory, otherwise there is no need to create this destructor. Your compiler will take care of that. Okay, and I mean to say is, if you are not using this pointer, then it will be simply integer x, then you don't have to initialize it with the null pointer. And yeah, that null pointer is nothing but a null. Null means not pointing to anything. Okay, so here also it will be simple pointer, and then you won't delete this, and you will have only 10 here. As you didn't create a pointer, your compiler will take care of everything. The destruction part, because compiler will create the memory for this one. But as soon as you started taking the pointers in your data members, you'll have to worry about the deleting portion. Okay, so for that we use destructor. And if you really don't understood what do I mean by integer pointer, or what is actual use of pointer data member, I have a pointer data member video in this series. You can go and check that. Or maybe if I have not given the link in the description field, you asked me for that if I forgot. So we were discussing about this second point. Now the third point is destructors get called automatically. It is an implicit call, as the constructor was. Okay, because you was not calling this constructor here. Okay, you were just creating the object and it was automatically get called. So similarly, when you are going after this main and there is the time to destroy this, so this destructor is also being called automatically. Okay, so that is the third point. We can call destructors explicitly, but that is not a good practice. And the only place where you will call destructors explicitly is after placement new, and this is little advanced topic. which I think I will cover in some another video. Fourth can be seen here. So if you want to call this destructor, you can just simply call like this. Done. If you just compile it, you will have 2 times destructor. First is when you are calling this one, and another time when your program is getting terminated, your program doesn't know that you called it, so it will call it again, because calling constructor is not your job. Calling destructor is not your job, so compiler doesn't have any idea about that. So compiler will again call the destructor, and 2 times destructor call is undefined. Undefined means what will happen, they don't know. If something bad have happened, you cannot claim the C++ developers, the committee, because it's your mistake, you're doing this. And there is one extra point here. This destructor doesn't have any parameter. Okay, you cannot just call like 11 here and get integer a something like this here. No, if you will compile this, you will get the error, okay, saying that maybe there is no matching function, and it is telling that destructors may not have parameters. So you cannot have the parameters in the destructor, whereas you can have in the constructor. So this was all about the destructor. Actually not all about, because when things go for exception handling, there are few things we need to really take care in case of destructors. So that we will see in exception handling tutorials. So for now, let's keep it this much. And to summarize this, destructor is a special member function which is having the similar name what your class name is, and with this tilde symbol. And as you was not calling constructor, so you don't have to call the destructor also. And destructor job is to destroy the object what you created here, and this destruction happens automatically. You don't have to write any destructor until unless you have used pointer data member. Okay, and that thing you can check out my another video, or maybe you will get the link in the description field if I forgot to include that link, because I generally do, because I don't really remember what did I said in the video. So it's your job to ask for that link, and that is a really very big video, so be prepared for that. So yeah, you might be thinking that if I'm not using any pointer, still I'm writing this, and I'm telling that there is no need to write. Yes, there is no need to write, but if you are writing, then it's okay, because you're not doing anything here, right? You're just simply doing some printf statement, which is okay. But it becomes really necessary when you have some pointers here, because you have to delete that pointer, and that delete will happen here in the destructor. So that's the whole idea about this destructor here. I hope you would have liked this video, and if you did like the video, don't forget to hit the like button, and make sure you subscribe to my channel so that you will get the notification for new videos like this. I'll see you in the next video. Bye bye. Hello friends, this is Rupesh and you're watching CVP.NET video series on C++ tutorials, and in this video we'll be learning about data members of classes in C++. And why I'm taking this video, because it is really very important topic, because when I was learning C++, I was not clear what data members are and what are all those types of the data member and why we use that. Okay, so let's start this one. So the answer to this question is data members of classes are nothing but they are just the attribute of the classes. Attribute means if you are something, why you are that thing, you have to have that attribute, then only you will be called something, right? Like if you are called human, you must have a human attributes, then only you will be called human, right? So these data types are nothing but the attributes only, and they hold the data of the object. Like if you are a human and there is one variable called hands, then generally human have 2 hands, right? Not generally, almost all the time. So that hand variable will have 2 as a value inside that. Okay, so that is holding the value for you. So it's something like that. So let's start this one. And yeah, that could be any type like string, character, integer, double and all that, and array type, bit fields, and user defined types such as classes itself. So one class object can be a data type of another class. So we'll see all those things here now. So let's suppose your professor gave you that, okay, create a class which will hold the XY coordinates. So you can call that class point, and this is the syntax, and you might be knowing how to create class and all. This is your keyword class, and this is the name of your class. And now we'll write the attributes, and for simplicity let me write these public here so that we can access this attributes from main function, or we can access these attributes outside this class. So let's call it integer x and integer y. It's not required to keep it integer x and integer y like this. You can just simply keep y here. So as you are asked to create the coordinates, so this is your x and this is y, and you are calling that coordinate system as point, correct? So this is 1, 2 and 3, 1, 2, 3, similarly 1, 2 and 3. Okay, so your point p1 could be 1, 1 and p2 can be 1, 2 or something. Okay, so this is here and this is 1, 2 is here, correct? And this is x and this is y position. Okay, so this much is enough for your point storing. So let's do the practical here, we'll understand it. So we can write point p1 and 1, 2, no, before it was 1, so 1, 1, and another will be p2 1, 2. So as we are setting the values when we are constructing it, so the constructor will get called, and if we are not having constructors here, there will be an error. So point, this is simple constructor, this is going to be your parameterized constructor, so integer a comma integer b, and x will have a and y will have b, and that's it. And let's suppose you want to print p1 x, and let's give some space p1 dot y, and similarly for p2 dot x dot y endl. If you will run this, you will see the answer is 1, 1 and 1, 2. So that's what we expected. And the more important point here is, if you have one class, here we are having point, and this has x and y as the attribute. Okay, so this is your class here. Now if you are creating objects like p1 and p2, p3 like that, then this p1 will have x and y for itself, and similarly p2 will have different x, y for itself, and same case for this p3. So if you have this normal variables inside your class, which is a data member of your class, then this data member will be different for all the objects. That is the only reason if you are printing p1's x and p1's y, it is printing 1 and 1, and if you are going for p2, it is different. Okay, so it's like this. You have this blueprint and you created an object of that. Now that object will have the attributes of that, and if you are creating different object, that object will have different attributes. So there is no connection between this x and this x. Okay, they are totally different than each other. And the number of objects you keep on creating, the number of x and y will get created for them. Okay, so this is how this normal data member behave. There are lots of types, like if you will make it integer, then what will happen? If you will make this one static, then what will happen? And we'll cover all those things in coming videos, because pushing everything in one place is kind of confusing all the time. So the motive of this video was just to show you that if you are creating one class like this and having two simple attributes of that or data members of that, and you are having different objects like this, then this x and y will be there in each and every object, but they will be different x and y. So memory for this x and y will be separate, and for this x and y it will be separate, and like this. Okay, so this you can call memory 0, memory 1, memory 2, memory 3. Okay, it is not like one single memory and each and every object is pointing to that. No, it is not like that. There is something like this that we'll learn in the coming videos. Yes, there is one common memory and each and every object point to that memory, and that is the topic of next video. So if you're interested, go ahead and watch that video. I'll see you in the next video. Bye bye. Hello friends, this is Rupesh and watching CPNet's video series on C++, and in this video we'll be looking into this constructors and member initializer list. So this is a very interesting topic to discuss, and the use of this is it initializes the data member of classes. So as you have this class here, base, you will be having this data member X. Generally what we do, we create this and have this integer A and X is equal to A. Okay, so this is your parameterized constructor, and this is how we do this. And let me just create this B10, and this is gonna work. Let me give this public here and compile, and this is done. It is compiled successfully. So this 10 has gone to this X. So, and this is how we do this. But there is something called member initializer, which initializes the members, and this is how it is done. You don't have to initialize this like this. What you have to do is, after this bracket here, round bracket, put this colon, or if you want to make it in new line, you can do it like this also, like base and colon, and then you can start initializing. But I prefer this one, and generally you will get the code like this. So put the colon and the data member name X and the curly bracket and this A, and you're done. So what is happening here, you're saying that I'm going to use member initializer list, and this A is going inside this X. Now let's talk about this using this one and this one. Actually, first let me compile and show you that it will work. See, it has compiled and it is working. So as I said, you can use this round bracket also instead of using this curly bracket. There is no much difference. See, it has compiled now again, but there is a difference. This is a uniform initialization, and this should be preferred over this round bracket initialization. And the reason is this curly braces will check the narrowing, and narrowing part is like this. Let's suppose you are having this character here, and you're passing this 10 as an integer, and you are going to assign integer inside X. So this integer is a 4 byte and this character is of 1 byte. So from 4 byte to 1 byte is called narrowing. So you are ultimately pushing your bigger data into smaller data. I mean bigger data type data into smaller data type data. So if this cannot hold that, then you will have a problem. And we know that this character is of size 1 byte, so it can hold at max 255. So if you will give more than that, let's suppose you're giving 300 here, then this 300 is not gonna go inside this X. Okay? It will get round off and it will assign maybe 55 or something, but not 300. And user doesn't get any warning if user is using this round bracket. So I'll just show you that. Let's compile this and see, it has compiled successfully. There is no error. If you'll print this, you will get some interesting thing here. So let's just print that and see out, compile. Oh, I just forgot to. And this b dot print. It is printing this comma because this is going to get converted into ASCII code, and as this is character, it will print comma. But let's make this integer and print this again. So it is printing 44. So ultimately 44 is going inside this X, not 300. And you didn't get any warning about that. That is the problem. And that problem is solved using this curly braces. If you will compile it, it will give you the warning. Even though it is performing that, see, you get this 44 here, but you got the warning here. See, this one and this whole thing. Okay, so if you are implementing something dangerous, you will get the warning. So that's why you should always use this bracket, this curly brackets, not this round bracket. And I would strongly recommend you should always use this initializer list to initialize your data members. So you always have the option to initialize it like this. Actually, this is not initialization, this is assignment. This is assignment and this is initialization, this part. So initialization happens when you're constructing the data member, but assignment happens later. First you have to create the data member and then you have to assign. So if you are using more than, if you're having more than member to initialize, this is how you will do this. Let's have this integer y, then you will be getting this integer y, or make it z from here, and using comma you can specify other data members, so y and z. So this z is going inside y, and here you will pass maybe 100. Okay, and let's just quickly print that and just remove this integer x, so no need of this thing. Okay, cool. Let's compile this. See, 300 and 100. So you have two parameters. So one you will initialize like this, then you will use this comma here, then initialize another one. And similarly, if you have n number of data members, you can initialize using this comma operator here. This was about how you can use it. Now I have created a video where I have shown where are all those places where you have to use initializer list, otherwise your program will not compile, or whatever you want to achieve you won't be able to achieve without using initializer list. I have given the link in the description field. If you're interested where you can only use initializer list, then you must see that video, because see, here you have the option, right? Like you just no need to do it like this, x is equal to a and y is equal to z, and this is perfect. But there are few places, almost 4 to 5 places, where you have to use initializer list, and I strongly suggest go ahead and watch that video. So for this video we'll keep it this much. Thanks for watching, and if you like the video, don't forget to hit the like button and make sure you subscribe to my channel to get the videos like this as soon as I publish them. So I'll see you in the next video. Bye bye. Hello friends, this is Rupesh and watching CPU Net video series on C++, and in this video we'll be learning about static data member of classes in C++. So before this video you saw normal data members, how they behave. So if you have not watched my previous video, please go ahead and watch that one and then you come and watch this one. So let me just write one class. Let's call this class a base class, and if you are creating one integer x and static integer y, just these two data members. First is integer x, another one is integer y, but this y is of static type. So let's try to understand why we create static and what is the meaning of this one. So if some data type like this is static, then it will be common for all the objects. Let's suppose this is not there for now and you are creating some object of this base class, then how it would look like? You are having this base b and b dot x is equal to, you can say 10, and you can have this base b2 and b2 dot x can be 20. And if now you are printing b1 dot x and another one is b2 dot x, then these two will be different. Okay, let's make it b1 here and b1 here. So we all know that, we saw that in previous video, that b1 dot x is 10 and b2 dot x is 20, and we know that if you have created an object of this class, then this x will be different for each and every object. So if you will run this, let's run this, answer will be 10 and 20. So this x is totally different than this x. Okay, I mean b1's x is totally different than b2's x, because this is normal variable, I mean normal data member. But now let's look at the static data member. If I will uncomment this and stop here, this is little different. What happens in normal case, when you create a class and you write data members of that and you create object of that, and automatically this x will get created, because this x is a normal data member and memory was created for this when you created this b1 here. But that is not the case with static data members, because static data members are not part of your object. They will be common in all the object. So this y will be a common thing. I'll show you how. And yes, if it is not belonging to each and every object differently, then the memory creation, I mean, if you have this integer y here, then you must have to create memory for this in order to store any value inside this, right? So the syntax for memory creation is like this. You have to create outside of the class like this. Like, what is the type of this one? That is integer. Where is this y variable? This y variable is inside base. So you will write like this: base scope resolution operator y and semicolon. Okay, so this is how you will define it. I'm telling you again, this integer x is a normal data member, so there is no need to create memory for this like this. Okay, because when you will create an object, this integer x will get created automatically inside this. Okay, I mean for this. But that is not the case with this static variable. This static variable will be common for all the objects. So who will create the memory for this one? So this is the syntax for writing and getting the memory for your y here. So for now, you just understand that this is the declaration part and this is the definition part. In normal variables, I mean data members, you don't have to do this, because this x will be different for b1 and different for b2. But this y is going to be common for b1 and b2 and b3 in all the objects of base class. So there is no way that who will create that memory should belong to b1 or b2 or b3 or b10. No, there is no way of telling that. So as it is only going to be single memory, we get it like this. And one more thing I wanted to tell, if you are having this .h and .cpp file, and generally what we do, we write the class declaration inside .h file and all those functions definition inside .cpp file. So if you are confused where should we write this one, then you should write this one in .cpp file, okay, not .h file, because .h file will get included here and there maybe 2-3 times, 4 times, then this will get copied here and there 4-5 times and you will have multiple definition problem. So if you didn't understood what they just said, then don't worry about that. That is little higher stuff, and if you are a pure junior, it will take little time. No worries, I'm there for you. So normal variables, nothing is required. Static variable, you have to define it. Okay, now let's do some magic here. Enough talk, let's do some experiments. Do one thing, b1 dot y is equal to 30 and b2 dot, let's come here, and b2 dot y is equal to 40, and let's just print b1 dot y and print b2 dot y. You will get the real picture of this one. See, both are 40 and 40, because what happened, this y, as it is single memory, let me just draw this. So how it is looking like is like this. You have this base class, inside this you have x and you have this y. Why I am drawing this? Because this memory is common for all the objects, and let's make these objects like b1, b2, b3, and here you selected x is equal to 10, here you selected x is equal to 20, and here you selected y is equal to 20, then y is equal to 30. But this y is common for each and every object here, so when you will change y, it will reflect that changed value to each and every object. So let's suppose object 1 is setting y is equal to 20, then 20 will come here, and after some time object 2 is setting y is equal to 30, then this will become 30. So if object 1 is going and checking this value, object 1 will get 30 here, and that's what happening here. b1.y is set as 30 initially, then we created b2x was set, so this 20 was here, but b2.y was set to 40, and this is this location, so it will be like 40 here. b1 will get that y. After initializing the new value, b1 will also get the new value, okay, because there is only one place for y and different place for x, okay. So if you are choosing b1.x is equal to 10 and b2.x is equal to 20, they will be different x, but this y is common for all the objects, okay. So let's just simply run all these things. So b1.x, and here we can write b2.x, okay, and let's see what is the output of this one. 10, 40, 20, 40. See, b1.x, x is initialized with 10, and here x is initialized with 20, so x is retaining its value because x is different for b2 and b1, but y was initialized 30 before, but later it was initialized with 40, so we will get the updated value because there is only one position no matter what object you are using to change that position, okay. That's why you are getting this one here. So up to now you understood that only one place is there in the memory where you access that location using any of the object like this, but there are other ways to access this data member, and that other way is you can just simply write the name of the class like this. So your class name is base, so you can write base y here, and here also you can write base y, okay. So if you will compile this now, it will tell you the same thing here. See, it is 10, 40, 20, 40, but you cannot do that base y with this base x because this x belongs to b1 object, but this y belongs to a global area. That's why it is called, they are the attribute of classes, not the object. Normal data members are the attributes of objects, but static data members are the attributes of the classes, and you have only one class, so you will have only one variable for that. So that's why you can access y like this also, whereas you cannot access x like this. You have to point which x you are talking about because x is depending on the objects, correct? So this was about how to access data member of your class outside. Now there is another thing. So if this is static data member, there is a function which is static. So let's look at that function now. So if you want to create some function, static function, then you have to write it like this: static print y, and you can print y here, okay, and you have to give the return type also. So this is how you create a function which is static function. So if you have not seen what is static function, let's try to understand that. So before that, let me write a non-static function. So void print x, and inside this, yes, you guessed correctly, you are going to print x here, okay. And let me just simply remove all these things and call b1.print x, and b2 dot print x, or make it like b1 dot print y and b2 dot print y. So we are printing x and y of objects here. So let's just simply print them and we'll see that later. This is giving you the exact output how you was getting before. But now what is the difference here? The difference is this function is a static function. So this function can access only static data member. This is the difference. Don't forget this. If your function is static function, then it can access only static data member of class. And if your function is a non-static member function, then it can access both. If you will write y inside this print x, there won't be any problem, but you cannot write x inside this static one. Okay, so just take a look of that. Just try to write x here and we'll compile it, and you will get the error: invalid use of member base x in static member function. So your compiler is telling you that it is not allowed. Now try to do the similar thing here. You can write y here and compile. It will compile. See, 1040, 40, 2040, 40. So remember this, static member function can only access static data members, and non-static member functions can access static or non-static both. Okay? And yeah, one more thing is there. Till now we was calling this print y using this object, but there is no need to call this print y using this object. You can call like this also. This is like base scope resolution operator. Similarly here, base scope resolution operator. And if you'll run this, you will get the similar output. Let me just remove this one. Okay, run this again. 1040, 2040. So to summarize this, let's create one diagram here. Let's make this one as base. You have this x here and this is y. Let me draw this box here which will show that y is having only single memory, and let's have this b1 object here and b2 object here. Okay, and this x will have memory here, and another x which is of this b2 will have memory here. But if you have y here and y here, this y is pointing to this location and this pointing to this location. So both are pointing to the same location here. But this x are different. So if you will write 10 here, then you can write 20 here. This is not overlapping each other. But if you will write 10 here, it means you're going to write 10 here, and if you want to write 20 now, you will be replacing that 10 with 20. Okay, so as this y is not specific to the objects, you can access this y using class name like this: base scope resolution operator is equal to 10. This is allowed for static data members, and there is something called static member functions. So if this is static member functions, it can only access static data member, and as usual, if it is static, you can access that using your class name. Okay, so base print y. This is perfectly legal code. And why it is working? Because this is not bound to the objects, and this print x is bound to the object because this is a non-static member function. Okay, and I think we are pretty much clear now. And if you are interested in constant data members, so let me write that here, constant. Then what happens? So for that, you please watch my next video, because this video has already become so big, and that constant thing is really very important. There are so many types of data members, right? Okay, I can get that, no problem, you will get it, because there was a day when I started learning C++ and I know it was not easy. So it won't be easy for you as well, but for me there was no YouTube and all, but for you there are hell lot of resources available. So if you want to know what is constant integer or constant character or whatever, watch my next video. So if you like the video, don't forget to hit the like button, and if you haven't subscribed yet, go for it. It would help you a lot. Thanks for watching. Bye bye. Hello friends, this is Rupesh and I'm watching C++ video series on C++, and in this video we'll be looking into this constant data members. So before this video we saw static data member and normal data members, what they are and how they behave inside your class. So this is a constant data member. So if you would have used somewhere like constant integer x is equal to 10, and if you're coming from C background, you might be knowing that okay, once you have initialized x with 10, you are done. You cannot modify this x now. Okay, so that much is pretty clear because you have created this x as constant integer, so you cannot change this once you have initialized it. Okay, so that's what it is studying. They are constant, so cannot be changed once initialized. And yeah, there is a difference between initialization and assignment. So this is an initialization, and if you are doing something like this now, then this is assignment. Okay, so this is assignment, this is initialization. Keep that in mind for some reference. So this is the typical behavior of your constant variables. So let's see how this is done in your class. So for that we need to think about a class. So let's suppose your professor has given you a task to create a class of circle. So in circle property there is something called pi, and this pi value is, if you know, then it's good, otherwise this is a constant term 3.14 and something, but this is generally considered value for pi. So if you want to get the area of your circle, then it's pi r square. We know that, right? So if you have r, which is radius of your circle, then you can get the area of your circle, okay, by using this formula. So let's module this thing inside your class. So let's create a class named circle and constant float pi is equal to 3.14, and we'll be learning two type of initialization. First is initialize itself inside the class, like what I'm doing right now. I am initializing this constant inside class itself, and another one is you can initialize this constant from outside the class, that we'll see later. So your pi is done. Now let's go for your radius. Let's keep it integer, or even take this one as float, no problem. Radius, okay. And now you need some constructors. I hope you know what is the job of constructor. An integer a and r is equal to a. So this is what your constructor will do. It will take the value of circle c1, and let's make it 5.2. So your circle's radius is 5.2. There is one circle c1 and its radius is 2, and this will go here, so it should be a float. Okay, so now you're initializing a, which is 5.2, inside r. So you are ultimately having this r and pi inside your c1 object, and you have done initialization for r here, and your pi is initialized automatically. So no matter how many objects you create, this pi will always be 3.14 for all the objects. And let's get the area of your circle. So area is going to be get area, and what is the formula for this one? R into pi. So pi r square. So this is the formula for your area, and if you want to print that, let's print that c1 dot get area. Let's compile this one. Oh, what happened? Okay, yeah, actually I forgot to keep things in private, public section. Generally what happens, you keep your constructor and all the functions in public section so that you can call from outside your class. So this is your class and you're calling them from outside. Okay, so this you are calling not inside circle class, from outside class. So this should be in public section, and we generally keep data in private section. Okay, so we will discuss all these things a little later. For now, you just understand that we are calling this one, and let's compile this. So 84.9056. So this is your area. If your radius is this one, your area will be this one. And let's create another circle C2. Maybe you just give this as area 10, and you can get output for that C2 dot get area, and let's compile this. So this is 314. Obviously 10 will get multiplied 2 times with 3.14, then it will be 314. Okay, so what I'm trying to tell you is this pi you have initialized inside class, and this is not gonna change for all the objects no matter how many objects you create. But there is a situation, and now I'm talking about this one, and this one is you can initialize your constant data member, which is this one, from outside this class. And outside this class means when you are creating the object, that time you can pass these values. Okay, so for that I need a little different example. Now I'll be taking the example of a phone class. Let's suppose you have a phone class, and we will not go for much details here, just keep the phone name and that's it. So phone name is a string type, then let's create const string p name. Okay, and phone, and this is your constructor, and get phone name. This is a simple function. It will return phone name and just return phone name now. And one important thing is, when you are using initializer list to initialize from outside, there is a different method you will use to initialize your constant data member. That is called initializer list. That topic is little big topic. I won't cover that, but I will show you how you will do that and you will understand it. So as I told, this is your constant data member, but you will not be initializing your constant member here. You will take it from here. So let's write that. So let's create phone 1 p1 and pass the name of your phone like Moto G4. This is your phone. Okay, so the property is, once your phone is created, you cannot change the name of that, right? But you can create different phones. So one time you will create P1, another time you can create P2. There you can write maybe iPhone 10. Okay, so this is another phone and its name is iPhone 10. Now once it has created, you cannot change that. Okay, so this is the logic. When you are creating the object, that time you are passing what is constant for you. So as this will end up calling constructor, and we have to create a constructor here. So as that is a string value, we have to take it as string str, and here comes the initializer list. Now notice this point here. There is this column and p name and this curly bracket, and inside that you just write str. Yes, this is the syntax for initializer list, and this is how you initialize your constant data member from outside the class. Okay, so if you want to check this, let's just print these values. Cout p1 p2 dot get phone name and just compile this. The same problem, I guess. I have not created inside public. Let's create this public and rerun again. What is this? Node candidate phone candidate expects 0 argument. What is this? This is string. Okay, see, now it is working. It should be string. I just did some typo here. So you have achieved setting your constant data member from outside the class. Okay, and once you have set this, you cannot change this. And if you want to see that, let's create another function which will change name. Actually, it won't be able to change that, but just I'm giving you the hint here. So we will get that name as str void. And if you want to change the name of your phone, like p1 dot change name, here you can write anything, my phone. Okay, so now if you will compile this, you will get the error. So we learned that this is not gonna work. Okay, so let's just remove this one. So we learn two ways of initializing your constant data members inside your class. First was inside your class itself. Let me go to that example now. See, this is your example. So first way was 3.14 was initialized inside your class because pi value will not change for different circles. It is a constant thing and it is constant for all the circles. So it was making good sense to initialize this one inside the class itself. But as we saw in the phone example, when you are creating different phones, they will have their own name, and after construction their name will not change, but that name should be coming from outside the class. So that we saw in that example, correct? And you learn what was the use of initializer list, and that initializer list looks like this one. So this is your initializer list, and you can use let me just do this. Yeah, and not only this, you can just use round bracket also here. That will also work. So there is actually a difference between this round bracket and curly bracket, but I won't discuss that here because this video is for students. The thing is, you have to remember these two things. That's it. Initializing inside class when it makes sense, initialize outside the class when it makes sense for this one, and initializing outside class requires initializer list. Okay, and yeah, one more thing. This initializer list work only in case of constructors. It won't work in normal functions here. Okay, so you can use this kind of things inside constructor only. And you might be thinking maybe some another data member is there, then what? So let's create another one, mem size. So you have memory slot and you will get memory slot size when you are creating this phone. So maybe Moto G is, I don't know, 32 GB, and this one maybe 16 GB. They always have less, right? iPhone, I don't know why it's like that. Yeah, so as you have changed this one, you have to change your constructor now. So you will get it like A, and now you can initialize your mem size here only with A. So this is the syntax for initializing your number of data members inside constructor using initializer list. Just use comma here and keep on initializing. So the left hand side should be the data member what you're initializing, and right hand side of that should be what is coming from this here. Okay, so this Moto G is inside this str, and that str we are initializing into this p name, correct? So let's just compile this. We'll see no difference here. Moto G iPhone 10. Okay, so this code actually compiles, and I'm writing here using this curly braces and round bracket because you can use either round or curly or mixed like this. And don't forget this bracket here. And it's not like you cannot write anything inside this. You can write. Let me just give you an example here. Let's call it constructed. Okay, so once your objects will get constructed, this will print that. See, constructed Moto G4 and iPhone X. So that's it. It was very simple, creating different objects, passing the constant value from your object itself like this. And don't forget, you have to use this initializer list in order to initialize your constant data member, and for normal data members this is not required. Anyway, you can do this. This is good practice. This is little optimized way of writing your constructor, but you don't have to worry about that optimization. We will discuss this things when you will get little mature about programming in C++. Okay, so for now let's just keep this much. I hope you would have enjoyed this video. If you like this, don't forget to hit the like button, and if you are not subscribed yet, go for it. It would help you a lot. So I'll see you in the next video. Bye bye.
Hello there, this is Rupesh and you're watching CPP Nuts video series on C++. And this video is about reference variable in C++. So this reference variable is not there in C, it is there in C++. Okay? So what is the meaning of this reference variable? It means that when a variable is declared as reference, it becomes an alternative name for the existing variable. Point this, for an existing variable. So in order to create a reference variable, you must have first some existing variable which this will refer. Okay, so it is something like this. Let's suppose you are having some integer variable x here, then you will make some reference variable, and the syntax for that is this one, r is equal to x. That's it. So what you did by doing this, let's suppose you created this x is equal to 10 here. Okay, so if you are writing this line, then memory would be created for this x and this 10 will go into that. Okay, so let's suppose there is some memory like this one, and this is your memory portion, and in that memory you are storing this 10 here. Okay, and this x is pointing to that memory. Got it? Now by telling that I'm making this r as the reference of this x, which is nothing but you are creating another variable, but that variable is also pointing to this memory here. Okay, so this is the difference between this normal variable and reference variable. Let's suppose you might have created some another variable like this integer k, and you might have created like this is equal to x. So this integer x is a normal variable, so if it is not a reference variable and you are assigning x into that, so we know how normal variable gets created. This x was normal, that's why the memory was created for that. So this k is normal, then the memory will be created for k also. So whatever is there in this x will come here. Okay, so k will point to this memory location and this x is pointing to its own memory location. Okay, so in this case, if you will change this k by initializing something else like 11, then this k will change, not this x. But in case of reference variable here, as both are pointing to the same memory location, if you will change this memory location either using x, like x is equal to 10 or 100, then this 100 will come here. So if you will print either x or r, both will print 100. Okay, because this r is also pointing to this memory location, and whatever the location was holding, it was changed by 100. Got it? So this is something like this. So let's take an example in program here. There is this normal variable x is equal to 10 here, and you are making another variable, let's suppose reference variable, and we are giving it as r. Okay, and you are initializing this into r. So this r is the reference of x. Okay, so this is the syntax of creating a reference variable. Okay, now let's do some operations so that we can check whether it is really pointing to the same memory location or not. So if you will print here x, which is nothing but 10 here, so it will print the value of x. So if you will print r, then it will print the same thing which is pointing as x here. Okay, now if you will change x is equal to, let's suppose 100 as I told, and if you will print this again, so I'll just copy and paste it here. So after changing this x is equal to 100, this x will also 100 and r will be also 100. So let's try that. See, first it is 10 and 10, after that both are 100. So it's not like if you will change x, then only it will change. If you will change r, then also it will change. Then only they are sharing the memory, right? So see, if you are changing r here, then also x is changing. Got it? So that implies that
both are pointing to the same memory location. Okay, and there are few points with this reference variable, and that first point is you cannot simply create this reference variable like this and later on you initialize with x. No, this is not working. Okay, because the rule is whenever you create a reference variable like this, it has to tell that what it is referring. It cannot refer nothing and later on you are assigning that. Okay, so that is first rule. And second thing is, let's suppose you made it like this, which is the initial case. Now you cannot point this r to refer something else. Let's suppose you created two variables, y is equal to 20. Okay, and you initially told that this r will be referring x, and you printed here, and later on you want this r to refer something else like y or something. No, this won't work here. Okay, actually this will copy whatever is there inside y inside r. There is no way to change the reference of r to something else other than this x. Okay, so these are few points you should be very careful when you are implementing your programs. Got it? So if you like the video, please hit the like button and don't forget to subscribe. So I'll see you in the next video. Hello guys, this is Rupesh. You're watching CPP Nuts video series on C++, and in this video we'll see this pointer in C++. And yeah, we have these points we'll discuss in between. So let's start this. So in order to understand this pointer, you need a class, obviously, and let's have this data type integer. Now public, I always forget this, I know that. And this is your parameter, this is your default constructor, and the parameterized one, initialize a, and you can create this object b1, which we'll call this default constructor, and another object b2 with some value, let's make it 10, and that is gonna call this one. Okay, so this much I know that. Now what is this pointer? To demonstrate that, let's have this void get, and not get, integer, and void set method. So get will just simply return x and set will set x. So x is equal to, make it a, and here we'll get a. Correct? So this is some member functions, and here we can call this b2.print, and we'll compile this. What did I do? b2.print. Oh, I didn't create it print, but still, actually I'm more habituated with this print thing rather than printing stuff here itself. Okay, let's compile this again. Wow. Okay, hit this. Got it. Now 10. So you know this much already. I know that. Now if I tell you that you can replace your function like this, instead of writing x here, you can write it like this, and instead of this x, you can write it like this. So ultimately what I'm telling is you can use something like this in order to access x, and this x is this x, and this x should be a non-static data member, then only you can use this. Okay, and this is holding the address of the calling object. So here you're calling this object, you're calling this get method on this b2. So b2 must be having some address, right? Because you have created b2 here, so b2 will be having some address, and you're calling this get function on b2, and you're coming here, then magically this pointer is pointing this b2. That's why whenever you get the x, that x belongs to b2, because there is one b1 object also, and b1 is holding its own x. So b1x is different than b2x. So how you get b2x when you don't write this and this? Actually what happens, when you compile your code, compiler will automatically write something like this, okay? And compiler will only write this for non-static data members, because static data members doesn't belong to object, they belongs to the class. As you have seen my previous videos, if you have not seen that, go ahead and watch static data member in C++. So we're talking about this one. So this is how, when you call some member function using some object, you always deal the data members which belong to the particular object. It never get mixed up. And this is the key of doing that. Whenever you call it, it will magically get this pointer, and this will be holding the address of the respective object on what this function has been called. So it is obvious now, if you have this b2 object address here and you're accessing x, then you will be accessing x which belongs to b2, not b1. So this is how your compiler internally achieved this, okay? And if you want to know more about this, let me just give you a hint. Like if you are writing b2.get or something, then what compiler does, I'm going to change everything now. You just don't have to do in your code. I'll just give you the example what compiler will be doing here. Compiler will do something like this: base get, base colon get, and the address of b2. Okay, so this will get replaced with this one internally, and as you can see, you are calling this get which belongs to base. It is quite obvious this get is inside base, and you're passing this b2's address. Okay, now as you have changed the calling here, you have to change this function also. So your this get will get converted into something like this. Let me just copy paste here, and now it will be looking like this: base pointer const this. So compiler will change this function like this function. Okay, so that's how you're getting this address as base pointer constant. This pointer is constant pointer to the base. It means you cannot change this pointer, or in other words, b2 is having some address, right? So b2 is pointing to some address. You cannot make b2 to point something else. So that's why this constant is placed here. But the point is, compiler will create it like this, and compiler really changes. Even if you write here this, or you keep it blank, I mean you just keep it x, compiler will check whether this x belongs to the data member part. Yes it is. Then it will check, is it a non-static member? Yes it is. Then compiler will automatically add this pointer here, and compiler will automatically change every function, not only get, this set will also get changed. Then only you are getting this x which belongs to your object b2. So if you are setting something like b2.set maybe now 20, then this function, I mean this line will also get replaced with something like this: set, and here you will have this b2 comma 20. Okay, yeah, this is important point. If you have some parameters, then how it would look like? It is going to look like this: your first parameter in almost all the compiler, but there is no standard that you have to keep it at the first place only, but this is how generally people do. I mean, this is where this pointer exists. So as you have changed this set, you have to change this also. So compiler will generate this like this. So as I said, base pointer constant this comma. So this is this one. Color is different, but don't get confused with this. Okay, so this is this only. I think you got my point, right? The only thing what I want to clear is, you must be having this question in your mind that if I'm calling this function which is set function on b2, then this set function, let's just remove the compiler generated stuff. Let's talk about our stuff and make sure you don't have this one. Okay, so you must be having this question in your mind that b2 have this x and b1 also have some x. Okay, so same function is being called, but sometimes this x is treated as b2x, and another time if I am calling the same function on b1, then this particular x will be treated as b1's x. So how is it happening? And this is the magic of doing that. Okay, so you just see this, you will get it. If you have any doubt, you comment. I'll be very happy to help you in this case. So compiler will generate this kind of function instead of this one, and compiler will generate this kind of function instead of this one. So even if you write this pointer in x, then compiler will see, okay, you have done my job, no problem. But you can skip this. You can just have x like this, but compiler will ultimately add this one here when compiler is generating the function for you. Okay, and this is how you really point to the particular object and the particular data member of that object. That's how you get associative x. Okay, so it's pretty clear now how compiler achieve that. Okay, so enough talk. So let me just remove all these things, otherwise compiler will not compile, because compiler will say that, hey Rupesh, you have done my job and you're not supposed to do that. You are a human and we have some rules for you to write the functions and all. Okay, so this is my boundary. I can go up to this only. Now let's read out these points. Now you know what is this pointer. This pointer will be pointing to the object's address. That's it. Okay, I won't repeat this again and again. So let's read this. This pointer is used to hold the address of current object. That is obvious, that I explained you so nicely. Using which we have called the particular member function. Obviously, if you are calling b2 dot set something, then this b2's address will go here. Okay, that's how you are getting this x differently. So let's look at the next point. This pointer is a constant pointer. Obviously, it should be a constant pointer. Okay, and constant pointer means you cannot change this pointer. So we were talking about this second point. Now the third point is this pointer is passed as hidden argument to a non-static member functions. Yes, this is very important. If you have static member functions, you won't get this pointer inside that. Okay, so static pointers, static functions are like this: static void print or something. So this is static function. If you don't know what is static function, please go ahead and watch my video which is regarding this, and maybe you will get the heading like static functions in C++. So if some function is static, you won't get this pointer inside this. And one more thing, if some function is a friend function, then also you will not get this pointer inside that, because this pointer is always inside member functions. So you have to be a member functions to get this pointer inside you. Okay, so if you're not a member function, you cannot have this pointer. Correct? And this is a pointer, that's why you are using this arrow operator. Correct? So that was some third point, I guess. No, yeah, second point. So third point is compiler automatically changes all data member access with this pointer. Yes. So wherever this member is coming inside your function, everywhere, wherever the x is coming, it will get replaced with this pointer. Okay, so it is not passed in static member functions. Yeah, that I already explained you. So I think we are done now. I hope you liked the video. Don't forget to hit the like button if you did, and make sure you subscribe to my channel, so whenever I publish any video, you will get the notification at the same moment. So I'll see you in the next video. Bye bye. Hello friend, this is Rupesh. I'm watching CPU Unit video series on C++, and in this video we'll look into this friend function and friend classes in C++. So there is a keyword called friend, and that is used to make some function or class as friend of your class. Okay, so we'll go through all these points. So first let's quickly create a class. So let's assume we have some class base here. So first let's take the example of a function. Later we'll go for class. So let's create some function. Let's make it void set, and then you will have this base reference object integer x. Okay, and inside this function what you're going to do is object.x is equal to x. Okay, so ultimately you are accessing this .x, which is of private data member outside the class. So this is what friend function allows. Okay, I mean, if you have made some function as friend inside your class, then that particular function is allowed to access your private data. Okay, because you said that that particular function is my friend. So compiler will allow to access your private data inside this function. Before, if you have watched my previous videos, I was giving set functions like this, void set here inside this, and here we was getting integer a, and we were doing something like this, correct? So this is obvious case, like if this function belong to your class, then obviously then this function can change or access x. But what if some function doesn't belong to your class and still you want that function to be able to access your private stuff? Then you will use friend function, and this is how you tell that some function is my friend. So you got this function and this is your class. Now you have to tell that this function is my friend. So this is the way of saying that. First you have to write friend, then this syntax. Okay, so base ref obj is optional. If you want to write, then write, otherwise it's okay. You just need to define the types only all the time here. Okay, this is the function. You said this function is my friend. Let's create some object and let's assign some value inside that. Let's make it 10. Call this function and pass this object here and pass some another value. Let's make it 20. So what will happen when initially your object was created, this 10 will go here and this x will get initialized with 10. So object having this x and that is having 10 value. Now what you are doing is you're changing this obj and want to assign 20 inside that and using this function. This is not a great example, but it will show you the use of this friend function. Okay, so you're calling this set function, which is this function, and inside this function you can access this .x because this is a friend. So let's compile this. It should compile. Oh, what happened? Oh yeah, actually you have created some function, your friend, but that function signature is not matching. How can I miss that? Integer. Now you compile. See, it has compiled successfully. Let's create another function which will get this value for you. So get, and that will return that obj return obj.x. This is what you want. So let's make them in one line, so it will take little less space. And yes, you are right. If you are accessing this x here, then you have to make this function also a friend function. So friend, okay, this time I'm not missing, right? Okay, now let's do this. Cout get obj and compile. See, you got 20 now. Okay, so you set 10. Let's call this cout after 10 also. So if you will run this, you will get 10 and 20 both. Okay, so that is correct. And if you are confused why this .x cannot be accessed outside this class, I'll just show you the example here. Let's try to access that. Okay, you're thinking maybe you can access that obj.x, but you cannot access that. If you'll compile this, you'll get the error saying that base x is private within this context. It is saying that this is a private thing, you cannot access this outside this class. So sorry. And not only this, I mean this private, it can access protected also, and public is already accessible, so there is no question about this public, but it can access protected also. So if this is protected, then also there is no problem. So protected and compile this. It's this one, which is making problem for you. See, it was telling that this is protected and you cannot access that outside. Okay, so if you have removed this, compile it, see compiled. So this is how you make some function as your friend. And notice one thing, this relation is like this. There is one class and that class makes some function. This is your function and this is your class. So this function will be declared as friend inside class and you are supposed to declare that. Okay, no one can come and tell that okay, I am your friend. No, you always says that that is my friend and this is my friend. So there is this class, you are the owner of this class, you will say that this particular guy is my friend. So this is how you will do that. Okay, now another thing, there is another class. Yes, one class also can become a friend class. Okay, so instead of making some function, now you want to make some class as your friend. But notice one thing, this particular thing is always class. Okay, this class is telling that this guy is my friend, this class is my friend, but this is not function. Okay, it cannot be like this. One function is there and this function is telling that this class is my friend or this function is my friend. No, this is not there. Okay, so always class is there and class tells this function is my friend and this class is my friend. Okay, so till now we saw how to create a function as your friend. Now let's look at the class example. So let me just simply remove all these things and let's quickly get rid of this and maybe this, and let's create some class here. Class get set. This will have these functionalities, so it will get some values for you. Okay, so the same functions what we saw here, getters and setters, will implement inside this class and we'll just simply make this class as your friend. So friend class get and set. So this is how it will look like, and if it is set, it will have base ref obj.integerx and it is going to return obj.x, and here we'll set obj.x is equal to x. So this functionality is pretty much the same what we saw in the function case, but this time you are making this whole class as your friend. So every member function can access these private and protected. So let's make this private for now. Now here is one thing, in C++ the compilation goes like this. Your compiler will come here and it will check okay, everything is fine. It will come here, it will come here, and it will check what base. I have not encountered base yet. I don't know what base is, so it will show you the error here. Let's check that. See, error, base has not been declared yet. Okay, so if you will keep this base from here to here, and if you will compile this now, it will work. You are just simply saying that this is going to be your friend, and if this friend doesn't exist at all, let's just remove all these things and just compile. Then also doesn't matter, because tomorrow morning you can just wake up and say that hey, John is my friend. Who cares John exists or not? But in this case, I mean in this get and set case, the error was because you are saying that my object will look like base. Okay, because this was like this right here, and you're saying that my object will look like base. So compiler don't know where is the base, but in this case you're saying that someone is my friend. Compiler don't bother. If that friend is accessing your private stuff, then compiler will check okay, it is allowed to access, I mean it is allowed for that particular class or function to access your private data parts or not. So I think that's clear now. So let me keep it here. So I think it makes sense. So before you saw friend function, now you're going to see friend class. So this whole class has become friend of this class. So let's do some experiments here. So as you have this get and set, let's create the object of that get and set. So cout gs.get, and you will send the object, and after that you will set the same object with different value, and let's call the gs.get object. This is, yeah, here endl is required, and I don't think we are missing something. Yeah, we are missing this one. Okay, so what we are doing here is you have this object which is initially 10. I mean, this is a 10 value. I mean, this x is holding this 10 here. Now you created this class has this function, so it's pretty cool. You're calling this function and passing this object here, which is coming here, not here, here, and just returning .x. Okay, and this whole drama is happening just because you cannot access this .x, which is private. So this whole thing is happening just because you want to access this private, so you want to become, so someone have made you as your friend. Otherwise there is no need of doing all these stuff. Okay, so let's compile this and see 10 and 20. 10 and 10. It's pretty cool, huh? So instead of writing so many functions as your friend, you can put everything inside one class and make that particular class as your friend. So all the functions inside that will automatically become the function, friend function of your class. Okay, but wait a minute, that is not the ideal situation. Okay, so you should not make things like this. Until unless it is really required, you should not go for friend functions. You should include some function inside your class if you think that function should get your private data members. Okay, and if you want to see where you can use friend function and classes, then watch my another video. I will be giving the link in the description field. There I have talked about where you can actually use friend classes and friend functions. So you saw that you had friend function, before this example, and this is your friend class, and this is the only use of friend keyword. And this whole thing is happening just because classes have this kind of protected and private data, and you explicitly want to give the rights to non-member functions that they can access your private data. So let's read out this whole thing again. Function cannot become friend of another function. Yeah, that's what I told here, right? One function cannot become the friend of another function. There's no sense in that. Class cannot become friend of function. As I said here, if you have some class, that class cannot become friend of some function because this is a function. Okay, a friendship is not mutual. If a class A is friend of B, then B doesn't become friend of A automatically. Yes, that is very important point. This base is saying that getSet is my friend, so getSet is allowed to access .x, which is private inside base. But as base has said that getSet is my friend, it doesn't mean that getSet is saying base is my friend. So if getSet is having some private data inside that, this base cannot access that. Base can only access when this getSet will say that, yeah, base is my friend. So if you are declaring this base as friend here inside this, then only this base can access. Okay, so that is a good point here. Now friendship is not inherited. That is also a very important point. So if you are a beginner, you may find it a little difficult because maybe you don't know inheritance, but let's assume you know an inheritance. So if this is base and there is this getSet function, class, and here you are using inheritance, make it public base, and let's make some function as friend, not class. So function. Okay, so this is some function, simple function, and you say that this simple function is your friend. Okay, so this is what I'm talking. There is a class. This class is telling that some function, this one, is my friend, and that class is inherited inside another class. Then this class will not have this function as friend. Okay, remember this. This class will not have this function as friend. So friendship is not inherited. This is also very important point. Someone can ask you in the interview questions. Okay. So this function will not become friend inside this class. So I think we are done here. I hope you liked the video. If you liked it, don't forget to hit the like button and make sure you subscribe to my channel so that whenever I create some videos, you will get the notification at the same time. Bye bye.
Hello friends, this is Rupesh. You're watching CPPNet's video series on C++, and in this video we'll be looking into this encapsulation topic in C++. This is a very easy topic and you will get it just like a snap of the finger. So let's start this. Encapsulation is an object-oriented programming concept which talks about binding together the data and the function that manipulates those data. Yes, binding together data and the functions happens in class. Yeah, so let's create the class here. As usual, we will have this base class. Here goes your data, okay? And then public, and you will have some functions here which you will call to manipulate this particular data. Or if you are having 10 or 20 data, you will be calling those functions. So let's make some functions here. So set x, which will set the value of x integer, get x, which will return the x. So return x, and x is equal to a, and here we are getting a. Okay, so this is the function and this is the data. You encapsulated these two things in one thing, and that is called base. So can you see here, you are encapsulating two things, the data part and the functions which will manipulate that data. Okay, so your class is a perfect example of encapsulation. Okay, generally what happens in encapsulation, like if you are looking at some capsule that look like this, right? So let's suppose you have some capsule, it looks like this, then it has two parts. One is a data part and another one is the function part. So data is this one, function is this one. You encapsulated these two and called it base. That's it. So let's read this. Class is an example of encapsulation because it does what we need. And if we have created some class and have data member and the member function in that, it's an example of encapsulation. Yeah, because sometimes what happens, you create the class, but you don't have the functions for that. Everything you keep as public and you just accessing it from main or some outside function, then in that case, that's not the example of encapsulation. The encapsulation is your data and the functions should go together, okay? Because you have the option of not including this function, just erase this and make this x public. So instead of this one here, you can make this x public. Now, if you are creating any object here, you can access that, right? So I'll just show you that. So instead of these functions, you know these functions will do their job, right? But you can have something like this also, like public. And now, if you are making some base b and b dot x, you can set here and you can get it, okay, like this. So if you'll compile this, this is a perfect code. See, you got 10 here. But the problem with this case is you are missing this function part. You don't have these functions. You just have the data, correct? So that is not the case of encapsulation. This is something else. I don't know what to call this one, but surely not the encapsulation. So this was about encapsulation. And if you want to know what is abstraction and data hiding and all that stuff, watch my coming videos. You'll understand that so nicely. So thanks for watching. And if you like the video, don't forget to hit the like button, dude. And if you haven't subscribed my channel, go for it because I'll be uploading videos like this and you will get the notification right away. Bye-bye.
Hello friends, this is Rupesh and watching CPPNet video series on C++, and in this video we will be looking into this data hiding concept in C++. So let's read out this first comment here. Data hiding is about data member in classes. We keep data members as private and this is considered as data hiding, nothing else. only this much. If you are keeping something inside your class as private or protected and you don't want to share that, or you don't want that thing directly to be accessed from outside world, that's where you are hiding the data, and that is called data hiding. Okay, when I started learning C++ and when I came to this point like data hiding and all, I was like, maybe it is hiding the important information so that no one can hack it. So this came in my mind because that time hacking was so popular and everyone was hacking here and there because systems was not that great. So you will always listen that, okay, somebody hacked this one and somebody hacked that one. So that time it was like this. So I came to this conclusion, right? Okay, maybe it's because to prevent the hacking, but it's not about hacking. Okay, it is about correctness of the data and preventing the accidental manipulation of the data. So what you are saying is, I will be keeping something as private. So let's create some class here. No, first let's read this one. Audio player volume increase. So this is the example I have chosen for this particular problem. So what happens, you have some player, let's say ABC player, whatever it is, and you want to set the volume, and you have been given from 0 to 100, and this is the bar. You can set this much, right? Generally, this is the values you can go for in volumes. So let's create a class. We'll get it better. So ABC player. I don't know whether this kind of player really exists or not. And we can have just one button called volume, and let's keep it private. And there is another thing, that is a function set volume. Okay, and here you will send the volume. Let's say you are sending the volume, and this is the function which is going to set that volume. So the possibility is, see, you will be having this as a public, correct? This function is public so that you can set from outside. So from here you will set it. So let's make this ABC player ABC dot set volume. Okay, and initially maybe when your player will start, it will be initialized with 0. So let's create a ABC player and initialize it 0. So if you are creating some object, the volume will be 0. So initially it will start from the 0, and now you want to set maybe 50. That's it. And let's do one thing, just copy and paste this, volume is equal to X. That's it. Then what if I'm sending ABC dot set volume minus 30? Is this going to work? Yes, it is going to work. So what you will do, you will write a very smart program here now. You will set volume is equal to X when this condition will pass. If X is greater than equal to 0 and X is less than equal to 100, then only you will do this. So here comes the data hiding part. You have hidden this data and given the interface to change that data, and that interface you have implemented in such a way that your data should be in always good state. Your volume should be always from 0 to 100, right? So if you are passing minus 30, then it should not set that volume minus 30, and in this case now it won't. So we can have just simple message here. If you have set it, then set, and if you could not set that, just print can't set. So if you will run this program, let's hope it will compile. See, it has given set and can't set. So 50 is a valid value for this volume, but this minus 30 is not. And not only minus 30, if you are going other than this value, maybe 1000, so you cannot set 1000 value, and you can set 0 value. Let's remove this. So if you're setting 0, it's okay. So let's compile this again and see the same value. If you will make this one something else, now it won't set value for either. See, can't set, can't set. So actually this is not the point. The point is you're hiding some data. This is the data, and giving the interface for that data to be changed, and you're carefully implementing that interface so that you accidentally don't mess up your data, which is this one. Okay, and suppose you are not giving this interface, let's just simply comment this, and what you can do is just copy and paste it here. So actually you're making this non-hiding stuff. Okay, so you're not hiding this volume now, and let's remove this. So what you will be able to do is abc dot volume is equal to maybe 30,000, and this will work. Okay, because this is public and you're setting it. So you can see the potential risk in these kind of implementation. That's why generally we keep the data inside private section, and we give the interface like this to set and get those data. Okay, so don't forget, it is about correctness of the data and preventing accidental manipulation. Okay, this is just about that, nothing else. So thanks for watching, and if you like the video, don't forget to hit the like button and make sure you subscribe to my channel so that whenever I'll push some video, you will get the notification at the same time. So I'll see you in the next video. Bye bye. Hello friends, this is Rupesh and watching C video series on C++, and in this video we will be looking into this constant member functions in C++. So yeah, you have constant member functions, and the use of that is it restricts the modification of data members inside function. But you still have one way of changing that, and we'll see how it works. So let's create that traditional class base, and let's make this integer x and default and the parameterize integer a. You might think I'm keeping this all the time similar, right? But there is a reason for that. If I won't do this, you will find hard to remember stuff. Now you can relate, okay, from the previous video. That's why I'm keeping all these things similar. So now the question is, it restricts the modification of data members inside functions. So let's create the functions, and let's create some getters and setters. So void set x, which will set x as a, and we'll get a here. And let's make integer get x. This is gonna return x. Okay, now what you want to do is, in this function, what you are just doing is you're just taking this x and returning from this function. You're not changing this x. So what you can do is you can create this function a constant function, and it will say that I'm a constant function, I will not be able to change data members. So if it is non-constant member function, whatever data members it can change, after making this function constant, it cannot change those data members. So this is the way of making it constant. After writing this, the function name and these round brackets, this becomes a constant function. So let's just quickly see this. If you are having this b here and b dot set x, you are setting this value as 10, and b dot get x, you should be getting that value, right? So let's print this. See, we got 10 here. It's cool. Now I wanted to tell you that if you will change something, let's suppose you're saying get x, but you want to change it into 20 inside this, and after that you want to return that x. So if you will compile this, you will get the error. Assignment of member, this is read-only object. So this is what I said, but there is a way actually. So that way is this mutable keyword. So if you will make this data member as a mutable, it says that all data members are not allowed to be changed in constant, but this mutable is. So now it will compile. Let's compile this. See, it compiled and you got 20 now, because you call this function and it changed the value, and then you are getting this x. So you got the changed one. So if it is mutable, then only it is allowed to change inside this constant. I will show you it another one. Let's make it something like y here, not required to initialize it here, but still okay. Y and B, and just do this. Y is equal to make it 30. Okay, so there is no problem with this, but there is a problem with this. So let's compile and check this. See, it is telling here assignment of member and the same error. Okay, so that's it. This is the use of this constant member function. This is a great message to the viewer of your code that this function is only for the purpose of returning something, but surely it will not change any data members. And if that guy want to verify that guy can just simply see these data members. Are they mutable? If they are mutable, then they can be changed here. If they are not, then this function is totally constant function. Okay, so that's it. If you like the video, don't forget to hit the like button and make sure you subscribe to my channel so that if I am pushing any video, you will get the notification right away. Thanks for watching. I'll see you in the next video. Bye bye.
Hello there, this is Rupesh and you're watching CPP Nut video series on C++. And in this video, we'll be learning about what is recursion in C and C++. The recursion is similar in C also. So if you are from C background, you can follow this video. There won't be any difference. Okay. So the point is function calling itself called recursive function. Okay. So what do I mean by that? So let's suppose there is some function like this, void and like print here. And there is some parameter inside this function. It is calling itself print like this. Okay, so you will call this function from, let's suppose, main. There is some main function. We know all what main function is, and from main function, if you are calling this function, and let's suppose there are a few lines here, you are executing those lines, and after that you are coming to this point which is called to yourself. So you will call yourself again. Okay, and then you will execute these lines again, and you will hit this print again, and you will call back. So it is like keep on calling yourself. Okay, so this is called recursive function. So let's check out the code here to understand better. So this is our example code here. We are calling this print function with this 3 value. So it will come here. This times is equal to 3 now. So if times is equal to 0, then we will return. But no, it is not 0, it is 3, so we will not return. So we will execute this statement, which is C++ times. So it will print like C++ 3. After that, this line will execute. This is nothing but pre-decrement operator. So we will decrement it by 1. So times has become 1 now. After that, we are calling yourself, okay, with the updated value. So this is 2 here, okay, and you will call yourself again. Now you are 2. 2 is equal to 0. No, it is not 0. So this condition is false. So it won't go inside. You will call again C++ 2, decremented by 1. So this time it will become 1. You will call yourself with 1. 1 will come here. 1 is equal to 0. No, it is not. You won't go inside this one. So you will again call yourself. So this is 1. Now it will become 0. Okay. And you will pass 0 here. And you will come here and will check that, okay, is this times is equal to 0? Yes, it is true. So in that case, you will return. So where you will return? You will return to this only, because you reach to this function from yourself. So you will come back here, and what is left? The left portion is printing this one. So that time when you call this function, that time the value was 0 here, okay? So 0 will get printed here, reverse 0, okay? Then you will go back here again, because you came to this printf function because of this function again when the value was 1. So you will come back again and you will print this 1 here. So let's check how this whole thing will work here. See, so as you can see here how it is working. So let's take an example where I'll show you how this whole thing is working in the form of snapshots. Okay, so let's take a look at that. So this is how your program actually look like when it comes to the recursion here. So this is one snapshot, another snapshot. So it worked like a snapshots. Okay, so let's iterate it one by one. This is 3 here. So note it down. It is very small and it will be very easy to understand this. So you're calling this with 3. 3 is coming here. It is checking, is it equal to 0? No, it is not equal to 0. So it is printing C++ with this times. So this is 3 only. Okay, so like this one, C++ with time 3. After that, you are decrementing it and printing it again. I mean the calling yourself again. So I have shown calling like this inside bracket here. So this is also calling and this is also calling. But when you was calling this print here, that time reverse was having this 2. See, okay, you're calling from here, but the time was 2, right? So that's why this reverse is 2 here. Okay, note it down. This is very important part. And you didn't came to this now. You directly call yourself, so you went to another snapshot like this. Okay, so in that case you again check time is equal to 0. No, it is not equal to 0, so it won't go inside this printf. So you will come here and that time printing 2. So like this, and before calling this you are decrementing. That's why I'm calling with 1 here. Okay, because it is decremented here. Got it? So you're calling with 1, then 1 is getting printed, then this is getting decremented here. So you're calling with 0, then another snapshot is coming. Now see, this is coming into the picture. 0 is passed. Okay, so there is a time when you will pass 0. So 0 will come here, 0 will get equated with 0 like this, which is true, and you will return. Okay, so you'll return. Where you will return? From where you was called. So you will come back here only, and whatever is left you will do that. So you was executing like this line and this line and this line, and you called yourself again, so you went to another snapshot. So now if you are coming back from the journey of yours, then you have to complete rest of the job, right? So the rest of the job was printing this reverse. Okay, if this is printed successfully, then you will go back here because you was reached to this snapshot with the help of this function. Okay, so the same thing will happen. This job is done in this snapshot, so you will again keep on executing the consecutive step. So here only one step is there, which is this reverse 1. And why 1? Because when you called this function, which is this print function, that time this times was 1 only. That's why it is 1 here. Okay, so that's why I'm calling this snapshot. It take a snapshot of all the values, whatever the values are at that moment. Okay, so you will print this one also, and you will come back from there to here. Okay, so the same thing will happen. Whatever is left out, you will complete that. Here only one thing is there, just reverse 2. So you will print that and you will go back. So yeah, where you will go back? You will go back to this one. Okay, so this is how you deal with the recursion. This is the best example someone can explain with. Okay, so that's why when you was printing it, it was like 3 to 1, because this is like printing 3 to 1, and you are again going here, but you are not printing anything because 0 is equal to 0. You are coming back. In reverse, you are printing 0. See, first you are printing 0 here. That is just because of this one. You're going back from here and printing 1 here. So 1 is coming. You're going back, printing 2. So this 2 is there. You're going back and everything is done. Okay, so this is how this recursion work. Okay, so if you like the video, please hit the like button and share with your friends, and don't forget to subscribe. So let's begin the next video now.
Hello friend, this is Rupesh. I'm watching CPP Nuts video series on C++, and in this video we'll be looking into this structure in C++. So there is no big difference between classes and structures. There is a big difference in union and structure and union and class. But if you're talking about structure in C++, I'm not talking about the structure in C. That is a very big different structure in C. But when it comes to C++ structure, it is almost similar to the class. But there is only one difference, actually two differences, but both are considered one only. So we'll be looking into two examples. First is this one. Structure in C++ is similar with the classes in C++, except by default, access specifier in classes is private but public in structure. This is the main difference. That's it. So as you can see here, and yeah, if you have not watched my classes and object video, better you go and watch that first, so you will be having the concrete knowledge about classes and object, and then you come and watch this one. So I assume you know what is classes, so let's start this. This is a class example and this is a structure example. You can see here there is no much difference. Both syntax are equal, like here you will write class and here you will write struct for making structure. Okay, now here comes the difference. Let's suppose this is base and let's make this one base 2 and this one base 1. So base 1 is a class and base 2 is the structure. Now the difference is, by default this X inside this class is private. So if you are not writing any X specifier like private and all, this is default private. But in case of this structure, this X is by default public. Okay, this is the first difference. So to demonstrate that, let's create base 1b1 and base 2b2 and try to access b1.x is equal to, let's make it 10, and here b2.x is equal to 10. So as you can see here, we are accessing X of base 1 and X of base 2. So in this case it will be allowed, but in this case it won't, because this X is private member, so you cannot access from here. Okay, so let's check that. Okay, it is telling so many things, but yeah, I forgot this semicolon here and everything is good. So let's compile this again, and yeah, see, you are having two message here. One is saying error, X is private within this context. Okay, and this is the context. It is telling X is private, but see, there is no error message here. Okay, and if you will make this public explicitly, if you'll compile it, it will compile. See, it has compiled. So that's the first difference. No matter what it is, if it is data member or member functions or constructor, destructor, whatever it is, by default classes have private and by default structures are public. Okay, so that's the first difference. Let's comment out this one and go for the second difference. So this is your second difference and both are looking equal. See, the first case is a class case where A is the base class and you're deriving this A inside B, but you're not writing the access specifier here and here. So this is structure case and this is class case. You're not defining. If you remember, we used to write like this, public, and here also public. Okay, something like this we need to write, right? But if you are not writing anything, then by default, as usual, class is private inheritance and structure is public. So as I told you here in this case, by default class was private. So similarly, by default class inheritance is private inheritance and structure inheritance is public inheritance. That's it. That is the only difference in between classes and structure in C++. There is no other difference. Okay, so if you know class, you know structure equally, except these two differences. Okay, so I hope you like the video. Don't forget to hit the like button if you did, and make sure you subscribe to my channel so that you will get the notification whenever I push a new video. Thanks for watching. I'll see you in the next video. Bye bye. Hello friends, this is Rupesh. I'm watching CPP Nerds video series on C++, and in this video we will be looking into this union in C++. There is no difference between union in C and union in C++. Actually, there are few rules when you create union, and inside that you have some objects, but this is a very basic video. I won't be covering all those things. So these are the notes. Just like structures and classes, a union is a user-defined data type. So classes and structures, user-defined data types. So similarly, union is also a user-defined data type. You will write union just like you used to write some classes and structures. But there is a very big difference that we'll talk now. So the second point is, in union, all members share the biggest same memory location. This is the key point of union. So let's create a union, then we'll talk about this one. The union creation goes like this. Union is a keyword, then you give the name. So I'll just give my union and semicolon, and here you give the data members like integer x, short y, and character c. So this is how you give in classes and structure also, but in union you don't have any constructor, destructors, nothing. You just define data members and that's it. So now let's talk about this one. So as I said, this unions, all members share the biggest same memory location. So you know this integer will take 4 byte, short will take 2 byte, and character will take 1 byte. So which is the biggest element, data member inside this? This one. So what will happen? Union will create only one memory like this, and let's make it 4 bytes, and this x, y, c, all data members will point to this only. This is the key point of this union. What will happen? You will create union will see which one is the biggest one, and it will create one memory for that. Okay, so integer was 4 byte, so it created 4 byte, and everyone is pointing to that byte. That's it. Now you might be thinking, what is this? What is the use of this one? So we'll see all those use cases. Wait for some time. So you understood how this will behave. Okay, so biggest element memory will be created and everyone will point to that. Okay, so now let's move to the next one. This is used to achieve polymorphism in C. Yes, if you remember polymorphism, maybe you don't know what is polymorphism, then let me tell you that polymorphism means similar name but different work. Okay, so it will be like different work or different functions, I can say, but these functions will have similar name, and that is called polymorphism. And here also, can you see there is only one memory and everyone is pointing to that memory only. So this is how we achieve polymorphism in C. So let's recap this quickly, then we'll go for the use cases. This is the keyword for making union and the name of the union. Then you type as many data members you want inside that, and it will take the biggest data members size and it will make every different data members to point to that memory only. Okay, so this is what union does. Now let's see the use of this one. So you might be able to understand this, like if it is having so many members but still creating the biggest one only, then the maximum size of this union would be the maximum data member size, right? So here, if you will get the size of this one, it will be 4 bytes. If it would have been a class or structure, it would have been like 4 to 1, and the structural padding will come, so it will become 8 byte, not 7. If you don't know what is structural padding, I have a video for that. But that's not the point. The point is union will be 4 byte only. No matter how many data members you have, it will take only the biggest size. So you can see here you are saving so much of size here. So that's the first point. When we need only one value out of many, that time we will use it. It means there is a situation like you have to create so many data members, but at a time you will be using only one. Okay, so no need to create different data members. Like when you create classes and structures, you have different sizes, but that is wastage of memory because only one is needed at a time. This is the example. Here what is happening is I have created a union square and given two integer, width and height. So you might be knowing what is square. Square means like this. The height and the width will be equal, a square. Okay, so I have created a square class. So if width and height both are equal, then why we need to take two different data members? So that's why I have achieved this using only this width. So either you set only width or the height. So this is square. So as I said, it will be choosing the highest one. So both are equal. So it will take 4-byte memory, and width and height both will be pointing to that memory only. Now let's create the object of this union. So sqr is the object, and I am setting width is equal to 10. So ultimately I am setting height also. Now what I am doing, I am getting this get area. So the area of square is width into height. So I am sending square dot width and the height. But here I have not set the height, but as I said, height is also pointing to this 10 only. So it will go and get multiplied. 10 into 10 will get 100 here. So let's compile this. See, we got 100. So this is a perfect code. I couldn't find a better example for this, but I think I made the point. The point is, when you don't need several data members, but it is quite logical to have those members, because if you are making square, then you cannot have only width, right? Or only height. You must have both. But here the situation is what the value of width will be, that is equal to the height. So no need to take two data members. It will make your size bigger. So these kind of situations are handled using union. This was the first example. I'll show you the second example also. That is a very nice example. Actually, there are so many examples. If you'll Google it, you will get it. But my job is just to convey the message. So here what we are doing is we are having this 4 bytes, and as usual this is 0, 1, 2 and 3. Actually it depends how your memory is reading the addresses. In my system it is reading from here. Okay, so if you are initializing 2, it will go here. So as this is 8-bit location, it will be like, I will write it here, 0, 0, 0, 0, 0, 0, 1 and 0. So 2 is this one in the binary. Okay, so this is going to this one, and the rest of the values are still 0. So everything is 0, 0, 0, 0 inside this. Okay, now let's suppose the requirement is you just want to read the first byte of your value. Then this is a very handy way of using that. Okay, what you can do, you can just simply read the byte number 0, and we have to typecast it into integer, otherwise it will show you the character at second ASCII. Okay, so wait a minute, let me just typecast that. So let's compile this one. See, it is giving you exact thing what we were looking for. 0th location is having 2, rest of the values are 0. So this is what we saw here. Okay, so you have this integer value and you want to access it byte by byte, not full. So as you know that character is 1 byte, so if you will read this byte's 0th location, it will read only 1 byte. Now it depends what location you want to get. Okay, so this is also a very good use of union. Okay, so just keep your main data and create that much big character array, and you will happily use this. Okay, so let's just change something. If you will make this 257, so you must be getting this one as 1 and this one as 1. Okay, so let's check that. If I'll compile this, see, you are getting 1 and 1. So 256 means there are 8 bits here, and the last bit is 1 here, and this is 0, and there are 8 bits here, so there are 7 zeros, 0, 0, 0, 0, 0, 0, 0 and 1. So this is your 257, but as we are reading only byte by byte, so this is only 1. Okay, and this is also 1. That's why we got 1 and 1. So it's great fun, right? You don't have to go and fetch bytes explicitly. You can use this technique and it will work really great. These kind of techniques are not so common. People use these kind of things in embedded because there you will have so much of problem in memory side. You will be having very less memory and you have to work with it. Okay, so they keep track of memory so much. So that's why if you are an embedded developer or you want to become an embedded developer, you should be mastering this union, or you can expect this union question in embedded interviews a lot. So I think we're done here. Thanks for watching. And if you did like the video, don't forget to hit the like button. And make sure you subscribe to my channel so that whenever I will create a new video, you will get the notification for that. Okay? So thanks for watching. Bye bye. Hello friends, this is Rupesh and watching C++ video series on C++, and in this video we'll be looking into this bit fields in C++. So this bit field is not dedicated to C++, it has come from C. So as this full series is about C++, I'll be covering these points. So what is the use of bit field in C++ or in C? To understand that, let's take an example here. I will create either class or structure because it works in both of this type, and remember this, it works either on class or in structure only. It doesn't work on anything else. Okay, so in order to understand that, let's create a class. Okay, leave it. Let's create structure and date. Yeah, this is very standard way of explaining this bit field. So date has three components: day, month, and year. So unsigned integer day, unsigned integer month, and unsigned integer year. So our data structure is ready for date. D is for date, M for month, Y for year. Correct? So if you will create this date d dot d is equal to, let's make it 8, and d dot m is equal to 8, and d dot y is equal to, let's keep it 1989. And this birth date is very important for me. So as you have put the values here, you can print these values, no problem. So d dot d, d dot m, d dot y. Okay, so let's put some indentation. So if you will print this, let's do that. You will get that 8, 8 and 1989. So this is perfect. If you want to store your date, you can go for this. Okay, and let's print the size of this data type. That is very important. Okay, that's why we use this size of date. And if we'll print this, the size is 12. So you might be knowing why size is 12, because this is integer and it will take 4 bytes. So 444, it is 12. Okay, so everything is pretty cool till now. But wait a minute, just think about it, that you're using 4 byte to store month, but we have month from 1 to 12, and then it will again repeat and it will again repeat. So this m is always going to have the value between 1 to 12, and same goes with this one also, because this is date and date is not going to exceed 31. So 4 byte is very much for this one and this one. Okay, so we don't need 4 and 4 byte. That's why this bit fields come into the picture. When there is a scenario that you can restrict your data type size, because you know that you won't be ever using that much size in your data structure. Okay, so in that case you can reduce that. And if we will talk about this year can be anything. Okay, so this integer is perfect for that, but month and date are so limited. So in order to calculate that how much bit is needed for this one and how much bit is needed for this one, we should check that what would be the maximum size of your date and month. So month will not exceed from 1 to 12. Okay, so this is the limit for your month. So in order to store this 12, how many bits you need? So if you will calculate that, I know most of the people would have got it. I'll still explain that. You might be knowing this 0001 and till this 1111. So this is 15, and this is 0 and this is 1, and intermediate values will come here. Okay, so as you can see here, the list is showing that you are having 4 bits enough to store 12, because this 12 will come somewhere here. Okay, and if you will take 3 bit goes only till 7. Okay, so this will be 0 0 0 0 1, so this is 0, this is 1, and this will be 7. So at max with 3 bits you can store 7, but with 4 bit you can store till 15, means total 16, and here total 8. So you might be knowing what the formula is. Like, formula is 2 to the power 3, because this is 3 bit. Okay, so 2 to the power 3 is equal to 8, and here 2 to the power 4 is equal to 16. And why 2 to the power means? Because your number system have only 2 digit, either 0 or 1. Okay, so from that, how many possible numbers are there? This is the one. Okay, so this is a different topic. We were talking about the size of M. So we got it that we need only 4 bits in order to store month, and how many bits for date. So if you will increase like 2 to the power 5, this is going to be 32. So in this case, from 0 to 31 means total 32. So we need 31 to be stored. In that case, we need only 5 bits so that we can accommodate the bigger date, and which is 31. Okay, so this is how we calculate it. So we need only 5 bits. So in this case we need 5, and in this case we need 4. So let's see the syntax of writing, how to write the bit fields. So this is your program now. Now concentrate here. We're going to write the bit fields. So if you remember, for this one it was 5, and for this one we got 4. Okay, so this is the way of writing bit field. You're saying that I will be taking 5 bits for date variable, D variable, and 4 bits for M variable. Okay, so if we will run this again, we'll get the size 4 byte less. So let's check that. See, everything is perfect, but size is reduced. Before size was 12, now size has become 8. And why 8? I'll tell you that. So now you understand this, that this is the syntax of using bit fields. We calculated that D will not exceed more than 5 bits and M will not exceed more than 4 bits. So we used it like this. And this is going to use 4 bytes of this integer. Okay, but they will not use full 4 bytes. And now let's talk about why it is having this 8 here if we will compile this. So let's understand that. So if you know what is structural padding and packing, you will be able to understand this very quickly. Otherwise, you'll have to go and see those videos of mine. I'll give the link in the description field, don't worry about that. But I'll try to cover that point here also. So this is how it's going to look like, and 4 bytes, right? So this is 4 byte and this is 4 byte. So this is this one. We have this Y here. But this 5 and 4 bits, as this is 4 byte, it means total 32 bits. In that case, either this first portion of this one is going to be 5 and next of that is going to be 4, or this one is going to be 5 and this one is going to be 4. Why I'm saying or? Because this is totally implementation defined. Okay, so however you have implemented your compiler, you will be defining that I will follow this rule or this rule when I am dealing with this bit fields. Okay, so this is totally implementation defined. And why we are using only 5 and 4 but ended up losing this much of space? So the answer is for memory alignment. So as I said, if you know what is memory alignment, it will be easier for you to understand this. But note down one thing: when your compiler is creating memory for your structure or classes, it will search for the bigger data type in this. So the bigger data type is this one, integer, right? So in that case, it will create whatever the size of this one is. for the first block. So let's suppose it is going to create that, then it will create first block of 4 size. So there will be total 0 to 3 blocks of memory. And now it will place from top to bottom. So it will start placing this one first inside this block. I'm repeating this again. It will create this block depending on the size of the bigger data type. So it has created one full block of 4 byte. Okay. And then it will start placing from top to bottom. So it will try to fix this 5 bits and it will place these 5 bits first inside this. As I said, it is totally dependent, but for simplicity I will assume that it will place first, and then 4 bits for this M. Okay. Now 5 and 4, total 9 bits are occupied, but rest of the bits will go waste. Okay. So out of 32, you are using only 9 bits. Okay. So the rest of this 23 bits are going waste. And yeah, we were talking about something else. We were talking about, we created this this memory block of 4 byte because of this bigger data type, and we started placing from the top, and we placed 5, and we found that okay, we can place 4 there, so we placed 4 there. Then we found that we're supposed to place this y now, and y is of 4 byte, but we don't have that much of bits here. I mean 4 byte means 32 bits, right? But we are left with 23 bits in this block. So what it will do, it will create another block, and as I said, whenever it is going to create block, it will create 4 byte because that is the biggest memory size here, I mean data type size here. Okay, so 4 byte will get created and y will be placed here. Okay, so this is how this will work. So now as you know how to deal with this bit fields, let's look at few points here that we will be covering in this video. So this is the first point that says that force alignment is possible using unnamed bit field of size 0. So what is this force alignment and unnamed bit field? So generally your bit field look like this. So we have this structure and node. I have given this node 1, and this A has 6 bit and 9, I mean this B will have 9 bits. So in total the size of this integer is 4 byte, so the size of this one would be 4 byte, and 9 plus 6, 15, so out of 32 we will be using only 15 bits. But what if you want that this first 6 bit should go in first block of the memory, I mean first 4 bytes, and this another 9 bits should come in another 4 bytes. So this is the way of doing that. If we will check this compiled, see it is 4 and 8. So this first one is 4 because as I said the integer size is 4 bytes. So inside 4, first 6 will be occupied, I mean 6 bits will be occupied, then 9 bits will be occupied in the same 4 byte. Okay, but in this case it is different. It will create 4 byte for this data type and use only 6 bits in that, and as we are saying that we are putting this unnamed bit field just to tell to the compiler that I want this 9 bit from another 4 bytes. So 4 plus 4, 8. Okay, so this is also possible in bit field. You can customize like this. Okay, so this was your first point, that force alignment is possible using unnamed bit field, and this is how you use that. So the second point says that taking pointers to bit field members are not allowed as they are not starting at the byte boundary. We cannot take the address of bit field member. This A is of bit field member. We are using this colon and 5, so it has become bit field member. We cannot take the address of this A and B, but we can take the address of C. So that's how what I'm trying to tell you here. C, this will work because C is not bit field member. Okay, And the reason is A and B are not necessarily starting at the byte boundary. And what is byte boundary? As we are taking this A and B, it might be coming, as I said, from half would be this C here, and this A and B, either A might be at this point and B will be at this point, and A is of 5 bit and B is of 5 bit. So 1 byte is 8 bits. We all know that. So if you are aware of this, that our RAM is addressable and we can address 1 byte inside the RAM. Okay, so 1 byte means total 8 bits. So minimum byte you can address is 1 byte. But this B or A, neither of these are 1 byte. So taking the address of that doesn't make any sense. So this was your second point. Let's comment this and let's go to the third point. Now this third point is assigning an out of range value to a bit field member is implementation defined. So as you can see here, you're having this A with 2 bits. So either you can set 0 or 1. So 2 bits means there is only 4 possibilities. Okay, 2 to the power 2, so means 4. So only 4 numbers can come in A, B and C, but if you are putting more than that, then it is a problem. And it is not a problem actually, it is implementation defined. So whatever the compiler you are using, the compiler vendor will tell you what will happen when you will do something like this. So in the specification, you will get all the details. Okay, so doing this is not good practice. And there is no need of doing this, because before going for any bit field decision, you should always confirm that this is not going to take more than 2 or something, whatever value you are choosing, but A is not going to take more than that. That's why you are putting that. So if you are confused, don't use bit field, because in future you may have to change your full code. So we are done with this third point. So third point was we cannot initialize more than what A can handle. Okay, so that was the third point. Let's comment out and go for the fourth point. Fourth point says that you cannot have static bit fields, because we are watching this video in C++ section, so we have to cover C++ style. So in that case, we can have static data members inside structure and classes in C++, but if this is a bit field data member, you cannot use static with that. So this was the fourth point. Now let's look at the fifth point, and that is most probably the last point. And the fifth point is you cannot have the array of bit fields. Okay, so these points are very easy to remember. I got it from somewhere in the internet, and I like to explain almost everything about the topic, so I have included these points here. Otherwise our video was completed long back. But these points are really very interesting when it comes to the interview questions or writing a good exam. Okay, so this fifth point is you cannot have this array. And yeah, if you will write some extra points in your exam, you will get a good marks, and that's a good thing. So fifth point is this much only, you cannot use it as array. Okay, so let's look at the summary of this. So the summary of this video is bit fields are from C language and they are not different in C++. So this is first point, which is not a very big point but still good to remember. And second point is it is used to reduce the size of the classes or structure if we can. If we can means if we are in situation like I gave you the example here of this date data structure. So we have that option, like you can reduce the size of your data member because it is not going to exceed some limit. But in case if you don't have, don't use bit fields. So third point is this feature is great in embedded system because there is a scarcity of memory. Yes, it is really very important when you go for embedded systems, and if you are planning to make your career in embedded system, you should be very good in all these things. When there is a topic about memory optimization and all that, you should be very good at that, because as an embedded developer you should be writing a very good code in terms of memory optimization and all. And structure padding, I don't know why did I write this. Oh yeah, maybe this topic is very much important in order to understand your bit field. So before you should understand this one, and as I said, I'll be giving you the link in the description field. You can go ahead and watch there. And the fifth point is only integral types like boolean character, signed character, unsigned character, and all these things are allowed to be bit fields. Okay, so we will go here, and as you can see here, I'm using unsigned integer. Okay, here you can use only integral types, and those types are this one. You cannot use float or double or something here. Okay, it need to be an integral type, and these are the types. So I think we are done now. Thanks for watching, and if you like the video, don't forget to hit the like button, and please comment how do you feel about the video, because it will help me a lot to understand my audience, what they like, what they don't like. And you can write comments, very big, very small, doesn't matter. You can just say thank you, or you can just say I didn't like this or something like that. It's okay. I'll try to improve there. Okay, so I'll see you in the next video. Bye bye. And yeah, make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. Bye bye. Hello friends, this is Rupesh and you're watching CPP Nerds video series on C++, and in this video we'll be learning this operator overloading in C++. So let's start this. So the comment says, in C++ it is possible to change the behavior of operators plus, minus, multiplication and all that as you want. But we can change the behavior for user-defined types only, like classes and structure. So what is this points about? We'll see in a moment, but let's try to understand the basic understanding of these operators. So here we can see that A is initialized with 10, B is initialized with 20, and A plus B is going into C, and we are printing C. So we all know that it will print 30, but how it is printing 30? Compiler knows very well that how to deal with this expression here, A plus B, because it is implicit type and compiler knows this very well. So if it is integer, float, character, your compiler will know how to add those data types. But let's suppose you have a requirement that you have to create user-defined data type. So let's create a user-defined data type. Let's suppose you have a requirement that you have 2D plane, and this is your x coordinates and these are your y coordinates, and there are a few points here and there. And you want to store those points, like this is P1 and this is P2, this is P3, okay? And this is 1, 2, 3 and all the way till infinity, and similarly here 1, 2 and 3, and these are integer numbers. So this is actually pointing here and this is here, so it's not a float or double, it is integer. So we will have either 1, 2, 3 or minus 1, 2, 3, so it goes in negative also. Okay, so this is your basic requirement, and you will fulfill this using either class or structure. Okay, so this is your minus x and this is your minus y side. Okay, so we all know how to deal with this in mathematical way, but let's go and create a class for this. So our class name can be a point, and we want to store only 2 points, so like integer x and integer y, and we need a constructor. So this is how it is going to look like. You have this x initialized with x and y initialized with y, and that's it. Your constructor is ready, but it should be in public section, so let's make it public. So there you go, you have x and y in your point, exactly how we discussed here. Now what we wanted is we wanted to add 2 points, so let's create some points here. So point P1 and initialize with 1 and 2, and another point P2 initialize with 3, 4, and these are 2 points, and you want to add this point and place into P3, P1 plus P2. Okay, and this is what the requirement is. You wanted to add P1 and P2 and place it inside P3 like this. But if you will compile this code is not going to work, because your P1 and P2 are not implicit data type. They are not integer, float and all. They are objects. So compiler doesn't know how to deal with this addition here. Okay, so in order to show you that, let's compile this. it is showing that I cannot add here. See, it is giving you the error. So in order to achieve these kind of things, we use operator overloading. Now concentrate here. I will be writing an operator overloading syntax. So the syntax is your return type first, that what type you want as return. So P1 plus P2 you want point as return type, okay, because P1 and P2 both are of point type. Okay, so first we'll write return type, and there is this operator. This is the keyword to write operator overloading, and what operator you want to overload, plus, and then this round bracket and this curly bracket, and then you will write this point ref RHS. So this should be the syntax of your function. First return type, then keyword operator, and then what operator you are overloading, and then constant point reference, and this is your variable name. RHS means right hand side object will come here. So actually whenever you are performing this operation, this function will be called. Okay, and how it will be called? P1 will call this function and pass P2. Yes, it is going to work like this. Your compiler will replace this expression something like this. So let me just give you a hint here. P3 equal to P1 dot operator. Which operator? Plus. And then P2 will be passed as parameter here. Okay, so you're calling this function on P1 and passing P2. Okay, so something like this happens instead of this one. I'm giving you just a small hint how this will be happening. This is not the actual syntax. Okay, so let me just remove this, and we were talking about this one. So P1 is calling this function and P2 is going as a parameter here. Okay, so remember this part, and we'll do the addition here like P and P dot X is going to be X plus RHS dot X, and P dot Y is going to be Y plus RHS dot Y, and we'll return this P. So this is the syntax of adding P1 and P2. So if P1 is calling this function, P1 is internally accessible here. So this first X is of this P1, and this second X is from this P2, which is now RHS. Okay, so we are adding X of P1 with X of P2, and similarly for Y, and storing that inside another object of similar type and returning that object. That's why we kept this as return type, and that is coming here. So let's compile this code this time, and it should compile. See, build success. In that case there is no problem. It is showing that unused variable. So if you want to check whether it really worked, let's create another function, a print function, which will print the values. So cout x endl, and have this one space here, x y, and let's call that function on p3 dot print. So let's run this. See, our code is adding 1 with 3, which is resulting as 4, and 2 with 4 which is resulting as 6. So we have achieved adding 2 objects using operator overloading technique here. So not only this plus, we can overload minus operator also. So if there is some another P4 is equal to P3 minus P1, then this should work, right? So if you will compile this, and it will tell you that there is no minus operator overloaded. I mean, it is saying that I don't know how to deal with this line. So let's go ahead and do that as well. So I'll just simply copy and paste this one here and change this minus, and everything will be similar, minus and minus. That's it. So this P3 will be calling this operator function, and P3 will be internally accessible. So X is of P3, and this RHS.X is this P1. So if you will print P4 now dot print, then in that case you should get the actual value. So let's run that. So P4 is printing 3 and 4. So let's check that. So P3 after this one is this one. So 4 minus 1 is giving you 3 and 6 minus 2 giving you 4. So this is working. This is how we overload the operators in C++. Very easy, right? But wait a minute. Are you really supposed to do operator overloading in your classes in order to achieve two objects addition? No, you are not. Actually, you can write something like this. Point add. Yeah, you can have one add function const point ref p, and similarly you can do this. Okay, so let me just copy and paste here v, and this should be RHS, otherwise it will be conflict. Okay, so this is your add function. Instead of adding it using operator, you can add it using something else, which is a function. So p5 is equal to p1 dot add p2. So this function will add p1 and p2 and return the value. Let's check that. p5 dot print and run this. So this is your p5 output. So this one is equal to this one, that's why this one is equal to this one. Okay, so you can achieve these addition and subtraction and multiplication, division using functions. But let's suppose you have some expression, something like this. So first you need to implement this one. So you have to write divide function and then pass add function with this one, and then minus function with this one, then multiplication, then addition. So you will be having so much of function name here, and it will not look intuitive. Okay, it won't look like you are doing some mathematical operation. So in order to achieve the intuitive way of solving any expression, we overload the operators. Let me give you the example here. Just to remove this one and have this y dot add of x and p dot add of w, and these two things are the parameter for another one, which is going to be, let's say, the multiplication. Okay, so this one is going to be like dot multi, or just make it mul, and pass this one. So as you can see here, it is really confusing what you are doing here, and we are doing exactly the same thing. What is this expression here? So we are adding y with x, and that whole thing is multiplied by p plus w. Okay, so as you can see here, it is very tedious to write some expression in function format, and it is really very hard to find the error inside this. So it is always a good practice to implement operator overloading concept and achieve these expressions, addition, multiplication, subtraction, and all that. So this was the introduction part of your operator overloading. Wait a minute, we are not done here. Don't go. We are left with few points here. So the point is, if we use them means operator overloading, our program becomes more intuitive. You saw that, right? And there is another point, that there are few operators we can't overload, and these are the operators. Like this is scope resolution operator, this is ternary operator, this is dot operator or member access operator. Oh, there is one operator missing here, and that is f dot type id, and this one is dot pointer. So these operators are not allowed to be overloaded, and the reason is the creator of C++ didn't find any use of overloading these operators. So that is the only reason we are not able to overload these operators, because he didn't allow us to overload these operators. So this was about operator overloading, and the main important point is we overload the operator just to make our program look more intuitive. Okay, it's not like we cannot live without overloading the operators. It's about using them so that your program will look very neat and clean, and it will give you clear understanding of the operation you are performing on. So this was about overloading binary plus and minus operator. There are so many operators, and there are different syntax to overload them. Like if you will overload pre-increment operator or post-increment or pre-decrement or post-decrement, there are different syntax. So we will be covering all those operators in coming videos. If you like this video, don't forget to hit the like button, dude. And make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye. Hello guys, this is Rupesh and you're watching C++ video series on C++, and this topic is about this unary operator overloading in C++. So before watching this video, if you don't know what is operator overloading, I would strongly recommend please go ahead and watch my previous video which is about introduction of the operator overloading, and you will be getting this link somewhere here I guess, and if you're not, then you will go to the description field of this video, you will get it. And there I have explained why you should use operator overloading and simple example of binary operator overloading. So binary means A plus B. Unary means plus A or plus B or maybe this. Okay. So the difference is in binary operators, you have two operands. This is one operand, this is another operand. But in unary, you will have only one operands. And in that video, I have explained that how this basic thing works, like adding one object with another and assigning it into something else, and how the calling happens. So if you don't know all these things, please go ahead and watch that one. It will be very beneficial for you, and then you come back and watch this one. So I hope you have watched that. So let's start this. So the point says that operator overloading works with classes and the structures. Means user-defined data types. You cannot change the behavior of this positive and this negative and all that if the data type is integer, float, character, because these are implicit data types and you cannot change the meaning for these kind of data types. Okay? But if it is object, then you can change the behavior of this operator here. That we'll see in a moment. So let's cover this theory part first. And the unary operator overloading needs only one operand, and that we have discussed here. Correct? So let's go ahead and check how to overload the unary operators. And yeah, before going there, let's have some requirement. So the requirement is you have 2D plane. This example is taken from the previous video. So if you have watched it, you will be understanding it better. And you have some points. So like P1, P2 and P3. Okay, so these are the coordinates 1, 1 and then 2, 2. So this is user defined data type. You will not get this data type in the compiler like integer, float and character. So we have to create this data type. So let's go ahead and do that. So first I'll create one class and let's create a point and hit this semicolon. And we need 2 points, so integer x and integer y, and need a constructor. So let's do this, and we will make this constructor parameterized as well as default one. So integer y is equal to 0, and let's initialize this x with x comma y with y, and we are done with this constructor and it should be in public. So let's do that, and we will be needing one print function which will print whatever is there with this points value. So let's do this, cout x space y, and done. So this printing is done, and we can go ahead and create this point p1 and initialize with 1 comma 2, and let's create this p2 and don't do anything with that. So this code is not doing anything, just creating P1 with value 1 and 2. So here we will have 1 and 2, and P2 is not initialized with anything. So it's X and Y will have 0, 0 value. Okay, so let's check that. P1 dot print and P2 dot print. Let's run that. See, we got this X1 and Y2, 0 and 0. So this is correct. So let's check one more thing. What if you want to do one assignment with negative value? Let's do that. Point P3 is equal to P1 but with minus here. So you want to assign whatever is there with P1 but with the minus value. Okay, and if you compile this, it won't work. see, it is telling that I don't know what is this minus here. So let's give the definition and understanding for this minus. So the syntax goes like this. As you can see, we have this point data type for P3 and P1 is also point data type. So we'll be returning this point data type. So we will write this point and then this keyword operator. And what operator you are overloading? Minus. And then this round and curly bracket. So this is the function you will be writing in order to overload this unary minus operator. And you can have this space and you can just delete that space. It doesn't matter, okay? And inside this function, we will return a temporary object with minus x comma minus y, okay? And we are done. So if you will compile this, there won't be any issue here. It is telling that P3 is not used. That is okay. We can see that. So we can just simply print P3 now. Let me just do that. P3.print. And let's run this again. See, you got this P3. This line number 3 is this P3 value and minus 1 and minus 2. So our code is working. So now understand how it is working. So when you are calling this one, you are writing this one, it will call this function and this P1 is calling this function. That's why this x is of this P1x and y is of this P1's y. And what we're doing is we're just creating a temporary object here and passing that value to the constructor. So the constructor is taking that minus and minus value and ultimately we are having one temporary object here and we are returning the temporary object and that is coming here. Okay, and if you have return value optimization enabled, this temporary object will not be created. It will create on the memory of this P3 itself. But if you don't know what is return value optimization, don't worry about that. You will get it when the time will come. So this is about overloading this unary minus operator. So there are plus, minus, and then this plus plus, which is this post increment or pre-increment operator, and then similarly minus minus operator. So these all operators are unary operator. We'll see these unary operators, this plus plus and minus minus in coming videos because they need little bit of spatial handling. They are not this simple. Actually they are simple, but the point is if you will have plus plus in the right hand side of this operand, which is a, in that case this is post increment and this has the difference behavior if it has before this a. Okay, so in order to achieve this behavior we have to do something else. So I don't wanted to club that into this video. That's why I have created that another video. So if you want to know how to overload this plus plus post and minus, this pre-increment and post increment, and similarly for minus minus, then go ahead and watch that video. You might be getting the link here somewhere. And if you are not getting it, you'll get it in the description field. So we'll keep this video till this much. And if you have any doubt, please comment. I'll be very happy to explain you that. Okay. So thanks for watching. Bye-bye. Hello friends, this is Rupesh and you're watching CPP Nuts video series on C++ and this topic is about operator overloading, but this operator which is called array subscript operator. So if you're new to the operator overloading, please go ahead and watch my previous videos which is about overloading this binary operators like a plus b and unary operators like plus a and minus a and all. So if you know what is operator overloading, it will be very helpful to understand this straight away. So let's go for the points here. So the first point is array subscript operator can be used to check out of bound cases. Yes, because we can explicitly check whether we are going to access array which doesn't exist. If you are accessing array of 0, then whether this exists or not, like your array has one element or not, or maybe you are accessing array of 100, but maybe your array is not that big, so this value is not correct value for that, and you can give the error at this time. Otherwise it is not possible in our C and C++ programming. And the second thing is array subscript operator cannot be friend function and others too. Others too means this array operator, this round bracket, and this assignment operator. We cannot overload these operators using friend function. You can create any function outside your class and declare that function as friend in your class and start using that, but not these overloaded function, means this one, this one, this one, and this one. So this collectively 4 operators cannot be overloaded using friends. It means you have to create these operator functions inside your classes. It means it should be a non-static member functions. Okay, so it should be a non-static member function, and it should be your class member function, which is equal. I mean, you say either way, it doesn't matter. So these are the 2 points, and let's have the requirement. So if you know what is requirement, it will be cool for you. So we have 2D plane X and Y, and we have these points here and there. So our requirement is you want to store these points in some data structure. So you can create a class called point, and you may have P1, and inside that 1 and 2 will be your X, and this will be your Y. So you can have so many points like that, okay? And this is what we want. I mean, to get this X and Y, we will overload this subscript operator. So let's go ahead and see how we'll do that. So we will have one class named point, and there you can have one array which will be like this. So you have 2 elements in the array. So 0th location will be X and first location will be Y. So let me just give you in the comment. So in this array, 0 will be pointing at X and Y will be pointing at, 1 will be pointing at Y. So that's correct. Now create this constructor and initialize integer X, integer Y. And then we can initialize it like ARR. No, not like this. We will use it like ARR of 0 will be your X and ARR of 1 will be your Y. Okay, so constructor is like this. We will need one print function, so let's create that quickly. Y ARR of 1 and ENDL. Let's quickly create some points. P1, good to go. And if we will not have anything here, it should be 0 and 0. So let's initialize them with 3, 4, and if we will print P1 dot print, let's check the output here. So our output is X is 3 and Y is 4. It's perfect. So till now we have not used any operator overloading. Let's suppose you want to do something like this, like P1's 0 position you want to initialize maybe 7, and P1's first position and you want to initialize something else, maybe 4, which is already 4, so let's make it 8. Okay, so if you will compile this is not going to work. It will tell you that point does not provide subscript operator, so we have to provide it. So let's go ahead and do that. So the syntax would be like this: integer ref operator, subscript operator, round bracket, and you will get one integer position inside this. So this is the syntax of your subscript operator overloading. You will return integer reference. The point is you will be returning the reference value here, so that someone can change that using assigning it with some another value. So if you're not returning the reference, you will be returning some temporary object or value, and if you are updating that, your original object will not update. That's the only reason we have to return this reference here. Okay, so you will understand once I will write the code. If position is equal to 0, we will return array of 0, and else if position is equal to 1, in that case we will return array of 1. In another else case, what we will do, we'll print something like out of bound case. So from here we can just simply exit the code, because we cannot process this code anymore. Okay, so if this is the situation, like if it is not 0 and not 1, in that case what we'll do, we'll just print one message and we'll exit from this program. So let's quickly compile this again and build successful, and the output is again okay. Yeah, we didn't print that p1. Now p1 dot print after change, it should be different. See, now it is 7 and 8. Okay, so this is quite logical. But let's suppose after this you are trying to do something like this. You're trying to access the second one and want to initialize with 10 or something. So let's see what it will do. We will compile it. See, it executed the first one, second one, and now it is telling that out of bound case, and we will exit from that program. So if you are doing anything further after this, like suppose printing this p1, that won't work. Okay, because we are exiting from here only. Let's compile that. See, this one is not printed. Okay, so this was about overloading the subscript operator. So thanks for watching, and if you have any doubts, please comment. I'll be very happy to help you in that case. And I'll see you in the next videos. Bye bye.
Hello friends, this is Rupesh and watching CP Minute video series on C++, and today's topic is this stream extraction and stream insertion operator overloading in C++. And yes, this is extraction and this is insertion, and we use them in conjunction with this object called Cout, and we use it like this, cpp nuts. So this is the string and we're extracting this string, and who is helping us to do that? This Cout. This Cout is nothing but the console output, and this is just an object. Don't confuse with this. This is nothing but just the object of OStream. So this is a class, and we have seen another thing like cin, and this is, let's call some x, and this x is nothing but some integer x, and we can take the value inside this. So what is this cin? This is also one object, and this is iStream object, not ice cream. This is iStream, and these two classes are included in IOStream. That's why instead of taking OStream and iStream separately, we take only one header file, which is called IOStream. So I for input, O for output. So one more time, this Cout is an object of OStream, and this cin is the object of iStream classes. They are classes. So don't confuse with this. And we are going to overload these operators, not Cout and cin, because I have seen people talking about like overloading cin and Cout operators, or just simply they will say that okay, overloading Cout and cin, but we are not overloading Cout and cin, we are overloading these operators. So let's talk about these points now. When we need overloading this and this, when there is a scenario that we want to output like Cout and then this extraction operator, then user defined type. What I mean to say is, let's suppose you have some class test, okay, and you want to create an object of that, and let's call it T, and you want to output this object using Cout. This is not capital C, don't get me wrong. Okay, so as you can see that this is something what we don't do daily. We will be using here some variable which is of implicit type like integer, character, pointer and all. Okay, but here we are using this object. So whenever we have something like this kind of situation, we will go for overloading this operator. Okay, and similarly for cin. So right hand side we should have a user defined data type. So let's quickly write the code and understand how we will do that. And yes, there was this another point I forgot to discuss there. It says that it can't be class member function. I mean, these operators cannot be overloaded as a member function of your class, because this Cout is an object of OStream class, not your class. So if you don't understand this, we'll come to this later. You have to make it a friend function of your class. So define it globally. You will declare it a friend
of your class, okay, so that it can access the private data members of your class. So let's quickly write that. So we have this class ready for use. So test t, we wanted this cin. First we'll take the input and cout t. This is what we want to achieve here. But if you will compile this, let's do that, you'll get so many errors that I don't know what is this, I don't know what is this. So let's give the definition of these operators. First we will define them globally. So let's go for cin first. So as I said, cin is the object of iStream. We will be returning iStream reference operator. This is the operator we are overloading, and we have to take two parameters, iStream ref input. We can call this input, whatever it is. I'll explain what is this, but let me write this first. And then this test ref obj. And what we'll be doing here is just take the input obj.x and return input. So this is going to be the syntax for your stream insertion operator, which will insert the stream in our system from console. So let's write another syntax for ostream. So this is going to return ostream ref, again operator, and this time this operator. And here we'll take ostream ref, and here we'll call this output, and then again test ref obj. And in this output obj.x, let's have this endl and return this output. So this is going to be the syntax for your output operator, stream extraction operator overloading. So these are the functions, and let me give this friend here. So let's get a little lazy and just copy and paste these. So what we are doing is we are creating a class. So this is your class. You want to output or input the object of this particular class. So what you did, you created two global operator overloading functions and you make them as friend. Why you are making these functions as friend? Because they want to access this x, and this x is a private data member of your class. If you don't want to access any private data member of your class, you don't have to make them friend function in your class, okay? Because they're not going to access private data member. So let's run this. So here we'll compile this. I have this code ready. Yeah, it compiled successfully. Now let's execute this. So this cin is asking you the value because this cin is calling this operator here. So input, you are asking the value here. I'll explain what is this, but let's just quickly see that our program is running. See, you give 25, you are getting this 25 using this cout here. So this program is working fine. Now let's try to understand why it is working this way. So first of all, why we cannot make this function as a member function of your class? The reason is this cin and cout are not the object of our class. They are object of different class, and we are overloading these operators on those particular classes. Like cin is the object of iStream, so this operator will be overloaded for that particular class. And similarly for this operator, it is going to be overloaded for ostream class, not for your class. So what we did, we overloaded these operators for their classes only. See, we are passing the references of their own type. Okay, see, even this one. And there we are passing our own object as the second parameter, this one. So this is how the syntax goes. These classes, this C and Cout are the object and they are not our classes object. We cannot create these functions member of our class. So let's try to understand how this calling is working. So when you're writing cin and this stream insertion operator and t, it is something like this. So when you give something like this to the compiler is changing it into something like this, not the actual thing, but I'm giving you just the example here. So this is your function, and compiler will call that function like this. So this line will be replaced, and similarly this line will be replaced like this, t. Okay, that's why we ended up calling this function and this function. So this much is clear now. And why we are taking them as a reference, because we don't want to create copy of these objects. We want to use these objects as it is. No need of copying them, because it will create temporary objects and we don't want that. So we are taking them as a reference here, 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 and here. So this part is done. Now what we are doing is, see, your cin has become input. So input stream insertion operator and object.x. Ultimately you are writing something like cin and then this operator and object.x. Exactly. This is how you write when you take any input, right? And after taking that, after taking the input from the user and inserting it into this x, we are returning this particular input by reference, and similarly for this output. So we'll talk about this later. Now why we are returning this as a reference? The reason is, here you might not only use it like this, you might use it like this also, like cin and then this t and then another, let's call it t1, or another one with some x, and this x is maybe integer. So they all can be different type. It doesn't really matter, right? So your first call, this is going to be your first call, and then it will call this function. We did our job. We took the input from the user and inserted that input into this x. We are coming back using the same reference. See, we are not making any copy after copying this input here. So what we took, we are just returning it back. So as we are returning, this whole thing will be replaced with cin. Okay, and then this cin and this operator, we will again call this particular function, but we'll pass this t1 this time here. Okay, and we'll do the same thing here. Then instead of this, we will have cin again, because we are returning from here, and then using this operator and using this cin, we will pass this x, but not in this function, because this x is, I said, integer. So this iStream class, this is IOStream. So iStream class is there. It already have the overloaded function for integer values manipulation or working. Okay, so we don't have to do anything for this. We only have to take care of these type, because this t is our user defined data types object. This is why we return by reference. We don't want to make the copy of this cin again and again, because it is of no use. And similarly for this. So I think we are clear here why we use these operator overloading, because we want to use this cin and cout with our own created objects, own types. Okay, this t is not integer or something. And why we cannot overload these operators in our own class, because we are overloading these operators on cin and cout, and they are not our object. If you remember, if you have seen those videos of mine, there is this class called point, and this is the object p1, and let's suppose, okay, leave it, it doesn't have anything. There are three objects, p1, p2 and p3, and what you want to do is, you just want to copy p2 plus p3 into this p1. So what you're doing here is, you're adding two objects. So that time what we did, we created this operator overloading as a member function of your class, and this particular object was calling that function, and we were passing this as the parameter to that function, and we were returning type point. And here we cannot do that, because this cin and cout doesn't belong to our class. So that's why we have overloaded them globally. I think we are so clear, and if you have any doubt, please let me know. And if I missed something, please tell me that, so that I can create another video, or I can highlight that comment so that viewers can get the most benefit of this video. Thanks for watching, and don't forget to hit the like button And make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. Bye bye. Hello friends, this is Rupesh and you're watching CPP Nuts video series on C++, and today's topic is assignment operator overloading in C++. And in this video we'll be covering like why you should overload this assignment operator even though it is already given by the compiler, and how you should overload that operator. So let's start with the point now. So the 0th point is when you should write your own assignment operator in C++. So the answer for that is when you have pointers in your class. What I mean to say is when you are having data members as pointer in your class, that time you will go for assignment operator overloading. Okay? If there is no pointer data member in your class, there is no need of overloading this operator. And assignment operator means this. Now the second point is this comes under binary operator overloading. Binary means you'll be having two operands, here equal to here. So this is your right hand side and this is your left hand side. So you should have two operands in order to perform this overloading. So this was the second point. Now the third point is when we need deep copy. So this is another topic which is called shallow copy and deep copy difference. So if you don't know what is deep copy, go ahead and watch my video about deep copy and shallow copy in C++. So when you need deep copy, then only you will go for assignment operator overloading. And deep copy happens when you have pointers in your class. Otherwise we don't need deep copy. So the last point is we should always create our own copy constructor when we are overloading assignment operator and vice versa. So if you are going for assignment operator overloading, you should always write your copy constructor. Or if you are in need to write copy constructor, you should always overload the assignment operator. You should not rely on the compiler's given assignment operator if you are explicitly giving this copy constructor, because you will be giving copy constructor for only one reason. You have pointer data member in your class. So let's start the coding to understand this better. And these 2 points are when you will create the function, overloading the assignment operator, that time you have to keep these 2 points in your mind, that self-assignment is a very dangerous thing, and we'll discuss that when we'll code it. And the second point is assignment operator must be overloaded by non-static member function only. Okay, so you cannot create a global function and make that function a friend of your class and it will work. No, it is not going to work. So let's quickly write the code. So let's create this test t1 and initialize it with some value. Let's say 10. Let's create another test 2 and don't initialize it with anything. So it will automatically be initialized with 0. Now this is what we want. t2 is equal to t1. And let's print t1 dot. No, wait a minute, don't print. Just set another value for this t1's x. So we'll set 20 here. And now we can print t1 and t2. But before going for the compilation, let's give some message like output. So this is going to be the output for our program. Now let's compile this. Output is 20 and 20. Why 20 and 20? What we did here, we initialized t1 which was 10 into t2 and then we changed t1 into 20. But t2 is also changed. See, this is t2's output. Here t2 is also changed. Why is it like this? Are you getting my point? We have this t1 initialized with 10. We created t2. Later we initialized this t2 with t1. So t1 was holding 10 at that time. And after initializing 10 into t2, we changed this t1 and printing t1 and t2, both are printing 20. So this is the problem. So let's look at the problem here. The problem is you have this t1. So let's create the memory layout for t1. Inside this t1 full, we have this x. Okay, and this is pointer x. Okay, there is another t2 and similarly we have pointer x for this. Okay, So this is your T1 and this is T2. Now what we did, we'll go by line. So here you created T1 and initialized with 10. So created means this constructor was called and you created the memory for this dynamically. So let's assume there is some heap here. Let's call it heap, and 4 bytes were given to you. So there are total 4 bytes, and what you did, you initialized 10 on that. So this is how it worked, and let's suppose the initial address of this was 0 cross 1 and 1. So this is 0 cross 1 and 1. So till this we are clear. Now you created T2, but you didn't pass anything, so value will become 0 because you're not passing anything. So this time value will be 0, and this time you are taking another 4 bytes, and let's suppose that address is 0 cross 1 and 2. No, it should not be 1 and 2. Let's suppose it is 2 and 2, and you initialize that there, and the value is 0. So let's initialize 0 here. So till this we are clear. Now you are initializing T1 into T2. So let's see what is happening. As this is compiler generated assignment operator, remember I told you if you are not giving any assignment operator overloading, compiler will give it by itself. So what compiler will think, compiler will do a shallow copy. Compiler will not go for deep copy. So shallow copy means whatever this X is holding, it will initialize to this X. Compiler doesn't know that it is holding address, so we have to create another address here and initialize the value of that, not the address. So shallow copy is like this. Whatever is there, you just assign here. So instead of this 2, 2, let's make it 1 and 1. We will have 1 and 1 here. It means the same address has come here. Now, before you was pointing to this location, now you are not pointing to this location. You are pointing to this location. And this one is also pointing to this location. So both objects X are pointing to this location only. Okay? After this assignment. Now what you did? After assigning, you changed T1. So if you are going to change T1 and going to make this 20, and after changing that, if you will print T1 and T2, both will obviously print 20 because both are pointing at this location only. Okay, so this is the problem. So there are two problems in this code. First is you lost this memory. Okay, you don't have any access to this memory now because you have replaced that memory with another memory. Second problem is when we will go for destructor, that case T1 will destruct first and then T2. Oh, wait a minute. If you will follow the stack, T2 will get destructed first, then T1, because T2 was created later. So this happens on the stack. If we believe, then it is like T1 was created first and then T2 was created. So if you are freeing this memory, then T2 will go out first, then T1 will go out. Okay, so T2's destructor will call and T2's destructor will end up freeing this memory 0 cross 1 1. So this memory is free now. Okay, assume that. And after T2, T1 is also going to get destroyed and T1 will end up again freeing that memory. And this is a problem. You're going to free that memory 2 times. So in order to overcome all these problems, we go for operator overloading. And remember this problem comes when we have pointers in our class. I'm telling you again and again so that you can remember this. So let's go ahead and implement our assignment operator. Now you know the problem, what problem assignment operator will solve. So this is the syntax for that. We will return objects reference, and obviously we need one operator keyword and equal to, and here we will take right hand side member as const test ref RHS. So let me write the syntax first, then we'll understand this. So this is equal to address of RHS. If this is not equal to RHS, then in that case we will initialize x is equal to RHS.x with dereferencing. Okay, otherwise we'll just return pointer this. So you are done. Now if you will assign T2 with T1, this function will be called. So let's see how this will call.
here this particular line will be replaced with something like this. You have this t2 dot operator is equal to, and you will pass this t1 here. Okay, so something like this will be replaced with t2 is equal to t1. Okay, your compiler will do this. Not exactly this, but something like this. I'm just giving you the hint to understand this concept. So this portion is your function calling portion, and this is the object. So you're calling this particular function on this object and passing t1 as a parameter. So we'll come here, we are taking this t1 as a constant reference. Why constant? Because you don't want to change this t1 accidentally inside this program, function. So we are taking it as a constant, and we are taking it as a constant because we can. So compiler will have some optimization for constant variables. So it is little faster in some sense. And then we are taking it as a reference. Why reference? Because we don't want to make the copy of it, because that is unnecessary copy. So that's why we're taking as a constant and the reference. So this T1 has become RHS now. And this is this important thing I told you. We have to check the self-assignment because it is dangerous. Why it is dangerous? We can see that if there is T1 is equal to T1. Let's suppose you ended up doing this. It is perfectly fine. You are initializing T1 into T1. But let's suppose if you are not writing this one, you are not checking this, you will end up assigning all those things again and again, which doesn't has any meaning. Let's suppose you are not having any integer pointer x. Let's suppose you are having a very big array of pointers or very big data. And what you did, you ended up assigning that data again to itself, which doesn't make any sense. So that's why we should always check the self-assignment case. And self-assignment, how would you check that? This keyword, this pointer will be having the address of T2 because we are calling on this T2 object. Okay, so this pointer is holding the address of T2. Now you are comparing with RHS address. So you got this T1 as parameter. Let's suppose this is not T1, this is T2. Then address of RHS will be equal to address of T2. So if both are not equal, then only you will assign it. And if they are equal, it means they are same object. Okay? And if they are not, then we are simply just assigning one value to another value. And this star x shows that this x is belonging to this T2. Okay? And we are dereferencing that RHS.x, which is this T1's x, and assigning it into T2's x. And this is one important point. Why we are returning this pointer dereferencing? And the reason is there is this syntax T1 is equal to T2 is equal to T3. Okay? Don't miss this part. So what we are doing is first we will initialize T2 inside T1 and then we will initialize T3 into T1. So if you are writing something like this, then this is two-step process. You are initializing T2 and then for the same thing is with T3. Okay, so this one line is this two-step. And if you're not sure, you just take integer x and let's make y and z. And if you're doing it like x is equal to y is equal to z and they all are integer values, it is going to be like x is equal to y and then x is equal to z. So this is the traditional behavior of this assignment operator. That's why in order to achieve the same traditional behavior what is coming from C language, we are returning it by reference. So let's see what is happening here. If not here, here. So first this will execute. We know that because this is round bracket and the precedence is higher for this. So T2 will be assigned into T1. That is okay. This code is fine. And we are returning. Don't forget this pointer is pointing to T1 now. Okay. So T1's reference. It means after this full expression, we will have T1 here. Okay. Because we are returning it by reference. And by reference means T1 itself. We are not making any copy. And then T1 is initialized with T3. Okay.
So this is how it will work. So we have ended up achieving this behavior, which is a traditional behavior, which is maybe called chain assignment or something. I'm not sure about that, but there is something. I mean, we call this behavior something. I'm not sure about that. But in order to achieve this only, we return it by reference. So you have to remember few things. You have to take the argument as constant reference, and you have to check the self assignment, and you have to return it by reference. Okay, so these 4 things you need to remember for this. And wait a minute, we are not done yet. Don't you think you are doing a specific thing here? You are assigning T2 with T1, and both are of similar type. Both are object of test class. What if there is another class? Let's call it base or something. I'm not good with the naming things. Just I would like to clear your concept. That is more than enough. So base, let's suppose there is some object B. And what you are doing is T1 is equal to B. Can you do this? Yes, we can do this. And let's look at that. So till this it is clear, let's create another base. Let's create base, and here let's have this integer simple x, not pointer x, and base, some constructor for this one, integer x is equal to 0, and then we will initialize x with x, and we are done. I don't think we need to do anything else in this. Yeah, we have to keep it public, otherwise it will start shouting. Why color is not different here? Am I missing something? Oh yes, we need to give this as class. Yes, that's why color codings are important, right? So our base class is ready, and what we want to achieve is just get rid of all these things. I will make it a little simpler. So base B, and we want to initialize not B with T, T1 with B. Okay, and we can pass this as 20. So if you will compile this code, it is not going to work. I'm not going to show you that. So let's quickly write how it should be. So I will make this test class as friend. Yeah. So this is one part of the operator overloading. We will do that with another one. So operator is equal to, this time we will take constant base ref RHS, and we are going to do almost the same thing. So let me just get lazy here. Syntax is messed up. Yeah, and we are not having this. Actually we have. And then RHS, we don't need to dereference RHS.x because that x is not pointer. Okay, so I think we are pretty much done, and let's print this T1 after this. Let me make it a little smaller so that we can see full thing what is happening. Yeah, let me compile this. Okay, something got wrong here. What is this? Oh yes, we are going to compare two distinct objects, which really doesn't make any sense. Yeah, I should have kept that in my mind, but I forgot that. Let's compile it again. We got it 20 now. See, your T1 was 10. Okay, so let's just print this T1 first. Print, compile. See, before your T1 was 10, after printing we created B with 20. You initialize that B with
B to T1, and now you're printing and you're getting 20. So this is working. So as you can see that you don't have to initialize your data types only. You don't have to only use this assignment operator overloading when you are initializing two different two similar objects. You can go for with two different data types also. Okay. So here what is happening? T1 is calling this particular function and passing b as a parameter. You remember before? I can show you that. Yes. We were initializing T2 with T1. So T2 was calling this function. Okay. So in this case, T1 is calling because T1 is at left hand side. And yes, it is true. Whichever is at left hand side, that is only calling the function. And right hand side is always passed as a parameter. Don't forget that. I literally missed that point before, but that is important point. And we can see here it is coming and we have achieved what we wanted. And let me show you one more thing. I told you that chain assignment and all. Let's have a look at that also. I know it is going to be a little big video, but it's okay. As far as you're enjoying and understanding the concept, it should be fine. If you're getting bored, go and watch something else because you're not fit for the programming. If you want to really become a good programmer, you should know your tool very well. So I was going to demonstrate this reference. So let's have it test T2 and T3. Okay. Now what we want is we want T2 is equal to T3 is equal to T1. But these two inside the bracket. So you know how it will work. Okay. Let me just give some space. And we can print all. So T1 dot print and T2 dot T3 dot print. And let's see what is the output here. See, it is 10, 10 and 0. Why it is 10, 10 and 0? Because T3 will be initialized into T2, which is 0 only because T3 doesn't have anything and T2 doesn't have anything. So both are 0, 0. So T3 will be initialized. It means T3 will initialize 0 inside this. And we are returning it by reference, means this T2 is returned by reference. So now, after assigning this expression will look something like this. Okay, something like this. So now T1 will initialize into T2. So T1 is holding 10. So we will end up copying T1 into T2. So that's why T1 and T2 both are 10, but T3 is 0. So this is perfect behavior. Let's change this. What I mean to say is, let's not return it by reference. And if we are not returning it by reference, I don't think we need to return this as well. Let's comment this. And let's make this one as void. And let's compile this. Okay, we got this error that this expression is not assignable, because once this expression will execute, there is nothing to execute for this one. That's why this expression has become not assignable, because we are not returning anything. So let's return test just simply by a value. Okay, so let's compile this again. Okay, this time another error. It is saying that malloc error pointer being freed was not allocated. Okay, I got the problem. If you also got the problem, let me know. I would love to see that. Okay, but anyways, I'll explain what is the problem here. The problem is, let me zoom in a little bit so that we can understand a little better. So we'll see why it is giving error. So as I said that, let's rewrite it here. T2 is equal to T3 is equal to T1. Okay, so this will execute this function, and T3 was passed here, T3, and we did everything, and lastly we are returning this pointer's dereference, means T2 by value. Okay, because this is by value, we are not returning by reference, and this is T2 address, and dereferencing means you're dereferencing T2 itself by this. Okay, so it means you're simply returning, instead of this I'll just tell you that it is something like this. You are returning T2 itself because you are dereferencing that address, okay, and returning by value. So if you are returning by value, some temporary object is coming here. Let's assume some temp is equal to T1, okay. So something like this is happening. Now what you did, you initialized this T1 into temp. That happened. Let's assume that happened. And after that, once this whole line is completed and the control is transferred to this line, this temporary object will go away, because temporary object's scope is till that line only. Okay? So this temporary object ended up freeing this pointer which was associated with T2 here. So actually T2's pointer is already free, but when you will hit this, and it will again try to free that, and maybe it is giving the error for that. Not maybe, I'm 95% sure about that. And you might be thinking why it is freeing T2. So let's check that. This is something like this. It is returning T2 by value, and one object is being created and simultaneously assigned. So that is not the case of operator overloading. That is the case of copy constructor, and we have not overloaded that copy constructor. That's why we are having that problem. So I told you there are two cases. First is, let's suppose there is some base B and you are initializing it with B1. So this B is getting created and simultaneously being initialized. So this is a copy constructor case. And second is, when this assignment operator will get created, you are doing it like this. You created B, this is B, and you are initializing after creating that with B1. Okay, this is B1. So this is assignment operator calling. But in our case, when you are returning T2 by value and one temporary object is being created and simultaneously being assigned, so that is the case of copy constructor. That's why copy constructor will kick in, and we have not not provided copy constructor. So it again ended up doing the shallow copy. And what I mean to say is it copied the address, not the value. So in order to solve this problem, let's go ahead and create copy constructor. I don't know where this video is going, but still it's okay. So let's create one copy constructor. Copy constructor doesn't have any return value, and it will take as constant test ref RHS. And here we don't have to verify that whether we are initializing with ourselves, because this will be called when you will create a new object and simultaneously initialize it. So you can simply do one thing. This new integer RHS.x, and this should be pointer. So what it did, you created a memory. Oh, wait a minute, this is not going to be this. That's it. So we have initialized our x with this one. So I think you might be knowing this copy constructor. I don't have to explain this. And let's compile this again and see if it is giving any problems. No, see, it is not giving any error now. And let me just remove this. Yes, I was correct. And we can expect some error. Not some error, that error what we was getting before. Okay, so I was correct. Actually, this is quite logical, that's why I was correct. Okay, so I think you got a very good picture of everything here. So let's summarize this video, and I think you would have enjoyed this video. So if you did, don't forget to hit the like button. Okay, I'll create a like button for you. I don't know how that like button look like. Oh, I wanted to create a thumb. Okay, so this is thumb. Give the like button and make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. And if you have any comments or doubts, please ask. I'll be very happy to explain that. Okay, thanks for watching. Bye bye.
Hello friends, this is Rupesh and I'm watching C Peanuts video series on C++, and today's topic is overload typecast in C++. So you might have seen overloading binary operator, unary operator and all sort of operators. Now today we'll learn how to overload typecast. So let's look at the points now. So there are no need to typecast implicit data type. Yes, this is first point because we don't have to give explicitly a typecast for implicit data types, because compiler knows that very well how to do that. And what do I mean by implicit conversion? It means converting integer into double. It means you're assigning something which is double d is equal to x, and this x is somewhere integer. Okay, so compiler knows this very well, that how to convert this x of integer type into double type. But when it comes to the user-defined data types, you need this overloading. And we'll see with this dollar and rupee example. So here you can see that we have a rupee class, which is Indian rupees, and this is a dollar class, consider it a US dollar. So what I want is, I will be converting dollar into rupees. So this is nothing but a wrapper for this rupee, and this is a wrapper for this dollar. And rupee constructor and dollars constructor. This should be R here somewhere. Okay, it's my mistake. It doesn't matter. So what we want from dollar to rupee. Okay, so let's implement that. So as you can see that this is just simple rupee class and dollar class. Let's create some variables, dollar $d, and let's initialize $10 in that. Okay, and let's create a rupee class and R, and don't initialize anything. What we want to achieve is something like this, R is equal to D, and this is perfectly fine. You would like to do this and you don't want to have any special function for this. You can include that function inside your class, and that's what we are going to learn today. So as we are going to convert dollar into rupee, we have to give the definition inside dollar, because dollar should be knowing how to convert itself into rupee. So this is the syntax for that. And notice this is very interesting syntax. Operator rupee, and you will return rupee, but after converting, so dollar into whatever the conversion rate is. So it can be 71, I mean for now it is 71 point something, let's make it 71.5. Or do one thing, we can have some function like dollar to rupee exchange rate. This is a really very big function, I know that, but it makes a good sense to create this function. So this function will return what is the exchange rate. Okay, so double, double, and it will return 71 point something 5. So anyway, even this is also a static number. Just assume this function is getting this number from somewhere from the exchange, okay, which is an authentic place to get this number. So for now I'm just placing this as a constant number and just to return that. Now let's compile this. So it has compiled successfully, but you didn't see anything, right? So let's see $.print and rupee.print. So if you'll print this, let's compile it again. I'll make it little smaller so that it will be good. Yeah, see, we have this dollar equal to 10. We are printing D first. So this is 10, and now this one is 715. So we have successfully implemented typecast in our class. Okay, so let's try to understand how it is working. So what we have here is, we have this $D initialized with 10. So we have a $D object which is holding $10. Okay, and now you initialize this D into R, and this R is of type rupees. So this conversion should happen automatically. So you have given this conversion operator. So few points to notice is you don't pass anything inside this. This is first point. And second point is you don't give any return type. This is very important point to notice. In all other overloadings, you would have noticed that you was giving return type and then this operator keyword, and what operator you are overloading, then this bracket, okay? And then your rest of the code, okay? But this return type is not given when you are overloading typecast. And why it is not given? Compiler trusts you on that if you are typecasting D into R and you have overloaded that typecast, you would return that type only. So this is kind of trust compiler have for you. And this is just one temporary object we are creating here and passing whatever the dollar is this D holding. So this dollar is associated with this D and D is holding $10. So 10 multiplied by whatever the exchange rate is. So exchange rate is 71.5 multiplied by that, it will call constructor of rupee. So here it will pass 715 and you ended up assigning that into rupee, and this is what you are doing by just simply printing that, and you successfully converted that into rupee. And similarly, if you want to convert rupee into dollar, see, we converted dollar into rupee, but if you want to convert rupee into dollar, you can do that. How? Just by giving the dollar typecast here. Okay, so that's kind of a homework for you. And this is the time to summarize this video. So if you have learned something new today, don't forget to hit the like button, dude. And make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos. Bye-bye. Hello friends, this is Rupesh and watching C Minutes video series on C++, and today's topic is overloading operator new and operator delete in C++. So what are the use of new and delete operator? New will get the memory from the heap and delete will delete that, or it will return that memory to the heap. Okay, so this is the use of that. Now by overloading this new operator and delete operator, what we are going to do is we will give one sort of layer before actually going to the heap directly. It will call a function and that function will internally call the heap. Okay, so we'll see that. So let's look at this why point, why we overload new and delete operator. Actually, overloading new and delete operator give developer more flexibility for heap allocation. We'll see this, what is this flexibility. I have few points other than these points. So let's discuss these points first. So there are two different types of overloading. First is local overloading, which is inside class or struct. So if you have overloaded new and delete operator for some particular class or a structure, then it is called local overloading. And if you have overloaded for global scope, I mean not for class and structure, then it is a global scope. So that is called global overloading. And these are the syntax for overloading new operator, and this is the syntax for overloading delete operator. We'll see that, we'll create the program and we'll understand this, why it is like this. But for now, let's just go for the points. So the fourth point is both new and delete operator are static member functions. If static member functions means it cannot have this pointer inside it. You remember, if you have watched my previous videos, there I have explained that how actually this pointer is passed inside member functions if they are non-static member functions. But it is a static member function, so you will not get this pointer inside those functions. But you don't have to worry about that. Actually, if you will forget it, then also it doesn't make any problem because we don't have to write static keyword. It is automatically static. What I mean to say is, if you want to create some member function static, you have to write static at front of that, right? So this is one delete operator prototype, and if you want to make this static, you have to keep a static keyword here, right? But in this particular case, like this new and delete case, you don't have to do that because it is implicitly static function. And the fifth point is, don't forget to overload for array version of both new and delete. So if you have integer pointer x and you have new int, and let's suppose you want the array of 10 size. So this is different than the normal new operator. Actually, it will call this also if you have not given the overloaded array version, but it's always good to give that. And another point is, if you are overloading new operator, you should overload delete operator. So these are some convention we should follow. We'll see that. So the sixth point is, we can have multiple overloaded new and delete operator functions. This is kind of cool. You know how to overload functions, right? If there are two functions, function fun, and this is taking integer, and let's suppose another function is taking some object, maybe derived d, then these two functions are different even though their name is similar. So how they are different? They are different just because they are taking different parameters. So exactly, you can overload new and delete. Similarly, you overload different functions. I mean the common functions. Okay, and we'll see that as well. So these were the points. So let's start implementing this local overloading first, then we'll go for the global overloading. So let me write the class for you very quickly. So this is the class. I have already created these two functions so that we will not end up wasting so much of time in writing and all that. So let me explain what is this. This is one simple test class and it has only integer x data member. And this is the constructor, this is default as well as parameterized constructor. And this is the syntax I told you that for new operator overloading. And if you have watched my previous video, what I pushed yesterday, then you might be noticing that it is size_t. So that's the only reason I gave that size_t video yesterday. I wanted you to know that what is the meaning of this. So it is nothing but a function call. So when compiler will see this new with test, it will check, okay, we have this overloaded. So it will end up calling this function and actually it will pass whatever the size of this test class is. It is like this. It will calculate the size. So size is integer x means 4. It will pass 4 here and obviously size is not going to be negative. That's why it is taking size_t. And if you are not sure what is size_t, I have a video for that. Please go ahead and watch that. But it's not a big thing. You can assume it some integer. So we have come here. Size is 4 and this is just the printing. This is the magic. We are again doing a malloc inside this function. There is no magic at all. So malloc will return void pointer. We all know that. And it is taking what size you want, 4. So it will return this p after initializing with the malloc. Here we will have void pointer and then magically it will call the constructor on that pointer and that pointer will be initialized to this t. And then we want to delete this pointer because this is a raw pointer. We have to delete this. So we are deleting it. Now we are calling delete on t and t is of type test. So it will check we have overloaded this delete. Yes, we have. Now this time it will not call anything like it has to pass size and all. It will pass this t itself here and it will free that p. So can you see that? We used malloc for memory creation. So we have to use free for memory return or deallocation. So let's compile this and check the behavior. Don't go anywhere. I have so many points to discuss further. So the output is expected. This will call this one and it has printed overloaded new operator size. Size is going to be 4. So this is the 4 and overloaded delete operator is also called here and we are good to go. So you have seen how to overload new and delete operator in local scope. And you remember I told you that we don't have to write static keyword. It is automatic static. So you cannot get this pointer here. Let me give you the example for that. Otherwise you will forget. So this, and if we want to print this x, we should get the error. See, it is giving you the error. It is telling that outside of the non-static function. Obviously, you're trying to access this pointer outside of a non-static member function. It means this is static member function. Okay, and let me remove this and put static at front of this. Here static and static. So it will not give any difference. See, it is compiling and giving you the same output. So this static is optional. Okay, so if you know something more about this, please comment. I'll be very happy to know that. So this was about local overloading. Let's go for global overloading, and this is the point for take home. So we'll be seeing that why we use new operator and delete operator overloading. So before that, let's go for this global overloading. If you want integer pointer x is equal to new integer, then it will not call those functions. See, it is not calling these functions. And if we are doing this, we should delete x, and then this delete will also see compiled, but it is not calling this delete. Okay, so this overloading is particularly for this class. And yes, obviously you can have multiple classes and you can overload those operators inside them individually. Okay, so that freedom is there. So let's talk about the global scope. Actually, the global scope is similar. So let me just copy this and comment this. We don't need this anymore. And I would delete this also. And let's paste this. And I think we are good to go. Now if I will compile, let's go and do that. It is calling these operators for this thing. So can you see that there is no difference in making these functions globally overloaded or locally overloaded? And you might be asking, what is the point of overloading these new and delete operator? Anyway, we are calling malloc and free, right? So what we are actually doing here, it is unnecessary call. No, actually it is important. So these points are for this only. Okay. So first let me complete this video, then we'll discuss those points. So we have seen almost everything, local overloading and global overloading, and these are the syntax part, and both new and delete operator are static and everything. And yeah, we have to see this multiple overloaded new and delete operator function. But before that, we should go for this array version. So let me show you that if you will create an array of integer, let's do that. See, this is 10. So 10 into 4, it should give 40. Let's compile and check that. See, it is giving 40. So this is calling this function and this is calling this function. Even though this is array version, okay, if it is array version, then we should call delete like this. You saw that after compiling, this is calling this one. So actually it will call this, but you have the freedom to create those functions. So let's copy and paste these functions and create those array version. There are so many copy and paste going on here, right? Don't blame me for that. Otherwise it will take so much time to write all these things. Okay, we are good to go. Now let's make this array, and similarly this one as array. So if I'll compile this now, we'll get the difference. See, this is array, so this is calling array overloaded function. Even though we have these two functions, now it is not calling that because it is finding the best match for this one. So if this is array version call, it will call the array version of the new operator. But you saw that there is no need to give these versions. It can call these simple functions and it will work fine. And if you know there is some special case where this will fail but this will not fail, please let me know. I would be very happy to know that. So we have covered this also. So fifth point is done. Now we can have multiple overloaded new and operator delete functions. So yes, let's go for that now. So this is your main function. Let me get rid of this array version stuff. So we don't need this and we don't need this. And yeah, we are okay. But let me remove all these things. It is unnecessary comment. It is taking so much of space. And so this is the simple new and delete overloaded. Let's compile and check we are not doing anything wrong. No, we are correct. Now overload these new and delete operator multiple time in global scope, and you can overload these multiple time in local scope also. So let's go ahead and do that. To overload that, we can have something like this. This is integer, not 0. This is value, and this value will be assigned here. So after getting this here, we should write if this p is not equal to null pointer, then we should do something here. And that something is we have to initialize this VAL inside this P. But the problem here is this P is of type void pointer and we cannot initialize anything inside void pointer or void because void does not have any data type. So we have to convert it into integer pointer and initialize that. So P VAL. But before this we need this dereferencing. Okay, and let's compile. No, before compiling we need to pass the value, right? And we can pass this 0 from here. So let's compile now. Okay, it is working. And now if you will print this here, you will not be surprised by 0. I know that, but it's okay. This 0 is coming from here. So the thing is, you can overload this. Oh yeah, I should have copied that. So sorry. How you will overload these things if you will not have other function? I'm so sorry for that. Okay, this is done. Okay, so let's put with value here and without value here so that you will get the idea. So I know this is a little bit lengthy and you are confused, but let me clear that doubt. See, you are calling new operator function. So now there is a choice which one to call, this one or this one, but there is no choice. Actually, you are passing this 0, which is of integer type, and we have this integer overloaded function. So it will obviously call this only. Okay. It is not calling this just because your data type, what you want is integer. It is calling this because this is integer. So this is how we are overloading this. So let me just compile and check that. With value, it means this one. So it is calling this one because of this one. So when this will call this function, actually if you have some another pointer, integer pointer y is equal to new integer and delete y. So if you're just simply calling new operator without overloading with something else, then it will end up calling this one. So let's compile and check that. See, first one is with value overloaded new, then second one is without value overloaded. Okay, so I think you got the point here. We can overload these functions by giving the values here. And you might be wondering what is the need of all these things? The point is, it is provided so that you can initialize simultaneously what I'm doing here. So if you have got some value you want to initialize when you are taking all those memory from the heap, you can do that simultaneously. And people tell that this is really very good practice so that you can hide the data what you have. Because sometimes heap will return the pointer and that pointer may be pointing to some data and maybe that data is very important data. What I mean to say is, let's suppose you have logged in your system and your username and password for some application was stored in some heap location and then later it was freed. So you have that memory freed, but heap will not flush out those memories because it is time taking process. So heap will keep that as it is and heap may end up returning or providing the same memory to you. And now by accessing that memory, you can get that password. So this is a security breach. So you should not allow this from your system. So this is it. And I think we have done everything. Now let's look at this take home points. So the take home points is overloading new and delete operator gives developer control of heap allocation. And we can do the following things with the control. Okay, so actually you will get the control of heap allocation. You saw that, right? Before actually going to the heap, it is calling your function and then internally you are calling heap function. I mean this malloc function which will give you the heap memory. But you can see that it is one layer between this and this and it provides so much of benefit. So let's talk about those benefits. And yes, always remember that why we overload new and delete operator? The reason is it gives control of heap allocation. And by controlling the heap allocation, you can do so many things, and I have listed only 3 or 4 things, but you can have so many applications of this. So the first thing is garbage collection. You might have heard about garbage collection in Java, because in C++ there is no implicit garbage collection because it will slow down your process. And we as a C++ developer take everything in our control, that we will be taking the pointer and we will be deleting that. So no garbage collection is required. It is very famous in Java and it does a pretty good job, but it is a good reason for making some system slow, because it will keep on checking whether there is some free space, not used space, then it will free that space. So you can take it again back when you need that. But in C++ there is no garbage collection. But you can do that using overloading new and delete operator. What I mean to say is, suppose when you are calling here, you can make some point that, okay, I have collected this pointer here, and you can make one list what are the memory areas are used here, and you can have the list of what are the memory areas are free, because you may end up calling this delete and all more often here and there. So this delete will actually call this delete function, right? So you can have the list of deleted stuff. Actually, this is really very good thing. If you want to practice, do that. So the first thing is garbage collection. We know that. Exception handling routine. Yeah, we can attach exception handling routines with new and delete. And we have not studied exception handling, what it is. So I will not go much deeper into this. Just you remember that it is doing something with the exception handling. Or let me just remove this. Don't worry about that. You don't have to write all these things. Just keep these things in your mind, how much you can keep. So B point is gone. C point is, it can be customized that the compiler provided version don't offer. What it can customize is, we can initialize something to the whole memory what we get from new operator. And that's what we did here. You saw that, right? We got this memory from compiler using malloc and we initialized that. Okay, so this is kind of customization we get. And the third point is, so it can be used to track how much memory is not in use, and we can reuse it instead of asking from heap again and again. The idea is, I was giving you the example, right, that you can track how much is allocated and how much is deallocated. So let's suppose when you are allocating, you are making a list that how much memory do you have, or how much you have allocated, and when you are going to deallocate, actually you are not calling this free. Instead of this free, you are taking that entry inside the deleted list, so that next time when you want something, here you will call, but here you will check whether is there anything in this list, this free list, then you will directly take that pointer and start using here. Instead of calling new again, malloc again and getting that memory from heap, you can reuse whatever somebody freed. Okay, like this you will reduce overburden on the system. And when you are going to shut down the application and all that, then you can track all the pointers what you have in your hand, and you can delete those pointers altogether. Okay, so this is also one good application. You can see so many good applications are there for this, right? And the last comment is, and there are so many possibilities we can think and discuss. So if you know something other than this, please let me know in the comment section. So if you like the video, don't forget to hit the like button, dude. It will help me a lot. And if you have not subscribed this channel, please go ahead and subscribe to the channel so that you can get the notification for upcoming videos like this. I will see you in the next videos. Bye bye.